Hi everyone, I'm making this video after I finish my web exploitation series. So right now all the 13 episodes are online. This is gonna be an introduction to that. Essentially we have 13 episodes and now I will briefly discuss what each episode covers for your study. So in the first one, we talk about an introduction to web exploitation. So we discuss the main components behind modern web applications and how we got there. In the second episode, we talk about BurpSuite. So we talk about tooling and how we can use BurpSuite to do web exploitation. So to discover vulnerabilities and to perform the various attacks. And then from the third episode up until the 8 episodes, we see some of the main vulnerabilities that appear in the web. These are like really good vulnerabilities to know if you want to do certifications like the OSCP certification. You need to know at least this. Of course, these do not cover all the possible vulnerabilities in the web, but they are the main vulnerabilities that you should focus on at the beginning of your study path in web exploitation. So we talk about SQL injection, and in this I introduce the concept of injection attacks. Then we talk about directory traversal, file inclusion, file upload, command injection, which is similar of course to SQL injection. However, the context is different because SQL injections attack a database while command injection attack a server, the command execution on the server. And then we see cross-site scripting, which is a client-side vulnerabilities that attacks the browser, essentially, the browser of the clients. After those main attacks, we see some enumeration. In particular, we have 3 episodes of enumeration, which are enumeration of files and directories, enumeration of virtual host. So I explain the mechanism of virtual host in the HTTP protocol, and finally enumeration of HTTP parameters. So this is how you can understand if there are extra parameters, for example in a page, through the usage of various tools such as Wfuzz. And then in the last 2 episodes I show how to do brute force attacks using a tool called Legba, very powerful tool. And finally, in the last video, I show how to perform this attack called DNS on transfer attacks, which happens when we have a vulnerable configuration of a DNS server and it allows us to obtain the DNS zone of the server. So with this kind of knowledge, you should be able to do, as I said, certifications such as the OSCP. This is not all the knowledge you need to work as a penetration tester in the context of web exploitation. However, this is a really good solid foundation, and after you know all of this, getting the rest is gonna be much easier once you understand very well all of this. So I leave you to the rest of the series. I hope it's enjoyable. If you find it interesting, please share with other people. Please let me know if you have specific feedback on what I can improve on or stuff like that, and that's it. Enjoy the series. Hi everyone and welcome to this new video. In this video I will give an introduction to the world of web exploitation. So you can think of this video as a web exploitation 101 in order to introduce all the technological components, all the main ideas that are behind the web, both as a technology, so like the web as a technology, and also as a way to do security on the web. Like, how do we assess the security of a web application? How do we think about the security of a web application? And what are the main methodologies and tools that we need to use in order to explore a web application on the security context, on the security point of view? So like how to do a penetration test on a web application. I hope the video is enjoyable. If you have some feedback, please leave it in the comments, and if you want to support me, just subscribe to the channel. Thank you very much. So to start off this discussion, I wanted to use a vulnerable web application. So this is a web application that was written to be vulnerable with some basic vulnerabilities. And the application is running on my computer. It is this SecureBank, an open source project in .NET Core with some security flows. So that's the basic idea. And if you're interested in playing with this application, I will leave the link to the GitHub project from which I took it. So essentially you go to GitHub, you go to this URL, and here you have the source code of the application. This is extremely useful when you want to learn these things, and to run it, it's really simple. If you have Docker, just install Docker and then you can execute this command where you do docker run. then you do -d to put it in daemon mode, then you open all the ports, so you connect the ports of your host machine with the ports inside Docker, and then you send a bunch of environmental variables for the login, for the admin credential, and then you just write the name of the image, which is currently loaded into the Docker registry, so you will download the image and you will start the container. And once you start the container, you can just go to the URL localhost in order to view the web page. And this is gonna be our starting point for talking about the web. So let's go. Now, the first thing that we need to talk about is the main architecture. So like the web follows a client-server architecture. This means that we have two distinct components. We have a client and we have a server. So anytime we have these two components, we have to imagine that the client is a piece of software that is used to obtain information from the server. So the client is the one who consumes the information, while the server is the one who provides the information, who provides the client the information. So here there is an exchange of data between client and server, so they communicate. And the way they communicate is through the network, specifically using TCP. So using a TCP connection, in this video I will not talk about TCP, because web applications are built on top of TCP. So we will assume that you already know what TCP is, but to say it very fast, TCP is a way to connect a client socket to a server socket so that you have a reliable point-to-point communication, so that anything that is sent by the client to this socket arrives at the server, and vice versa. Anything that is sent from the server to these sockets arrives at the client. So this is our basic assumption. It's sort of like you can think of as a file. You write bytes to this file, but the one who receives it is maybe on the other side of the world because it's your server, and vice versa. So that's the idea. So at this point we know that we have a client and we have a server. Now anytime you have two components like client and server that are like literally computers but far away from each other, and they communicate through a network protocol such as TCP, if you actually want to build something robust on top of it, you actually need to define an application level protocol. For example, if you know FTP, well, FTP is a protocol built on top of TCP. SSH is also another protocol built on top of TCP. Well, for the web, there is actually the HTTP protocol. So for the web, the creators of the web choose to define the HTTP protocol as the most important means of communication between client and servers. This means that, thinking back about what we said about clients and servers, the idea is that the client will make HTTP requests in order to obtain information, and the server has to respond to those requests with HTTP responses in order to provide the client with information. And if you use a tool such as Chromium, you can actually open the DevTools with Ctrl-Alt-I, Ctrl-Alt-I, and we can go to networks, and if we refresh the page, here we see a bunch of requests being made. Now these requests are all HTTP requests. For example, look at this. This is the request for the HTTP localhost, for the main page of the application. However, we can actually see, so let's see if we have... This is really not that clear actually, because it's kind of confusing the way that Chromium puts it. So another way to look at the requests in order to get used to this HTTP protocol is by using the command line command curl. I like curl. I can do curl-v to print out the HTTP headers, and I can do HTTP localhost. And let's see our responses. So the response I get here is a bunch of text, but if I go up above, here, right after I did the command, here it printed get/http101 host user agent accept. So this is an example of an HTTP request. As we can see, it starts off with a verb like get me this. And the question is, what do you want? So the next thing after the verb is actually the resource we are interested in. For example, in this case, we are interested in the /resource, which in the world of the web, it means give me the page that sits at the root folder of your web server. Then we put the version of HTTP we want to use. We put the host, which identifies which particular web application we are interested in. We put the user agent, which identifies who we are. For example, we are curl, and what kind of documents we will accept. So this is an example of an HTTP request. And as you can see, this request is actually written using ASCII, which means that HTTP is an ASCII-based protocol. It's not like TCP, IP, Ethernet, and so on and so forth that have byte encodings, have particular byte encodings which you cannot read directly as text. Well, with HTTP is different because you just have text. So this is why it's an ASCII-based protocol. And notice here the response of the server. It says, okay, here is the version of the server, the status code 200, and then okay. So it's sort of like, okay, I have the resource, I'm giving it to you. Then the server tells us the type of the resource. So this resource is text/HTML. And we will talk about HTML in a little bit. And then it also gives us the encoding of the response, the date of the response, the server, which is Kestrel, it's just a type of server, and how we want to transfer it essentially. So that's the idea. And then we get the entire response. So this is the content of the response. And to understand what this content is, we actually have to talk about what is HTML. Because at this point we said, okay, look, we have a client and a server. They communicate using the HTTP protocol, which is an ASCII-based protocol. But what do they exchange? What is the data format they exchange? Because remember that HTTP is just the protocol they use. HTTP is just the protocol they use for communication. It does not define the data that is inside HTTP messages. So to actually understand the data inside, we have to talk about HTML, because when the web was standardized, it was choose this HTML, this language was choose to be as the main language for data exchange in the web. Now, what is HTML? HTML is exactly what we see when you use a browser. However, the thing is that the browser does not make us see the raw HTML code. We do not see that specific code. What we see rather is the rendering of the code, the interpretation of the browser of that particular code. Now, how do we actually see the code itself? Well, we can just click with the mouse and we do View Source Page. Here I have written it in Italian, visualizza sorgente pagina. We click on this and this is actually the HTML code. Now, as you can see, HTML is called a markup language. So remember this term, markup language. What does that mean? It means essentially that HTML is used to give a structure to the documents, to give a structure to the information contained in the documents. It means that, consider if you have just a raw paragraph with some words with no structure. Well, in this case, it would be hard for the browser to understand what are the various elements. Is this a navbar? Is this a paragraph? Is this an image? Is this whatever? If we have no structure, it's really hard to display the information accordingly. Therefore, what HTML allows us is to define the main structure of all the information contained within the document. And of course, here we're talking both about the data and also the metadata. And in particular, HTML is characterized by these elements, and each HTML element starts with a tag. So for example, this, with these angular brackets, HTML closing angular brackets, this is a so-called opening tag. If we go at the end of our document, we have a closing HTML tag. So every opening tag has a closing tag. However, there are some specific tags they just open, they never close. And this is an example. For example, the meta charset tag, which defines the encoding used to encode the document. So it's like UTF-8. So this does not close, it just opens. So as I said, this is an element which is opened by one tag, which is the meta tag. So here is the name of the tag. And inside a given tag, we can have so-called attributes, which define the specific characteristics of the tag. For example, this meta tag has the charset attribute, which is defined to be the string value UTF-8. And you can just keep reading the HTML to find other elements. For example, you have the body, we have the head, we have the title. Now notice that when the page renders, the title is actually used and is put on the tab. So the string that is put on the tab is taken from the title. If we change that, also the title in the tab is gonna change. So the idea is that the browser, which acts as the web client, the HTTP client, receives from the server an HTML documents and it renders these HTML documents according to the meaning of the various tags. And so that's the basic idea of HTML. And why is it called HTML? It's called HTML because it's called Hypertext Markup Language. Now, as I said, markup language means that it gives a structure, hypertext, because in any HTML documents, we can actually link to resources belonging to other HTML documents. For example, consider this element. This is one of the most important elements in the web. This is called an anchor. And one of the attributes of the anchor is this href. This is a reference. This is a reference to another website, to another HTML documents. It could also be a reference to another type of document, like a PDF document. The basic idea is that when I load the page, this page can link to other pages. And this is how the web is created. I mean, the web gives us this sense of linking, right? The basic idea is that essentially I have one document, HTML1, that points to another document, HTML2, that points to other documents, that point back to the original document, and so on and so forth. So we create this web of documents, and those who consume the documents are the browsers, the clients, and those who serve the documents are the web servers. And so this is sort of like the general idea. However, it's not this easy, because in terms of client languages, there's not only HTML. HTML, as I said, gives the main structure of the document. However, there is also two more languages, which are CSS and JavaScript. Now, when it comes to CSS, it is used to define the style of the page. This is because the structure of the page and the style of the page are two distinct things. For example, the fact that everything here is in blue, and it has this font size, and it has this in bold, and things like that, they have nothing to do with the actual structure of the document, because the structure just gives me that this is like a sort of title, this is a navigational bar, this is an image, and this is like a big paragraph, and this is a link. This is the structure. The style is how I want to display this structure to the actual user. And to define this style, we actually use a CSS-like language. So it's a totally different language, which has nothing to do with HTML. And for example, in this web application, we can see actually that it defines a style tag. And within this style tag, we can actually put a CSS code. So CSS code is completely different from HTML code. We have various attributes which define, for example, the font size, the family, the color, the radius, and there are other complexities and models regarding CSS, which from a standpoint of security is not really that interesting, because from a point of user experience and business, CSS is really important because it sort of allows you to have a unique style for your website. But in terms of security, the style of the website is the least interesting thing because it doesn't change the security of the website. And for this reason, there's not much to say about CSS. We can just skip it altogether. However, a very interesting language is JavaScript. So as I said, the web has three main languages client-side, which have HTML, CSS, and JavaScript. Now, initially, the web did not have JavaScript. Initially, I think it did not even have CSS. You just have ugly HTML pages. Then they introduced CSS to make them look more stylish. And then they introduced JavaScript. Now, why was JavaScript introduced? Well, if we think about our web page, without JavaScript, it's just gonna be a static document. It's sort of like a PDF. You can read it, but it never really changes. So like once you download it, it's gonna be the same all the time, no matter what. And we can actually view the live form of the documents in a so-called DOM. So the DOM is called the document object model. And it is an internal representation constructed by the browser of the HTML document. As I said, the HTML document gives the structure to the information. Now this structure is read by the browser and it constructs a DOM, a document object model, which you can think of as a tree. So for those who studied computer science, this is like a typical tree with various nodes, and this live structure created by the browser is the DOM. So this is the DOM. Now, if we have no JavaScript, this DOM will never change because it is completely static. It never changes. People have introduced JavaScript, and this is why JavaScript comes in, because they wanted to actually modify this DOM on runtime during the usage by the final client. So they were like, wait a sec, we have this DOM, but having this DOM static does not give us much benefit over, for example, PDF files and things like that. We want to change this DOM. We want to make it dynamic. And so this is where JavaScript comes in. JavaScript was born as a language to interact with the DOM, to change the DOM depending on the user, depending on the server, depending on the status of the application. JavaScript is a language that is used to interact with the DOM and to change dynamically the structure of the HTML. And for example, in this page here, if we just go here, just view source at the end, I think we have some JavaScript here. For example, this jQuery, which is a JavaScript framework, it is a JavaScript library, more like library. And we can see this is like JavaScript code. And there's a lot of JavaScript code because during the years, people have made various sort of like libraries to create easier interfaces. And so there's been a lot of things built on top of JavaScript. For example, React.js, so React.js, AngularJS, Vue.js are just three main like framework. I mean, React is more like a library, but like ways that underneath they just use JavaScript, but they built a lot of complexity over JavaScript in order to create like user interfaces faster and more efficiently and things like that. So the web has exploded in terms of client-side JavaScript a lot over the years, but basically the basic idea of JavaScript is pretty simple. It is just a language that you use to interact and modify the DOM during the execution within the browser. This means that JavaScript originally was just executing within the browser. So far we focus on the client side and we discussed the three main languages client side, which are HTML, CSS and JavaScript. We did not talk much about server side, and now we will focus on the server side, and we will end this video by analyzing some flaws that can arise server side, so some server side vulnerabilities, because those are the easiest to understand. So in the discussion so far, we have a web client, our browser, and we said that we have a web server. For example, an open source server is Nginx. It's more of a reverse proxy, but people use it as a web server. I use it as a web server, so it can be used as a web server. Another open source web server is Apache. Maybe I can bring specific videos on how those web servers work, but the general idea is that we have a client, for example Chromium or Chrome, interacts with the web server. Now, actually, this is not true anymore. This is much more complex than this. This was maybe true in the early days of the web. Right now, what is going on is actually that behind the server, you actually have a web application. So you have the concept of a web application, which is divided from the concept of a web server. There is a distinction between a web server and a web application. Specifically, what is this difference? We need to understand it because security is mainly done on web application, not on web servers. Now, in terms of components, the web server is the software component that handles the HTTP request and response. So he handles the incoming request and he gives it to the web application, which then processes it semantically depending on the content. So like the job of the web server is just to give out files essentially, is to take the request and give out files. If you just want to have a web server with no web application, what do? You just create a folder, like maybe a public folder, and within this folder you just put HTML files. Like you can put an index.html, you can put some CSS, and things like that. For example, and this is called a static website. It's because it is just served by a web server. There is no web application logic going on. For example, consider my personal site, this leonardodamiano.xyz. Now, if you look at the source code, this is a simple HTML asset that sits on my server. It's literally a static file, which is the same for everyone. It doesn't change who you are. You can also go into the blog, and it's the same thing. It never changes. It's always the same. This is a static website, which is only done through a web server. I have no web application giving out this thing because it's just a bunch of HTML files. Now, what's the issue here? When people started to understand this technology, they were like, okay, perfect. I can have a server which handles which hands out the same information to every client. So like every client sees this page, it's the same for everyone. Now, what's the problem here? The problem is that I might want to build an application which actually sends specific information depending on the client. So it's sort of like I have client 1 interacts with my web app, and it receives a specific answer, A1. Client 2 interacts with my web app but receives a different answer, A2. For example, consider banking. We have a web interface for our bank accounts, but if we are different people, we're gonna see different data because we're gonna have different balances and things like that. This means that now the response we get has to depend on our particular session, on who we are, and on the interaction that has happened between our particular client and the server that is running on the server side. This means that a simple web server now does not suffice. It is simply not enough anymore. And so what people did essentially, they were like, okay, the web server is the component that handles all the HTTP stuff. So HTTP stuff is the web server. The web application instead is the application that handles the logic contained in this HTTP request and response. So for example, I might have a login request. So when I go give the login, my client asks for the login page, the web server asks the web application, and the web application gives back to the web server the page to be sent back to the client. Then I use my credentials, and once I use my credential, a new page is constructed. Essentially, this means that with web application, the web pages that are exchanged through the web server are dynamically constructed. So here we have a different form of dynamicism. I don't even know if you write like that, but the idea is essentially that with JavaScript, we have a client-side dynamicism, meaning that the DOM changes, so the page rendered by the client changes, but the information received by the server is the same. Now we have a server-side dynamicism where it is actually the page itself that changes. So like the bytes I get from the HTTP response changes depending who I am. If in this form I use admin1 or admin2 or user1 or user2, I'm gonna have a different response from the server. So like for example, in this case, some credential were like admin, so this is like a basic, and then the password is also admin. I log in with these credentials and I get a specific page. So this is still HTML for sure, but this HTML is private to me. No one else can see this. In order to make this possible, the web application has to implement a security mechanism to avoid other people to read my stuff, to read my HTML page. So this is the basic idea of web applications. So to give a quick recap over all the elements we talk about web clients, so like browsers, we talk about web servers, we talk about web applications, we talk about HTML documents, we talk about CSS style sheets, we talk about JavaScript files, and we talk about essentially dynamicism client-side thanks to JS and server-side thanks to web applications. So we talk about a lot of stuff. Now, how do we put all this stuff into practice? Well, the idea is that the main vulnerable components that we want to analyze are exactly web applications. Because I'm not saying that web servers are not vulnerable. Sometimes they are vulnerable. For example, if you find a specific payload, like a payload in the URL, that makes the web server crash or gives you remote code execution on the web server, then you are attacking the web server. However, typically, what is much harder to exploit are the web servers, because web servers, they are fewer than web application, and typically they are very well analyzed by the open source community, like Apache, Nginx. As I said, I'm not saying you cannot find vulnerabilities on web servers. I'm just saying it's much harder, and you need to be more expert to do that. However, when it comes to web application, this is no longer true, because everyone can write their own web application, and generally web applications are much more complex than simple web servers. Now, when it comes to web application, there are a lot of areas where things go wrong. For example, we just did a login, right? Now, the login procedure is a really critical procedure for the web application. Why? Because we have to remember, I did not say it, but essentially we have to remember that HTTP protocol is stateless. Stateless. Now, this is a really key component of HTTP. What does it mean, which is stateless? It means that for every request and every response, the web client and the web server, they have no idea who they are interacting with. It's sort of like every time they have to begin from scratch. There is no past recollection that that particular message belongs to this particular session. It is stateless. There is no state that is shared during the communication between client and server. What does this mean? It means that if we actually want to log in, we need to implement the concept of a state, because we need to say, look, I give you my credential once, and then while I keep using the web application, I must be the same client. I must be that particular client, the admin one, who has, for example, 10,000 euros. So it must implement the concept of state. Now, how does it implement the concept of state? Well, the idea is that we use cookies to do that. So typically applications use either cookies or JSON Web Tokens, but for example, this application uses cookies. How do I know? I can go into the dev tools, I can go into application, into cookies, and notice here I have this session ID with a specific value. Now, what happens if I remove this cookie? So I remove this cookie, I refresh the page, and I'm out of the application. I do not see anymore the admin page with my admin transaction. So the application is actually implementing the concept of state. And to do that, I have a login. I also have a register a new user, and so on and so forth. So let's go back to the admin. And let's log in to the admin. Now, most web developers have this idea that the only way that one can use a web application is through the main interface. So for example, here I have an interface, I have transaction, I have store, I have search, things like that. So they think that everyone can just use the main interface. What they are not remembering is that actually between the browser and the server, it is not me just pressing buttons. Underneath, that technology is actually exchanging HTTP messages. It means that technically, I don't even need a browser to interact with the server. I just need to craft specific HTTP messages. And this is really key. So the basic idea essentially is that by crafting specific malicious HTTP messages and by sending them to the server, we are actually testing the security level of the server. Sometimes it happens that the client, the default client, the browser, does not allow you to craft specific messages. However, we as malicious actors can, because as we said, HTTP is an ASCII-based protocol. Even if it was not ASCII-based, we would still be able to send specific messages to the server. We have full control over the data we send to the server. It is the responsibility of the server to validate that data and to make the proper checks on the various aspects of the application. For example, previously we did a login. Now when we do the login procedure has to do with the authentication part of our web application. It has to authenticate us. It has sort of to establish that we are actually that particular user. How does authentication work? Typically through passwords. Like passwords are like tokens to enable authentication. I authenticate you because you give me the password for your particular user. And so that's the general idea, but there's also other types of checks. For example, there are authorization. There is a concept of authorization. Authorization is not who I am, but rather what can I do with my rights. For example, if I log in as admin, then I shouldn't be able to view the balance of another user, right? I mean, that's the general idea, because I should only be able to view my own balance. Because if I go and view the balance of other people, that's a break of privacy. That's a leak in privacy. That's a break of confidentiality of the application. The application does not offer confidentiality in that case. That is called an authorization bypass, essentially. I'm bypassing the authorization mechanism because maybe they are just not even there. And so this could be problematic. Okay, so at this point, the question is, okay, how do I modify these HTTP requests that our browser sends to the server? Because right now, if I interact with the application, I'm only bound, like I don't see the traffic. I have no control over the HTTP traffic. However, as we said, there's no one stopping me from actually sending to the server the specific HTTP messages that I want. So that's the idea. How do we do that? We use tools. We use proxy tools, and one such tool is BurpSuite. So it is given by PortSwigger. It is developed by PortSwigger. It is not open source. There is a professional version and also a community version, and you can just download for Linux, Windows, or Mac. It is written in Java, so I just suggest you just download the jar file and you execute it directly with your Java environment. So I assume you already have Java installed. For example, here I have version 21.02, and the way you execute it actually is like this. But here I have a specific environmental variable that you don't really need to worry about because it's just specific to my setup. So you can ignore this. The command is java jar and then the name of the file you download from the official site of PortSwigger, and all these other flags are just to deal with the output and the error. So you can just execute it like this. You wait a little bit and it starts off. So it says that this is not being fully tested with this Java runtime environment, but we don't really care. It's gonna work anyways. So we just wait a bit and it starts off. So when it starts, the community edition does not allow you to create projects. So you just have a temporary project in memory. And then you can use configuration file. I'm just gonna use the default because we don't really care about that. So what does this tool allow you to do? Well, the tool is pretty powerful. And the idea is that we have a proxy here. It's defined here, 127.0.0.1 port 88. So the idea is that now our browser will not talk directly to the server. Before it was like this, the browser is directly connected to the server. What we're gonna do right now is we're gonna do a sort of man in the middle where the browser actually connects to BurpSuite, which then connects to the server. So it's gonna be our man in the middle, but we control this man in the middle. So this is not dangerous. What this allows us to do is it allows us to change on the fly any HTTP request and see what changes. So if the browser generates a valid HTTP request, the one that does not create any problem, we can simply change it. We can change specific parameters of the request in order to create problems for the server. In order to actually test if the server checks server side if things are good, if it validates parameters, if it protects against common attacks, and so on and so forth. That's the basic idea. Now, to actually use BurpSuite, we need to connect it to the browser. So there's a communication that has to be established between the browser and the BurpSuite. Now, in terms of BurpSuite, once we launch it, we actually do not have to change anything. The most important thing we have to remember is this interface. This is where it listens for incoming HTTP traffic. Every traffic that is sent through this proxy is sent to its original destination, so it really acts like an invisible proxy. However, everything is logged by BurpSuite and we have control over it. So this is very, very useful. Now, the command I use to actually create the browser and to connect the browser with BurpSuite is as follows. So I can close this tab and I can go here. This actually is the command. So we launch Chromium with a bunch of flags. The user data flag is just to use a new data directory. Then here I have the proxy server. This is where I say, look, you have to send your data to this proxy server, which is the proxy server where Burp is listening. Then here I say, ignore any TLS related certificate errors. And here I say, proxy bypass list loopback, because if I do this without this flag, then Chromium will not send to the proxy all the requests that go to localhost. However, I also want the request going to localhost to pass through the proxy, so I have to say this. So I take this command, I just execute it, and here I see the browser, and notice now that this history tab is actually filling up. Now if I go to localhost, notice now that localhost, I get the queries on localhost. So in this history tag here, in this HTTP history, I'm getting all the requests that the browser is making implicitly. Now, I did not see all these requests before because they were happening beneath, they were happening within the browser. I did not see them. So like we can see that there are also redirector, Google accounts and things like that. Now, if you actually want to focus only on the requests that go to localhost, we can go to target and we can say, look, I want localhost to my scope. And then here, I want to say, look, I want to only show items in scope, where the scope essentially is defined by localhost. Notice that now only the requests that are mapped to localhost are actually shown by BurpSuite. And a very cool thing is how we can see actually the request and the response. Look at this. This is the request and this is the response. So we see both of them very easily at the same time. And we see the actual HTTP request and response. For example, when we went into the header, we did get/host, a bunch of other stuff. This is the request that the browser actually launched. Before we saw the curl request, now we see the browser request. And this is the response of the server. So we have like a 200 OK and then all the HTML code. All the HTML code, which we can also render within this render tag. And that's the general idea. Now, what can we do with this? Now, this opens up the possibility for a lot of interesting stuff. So for example, let's do here a login. So here we do a login and we see, oh, look, I'm getting the page login. Perfect. But this is just a get. This is just to get the HTML code for the login, which is this one. This is the HTML code for the login. Perfect. Now we can actually use the credential that we have for the login. And we see, so for example, we can use admin at SSR, this one, and then admin as password. Now notice, what we can do here is we can intercept the request. We can do intercept is on. Now, anytime the browser makes a request, it goes to Burp, and Burp actually stops. It does not send directly to the server. So I do login. Now, I have the request here and it is not sent to the server directly. And notice here that now I see that it is a post and I see a JSON body that contains a username and a password. I can do forward or I can do drop. If I do drop, nothing is gonna happen because I will never send this request and so I get nothing back. So I get an error, the request was dropped. However, if I send it again and I do forward, I'm actually giving it to the server and I get another request to go to transaction and now I go to transaction and then I get another request to go to profile image and another request to get the transaction and another request to get the available funds and so on and so forth. Now I'm getting all the requests the browser is making and I'm stopping for them. If I remove intercept on, I just let the browser do its own thing, so like I don't bother it essentially. Now another cool thing, for example, let's do a logout. Let's do a logout and let's try to log in again. So let's remember it was admin and then admin again. Another cool thing that I can do is I do intercept on, I do login and then do action and I say do intercept response to this request. So here I'm also intercepting the response from the server. So I say forward and notice here, this is the response from the server. When the server gets my request with the OK credential, with a good credential, it replies with this other JSON in which I see a cookie. And this is one of the ways in which sessions are handled by web application. So I can actually intercept the responses too, and I can change content of the response so that I can modify the way my browser behaves because I actually change the response of the server, or I can forward it to my browser to have a normal thing essentially. So there's a lot of cool things that we can do. Another cool thing that we can do, for example, is once we go into this history, into this HTTP history, here we can just take a particular request that we like. For example, let's take the post API out login, which contains the credential, and then I go and I put Ctrl R and I send this to repeater. Now repeater is a module of BurpSuite which allows me to send specific HTTP request. So here I can say issue again this request, and here I get the response. So notice here that I'm getting the response many times because I'm sending many times this request. And here maybe I can change the password. I change the password and it says bad request because the credentials are no longer correct. So here I have admin and this, or I can use other credential. For example, there is this other credential which works. So it's like here I have to say, so here the credential is tester at srrd.io, and the credential is test. Here I say, and okay, this is actually bad. I have to say tester, so tester at ssrd.io. Maybe this does not work for some reason. Test. Okay, this does not work. The only one that works is admin and admin. And so these are all the tools essentially that I need to actually start to understand some of the basic vulnerabilities present in this web application. And this is essentially why BurpSuite is a really useful tool when it comes to analyzing the security of a web application. We always have to ask ourselves, how is the web application implemented? Okay, we talk to the HTTP protocol, we send HTML documents, but what kind of information can I access? How is the authentication implemented? How is the authorization implemented? And things of the sort. Now, to end this specific video, I will show some simple vulnerabilities that you can find, and I will leave other vulnerabilities for later videos. Just tell me if you're interested in this sort of content where I just go around and I explain the stuff that I know regarding penetration tests, and in particular web-based penetration tests. So for example, notice this application. So remember that from the login procedure, if I go here intercept, I intercept on, I do the login, here I put okay forward, I see this form, I put the credential which is admin srrd.io and the password is admin. I do login, here I get this first post which is the request sent by the browser to actually login, I do forward, then I see this /transaction, so now the browser is asking for a specific page. Now notice that to authenticate here I'm putting a cookie session, so I'm putting a cookie, session id equals this particular value. This is the way in which the web application implements state, because as we said, HTTP is stateless. However, if in all requests of the same session you put the same cookie, cookies are mechanisms essentially which allow you to handle state within an HTTP communication. And one thing that I did not mention about HTTP, of course, is the headers. So these are called headers, and we can have many different headers which contain meta information about the communication. So for example, this cookie header is used to handle the state in a web application. So that's the idea, and of course we also have the body, but in this case there's no body, it's just a simple GET request. If we do this forward, then we have this other request which has to do with Google internals, we don't care about this. Then we do this API user profile image. This is interesting, but I don't want to zoom on this for now. Then I do this API transaction with a lot of parameters. Notice here, there are a lot of parameters here, whatever. And then I say this, get available funds. Now notice this particular transaction. At this point in the application here, I do not have my current balance displayed on top here. However, so let's put this into the repeater tab with Ctrl R. So now it's put on the repeater, and now I'm just gonna forward this. Notice now that I actually see the amount of money that my account has, which is 10,000, I think. So if we go into repeater, we have this request. Perfect. Now, how does this request essentially is structured? Well, if you analyze it directly with Emacs, so we can zoom in better. So we go here. We go into content, we go into notes, and we say we just want to analyze this particular request. So notice we have a get, this is the resource we are requesting, and there is this question mark. Now this is a parameter. This is a parameter, and essentially say user is equal to admin. So it's sort of like we are asking, get me the available funds of this particular user. Now, anytime you have this API, you have this sort of like API design, the thing you have to ask yourself is, but wait a second, why do I have to specify the user over this particular parameter? Can't the web application just use my cookie? which was assigned to this particular identity during the login to actually understand who I am, shouldn't a more correct design be just do a get over this to get my current funds? Well, to actually test this idea, what could be our hypothesis? Our hypothesis could be that if we put the email of other users, we might able to get their current balance. So how do we do this? Well, first I would say let's create a new account. So we do logout and let's see we have to stop the proxy, so proxy intercept off. Then we do sign up. We create a new mail, testgmail.com or whatever. The password is gonna be password. The confirm password is going to be password, and then I accept, I register, and it says, we have sent a confirmation link to your email address. So here it says that it sent a confirmation link. However, what if I do testgmail.com password, we do login, and I'm into test.gmail.com. So it actually did not want me to confirm the thing. Notice that now here I have 100 balance. So here I have 100 balance. Now, if I go into the HTTP history, so here I have this new token, it gives me this new token, and here I have this get available funds user equal test user equal test at gmail.com. Now, how can we test this? Well, the idea is that this cookie is valid for admin, right? So this cookie is valid for admin, and here it replies with a JSON balance 10,000. What happens if I put test gmail.com and I do send? I get balance of 100. So I was able to actually see the balance of a different user by knowing the email of that particular user. This cookie should not be authorized to access information on this particular user. Yet, using this API, I'm actually able to obtain this information. Notice here, this cookie should actually be used only for this test at Gmail, right? And this should be the original request. However, if I put here the admin one, so I say admin at ssrd.io and I say send, notice here, I actually get the balance of the admin account. Now this in technical terms is called broken access control. Broken access control. And it essentially says that this API does not check authorization. It does not check that the user I'm actually authenticated with has authorized access to that particular information. Another test that we can do actually is, what happens if I just remove the cookie? I literally just remove the cookie. So like right now, there is no authenticated information. I say send, and I still get the same answer. So this means essentially is that whoever user I am, even though not authenticated, so any user of the web can just send this GET request and obtain the balance of any user just by knowing their email addresses. So like test at gmail.com and I get the balance of test, which is 100, or the admin one and I get the balance of the admin one. Now this is a really dangerous vulnerability. If you have a banking account, you don't want this to happen. It's very, very critical. So this will be a high risk vulnerability. So that's a general idea. Now in this application, there are a lot of vulnerabilities actually. For example, look at this search bar. What happens if I put this particular character, this hyphen? Here I say, look, data table sorting. I have an SQL injection. Another vulnerability that we have in this search, notice here, I do this title search and it reflects me back the value. What happens if I would do script alert one script? When I do search back, it's gonna reflect me the JavaScript and it's gonna execute the JavaScript. So this is a reflected cross-site scripting. Now, this is a small example over an application which was written to be vulnerable, which was written with education in mind in order to understand this sort of vulnerabilities. But the general ideas applies also to production-ready web servers, websites, web application, and things like that. So this video was like a one-on-one introduction. I was very messy about it. I did not organize well over the various concepts. However, I hope it was enjoyable. I hope you got something out of it. There are a lot of things which I did not talk about, honestly. This was just meant to be a quick introduction to the world of web exploitation. In the future, I will talk more specifically about various web vulnerabilities using this SecureBank as an example, and then I will talk more general into the structure of the web, trying to bring some theory about, for example, what are domain names, what are virtual hosts, what are URLs, resources, the various type of HTTP messages, HTML stuff, JavaScript stuff, and things like that, understanding the various web vulnerabilities. So if you are interested in this sort of content, please let me know because I will continue making such videos. Hi everyone and welcome to this new video of my web exploitation series. In the first video of the series, I went through a general introduction of web technologies and how we got to web applications, and I also showcase a little bit of BurpSuite, which is one of the most important tools you will use in web exploitation. In this second video, I want to focus mainly on BurpSuite, on how to install it, how to configure it, and how to work with it. This is because, as I said, BurpSuite is one of the most used tools when it comes to web exploitation. It is essentially a proxy that allows you to change incoming traffic to generate malicious HTTP traffic in order to test your web application. And this is why you need to be comfortable with it as soon as possible, because it's your tool of choice typically. So in this video we will see the setup and we will see how to use it and how to work with it. I hope the video is gonna be enjoyable. If you have some feedback, please leave it in the comments, subscribe if you're interested in this kind of content, and just please let me know what you think of what I make. And that's it, we can go with the video. So gonna see now the full setup, because in the previous video I went through it too quickly. Now we're gonna see all the details. Now the first thing to know is that BurpSuite is a Java application. Therefore the first thing you need is to install Java. And of course, this installation, the process of installing Java, depends on the operating system you are using, and if you are using Linux, also on the distribution of Linux you are using. In my particular case, I'm using Arch Linux, and therefore I have this very useful command, which is called, so we go into the content folder, which is called Arch Linux Java Status, and essentially tells me all the various Java environments that I have installed, and also the one active, the one default, which right now is Java 21 OpenJDK. I can access the Java compiler javac, and I can say give me the version, and the version it says 2102.0.2. So how do you install it if you don't have it? It's a simple pacman-s jdk openjdk. So that's the command, really simple. Once you have downloaded Java, and once you have access to the javac compiler, this one, then we will be able to execute BurpSuite. So the first thing we do is download BurpSuite. Now you can either download it from the official website, this portswigger.net, or more easily, I found the command that is used to download it, so you can use this one. You can do wget, this is the URL. Notice that here we put product community, because there are actually two different versions of BurpSuite. One is the professional, and the other is the community. The professional has extended features, but it requires a subscription. I think it's like a monthly or yearly subscription. Typically, when you go to work for a penetration testing company, for an offensive company, typically they pay you the license. So if you are on your own, I just suggest you to use the free version, which is the community version. For example, for the OSCP exam, you are only allowed to use the community version. So just get used to the community version, and once you get access to the professional version, you just have new feature. But the basic idea and the basic features are gonna be the same in both versions. And then we put version 2023.12.1, and then we type equal jar. I install directly the jar, which is a format used to ship Java applications because it's simply more useful. You have everything in a single file. And then I do -o, big O, and then BurpSuite. So we just download it. So it takes a little bit because I think it's like a bunch of 100 or 200 megabytes. We will see at the end, and we just wait for the download to finish. And with this we can download BurpSuite. So notice now that the download is finished and it has saved it in burpsuite.jar. So we have this new file, burpsuite.jar. We can check the file extension. It is a zip archive data. So to actually execute BurpSuite, the command is the following one. You do java-jar burpsuite.jar. Notice here there is an environmental variable at the start, and this is because of my particular setup. I'm running a tiling window manager. In particular, I'm running Emacs with EX.pvom. So it's like a particular tiling window manager, and for this kind of setup, I need this flag, otherwise the interface does not look good and it glitches out. And these final things are just to redirect the standard output and the standard error to dev null, because I don't want any error, and this final command, this final thing, is just to put in the background the process. So once we execute this, we're gonna have BurpSuite, so we can just do this. Notice here is, because the command is being put in the background, we have BurpSuite and the shell is free for us to use again. So notice what's about this. This is about the project selection. Now in the community edition, you cannot save project to disk. This is a big limitation. However, for doing single targets like OSCP machine, OSCP exam, ActiveBox machines, this is fine. When it comes for work, however, this is not fine anymore, because if you want to work, you want to save everything you do, every request you make to your target, so that if your client asks for more details about the engagement, you can just retrieve them from the file. However, if you're not working professionally, if you're just learning, the community edition is okay. So you can just skip this sign and you go to the next one. Now at this point, it's about the specific configuration of BurpSuite. So it's not about the project you're working with, but it's more about, okay, how do you want to configure BurpSuite? Because you can actually change the way BurpSuite works, and when you change this, you can save this to a configuration file, and then you can just load it. In this case, we'll use burp defaults, and then we will modify it as time goes on. And this is the idea, essentially. We can just choose a file and we can just pick our file to change the configuration. And then we'd say start burp. And so right now, finally, it is starting. So we say start, please enter, no, not load from configuration file, use burp defaults. So it's gonna start up the project. We just have to wait a little bit. And so this is the main view that we are left with, that we are given. So this is like the dashboard. Now here I put all the various tabs. However, I don't use all of them, because each tab is a specific functionality of burp. So each tab makes you work in a specific way for doing specific tasks. For example, one tab that we don't really need is the collaborator tab. This is because this functionality is only available to BurpSuite Professional. So we don't really need collaborator in the community edition. Now for those who are interested in knowing what it is and how it works, essentially it is a way, sometimes you are interacting with your web application, so this is your web application, and sometimes you're able to trigger certain vulnerabilities, but you do not see the response immediately. So the web server does not respond to you immediately. However, sometimes you might make, for example, the web server do a DNS query. So you make it do a DNS query. How to do a DNS query, you need a DNS server that has registered a specific domain. And this is where collaborator comes in. It allows you to, for example, register DNS names and to check if queries on the internet are made for that particular domain. It uses BurpSuite PortSwigger domain name. And that's the general idea. So it is used for this kind of activities, also for HTTP or SMTP. Anytime you trigger the web server into making an internet directed request that you cannot directly see, you can use collaborator as a sort of second server on the internet to check if the request has been made. So it actually requires external infrastructure. This is why it's only available to BurpSuite Professional. So we don't need this, and we can just do hide tab. So you can view the tab again if you click on this view collaborator, but in this case we don't really need it, so we can just hide it. So another thing that I usually hide is organizer and logger, because they are mostly for organizing the project, for organizing the requests and things like that. We don't really need that. The most important tab that we use is the proxy one. Is the proxy, is the repeater, and it is the intruder. And also we'll talk about target, decoder, comparer, and the extensions. So we can start off by actually stopping burp here. I mean, we don't stop it, we just keep going, and we open actually the browser, because of course, as I said, BurpSuite acts as an intermediate proxy. So we're gonna have our Chromium here, which is gonna direct to burp, and burp is gonna talk to the website, to the web application. So we introduce this man in the middle that we control, however. So this is the setup, and we introduce this man in the middle so that we can change on the fly the HTTP traffic that is sent between the browser and the web application. Now, it's really useful to have an external man in the middle so that we don't really need to change the internal logic of the web browser. We can just keep as it is. And we can just change the traffic itself, which is much easier. And so that's the general idea. Now, how do we start a browser? We start with Chromium, but we have various different flags, attributes. So for example, the first one is user.dir. This is used to make this instance of Chromium have its own data. And this is useful when we want to do penetration testing activities, because we want to separate your personal browsing activity from your work browser activity. So this is why we create a new user data, so that it does not access the data that we have on our personal accounts. And we call it PT activity. You can also say PT or PT data, something like that. Then we set the proxy server. This is one of the most important settings. Notice the proxy server here is an endpoint, an IP and a port, because BurpSuite listens to this particular endpoint, and we can check by going to the proxy tab, proxy settings, and notice here, these proxy listeners. Here we have a list of endpoints in which the burp listens to. So we can leave it not running or leave it running. So if you click on it, it runs. And essentially that's the general idea, and it also supports HTTP too. But that is not that important for now, for the basics. So we're gonna set it here, exactly here. Continuing, another useful flag is to ignore certificate errors, because when you typically use a browser, if something happens at the level of the TLS authentication, when TLS certificates are checked, the browser simply stops you. It says, look, it's dangerous, the certificate is not valid. And this can be problematic when it comes to penetration testing, because sometimes the activity that you want to do as an invalid certificate, and maybe you have to flag that as an issue. So like you don't want to be bothered by the typical protection mechanism that the browser implements to protect the users. Finally, this proxy bypass list, and we say loop back here. Now this flag is really important, because if we don't put this flag, anytime we have to test a localhost application, which is an application running on the localhost interface 1.127.0.0.1, then these requests are not proxied to the proxy set up before. Because typically Chromium thinks, well, it's a localhost request, I don't need to proxy it. However, this sometimes is needed. For example, in our case, where we test a local application, this is needed, but also when we are working, for example, with SSH tunnels. Sometimes we might make a tunnel so that on our machine, maybe the application is listening on port 1337 of localhost, but actually we are interacting with a remote application. It's just that we have to pass through an SSH tunnel where the entry port is in our localhost interface. So sometimes this is really needed. And then once again, these are just to handle standard output, standard error, and to put the process in the background. So that's the general idea. I'm explaining all the flags so that you know, because in the future I'm always gonna use these flags essentially. So let's see if something happened. I think there was a problem with tabs. Let's see. Okay, now we open our Chromium. And now notice, in the HTTP history, we already have some requests that the browser is making. So the browser is making those in the background, but already they are being proxied by BurpSuite. Now if you search something, notice here what it says. The browser says, wait, this is not secure. And here we see the actual request made for the search. Now the browser acts like this because it says, look, certificate is not valid. This is in Italian. If we go here and we check on the details of this certificate, we see that this certificate is actually not the Google's one, but is actually omitted by PortSwigger CA. This is because at this point, our browser is not interacting directly with Google servers as it typically is. It is rather interacting with the proxy. Therefore, the TLS certificate that the browser sees is not the one from Google, which is trusted of course, but rather is the one from PortSwigger, the one that it obtained from BurpSuite. What does it mean? It means that we want to avoid this error because we know that we trust BurpSuite, we know that we put a man in the middle, and so we would like to get rid of this. How do we do that? We need to import a certificate into the browser. In particular, we need to import the PortSwigger certificate into the browser. How do we do that? There are various ways. One way, first of all, we need to get hold of the certificate, and then we need to put it into the browser. Now we can say import export CA certificate in this case. We can say export certificate in their format, I think. So this should work. Or another way, which is easier, we just go to the localhost 8080, which is the endpoint where BurpSuite listens, and then we click on here, CA certificate. We click on this, we download the cert.dir, this one. So I'm gonna put it in this folder. cert, actually, I think it's in downloads, cert.dir. So notice now that we have this certificate.dir, and if we check on it, it's like there's PortSwigger stuff and some other binary encodings. We don't really care about that. What we care rather is that now we need to import it into the Chromium, and here we just do this one. So we go to the settings of Chromium. So we go to settings, and then we search for certificate, actually HTTPS, and then we look at security, then we look at gestisci certificati, which means handle certificates. I mean, this is in Italian. Notice the URL, however. We can also have gone directly to Chrome settings certificates. So no matter your language, you can just open your settings, open your Chrome actually, from any tab. You can open your Chrome and you go to the handling of the certificates. Then you go into authorities, you go into importa, and then on the file explorer, you go into directory where you have this cert.dir. You click on it, you have to do all the files, because I think sometimes it hides it. You have to do all types of file, because this is a binary encoded dir certificate, and then you click on this, and then it says certificate PortSwigger CA, so it reads it properly, and then you have to tick the one where it says consider this certificate good for trusting web servers, CD web. So you click on the first one, you say okay. Now we have the certificate, so which means that if we now go on, for example, test, notice here, there is no warning anymore. Now the warning does not block us from like exploring, but it is important to do this step because BurpSuite, we know that we can trust it. And if you check on it, now it says connection is secure, we have the certificate is valid, and we have that it is the same certificate as before. However, before we did not trust the root certificate, and now we do because we inserted it into the databases of root certificates. And you know, this has to do with TLS, with the certificate verification in TLS. I can talk in later videos about this process. It's very complex. I just wanted to show you the full procedure because you do that once and you are good. So the next time you start at BurpSuite and you start at Chromium, as long as the certificate is still in the settings of Chromium, you will be good and you won't have to bother with that problem. So this is very good. At this point, we can start the web application so that we can talk about specific BurpSuite usage. So we can start it once again with Docker, as I showed in the previous video. It's very simple. I will put this sheet with all the commands you need to set up your system in the GitHub repository. It's going to be a link down bottom below if you're interested. So all these flags, all this configuration and things like that. Now at this point the application should be running. We can check it actually with a Docker container ps. Notice the SecureBank is running and we can access it with 127.0.0.1 and that's it. So let's see, 127.0.0.1, maybe localhost 80. I think it takes some time to get started actually. Perfect. Now I can access SecureBank. This is our web application. And now we can actually start to talk about the way that BurpSuite is typically used. And of course, remember that in this video, I will talk about the way I use it. If you use it differently, please write in the comments. If you think I missed something to say about BurpSuite, also please write it in the comments because it can be useful to other people. So let's start. Notice here that we have this HTTP history tab that is it's like progressively filled up by the various requests that the web server makes, that the Chromium makes. Before we had all the requests on Google, now we have all the requests on localhost, on 127.0.0.1 and so on and so forth. Now when it comes to exploring a web application for a penetration test, it is important to just focus on the necessary detail. So the first thing to do is we need to define the scope. We need to tell, look, this history, I just want to show me only the things that have to do with localhost, because localhost is the domain I'm testing. Localhost is the scope I'm working on at this particular moment. So to actually do this, we can go into the target, the sitemap, and here we have a bunch of domain names, different domain names. Mostly they are about Google, then there's localhost, and that's it essentially. Now, as I said, we are only interested in localhost, right? So, and here is essentially the sitemap of all the resources it has found. So for example, in localhost, we have the dash, which is the index, and the auth, which is contain login, register, the JavaScript. So it's sort of like a sitemap of all the resources accessible through the HTML. Now, if we just want to focus on the localhost, we can click on the domain we're interested in, and then we can say add to scope. So this is a right click and add to scope. And then it says logging of out of scope proxy traffic is disabled. What does that mean? It means essentially that right now we don't log anymore anything that happens to targets that are not in scope. Now, once we added this item from the scope, we can also remove it, of course, but it's not that the point. We want it to keep in scope. And essentially here, notice what it says. It says logging of out of scope proxy traffic is disabled. It means that right now we don't log anymore anything that happens out of scope. So like if we go back to the proxy here, notice here. Here now the last request is that we can order them like this. So it's the 314, it's the 314, perfect. If we now make another request on Google, notice here that this history is not updated, this list is not updated, we're not receiving any more queries, even though the browser is still proxying them to BurpSuite. We just don't log them anymore, we don't write them anymore. Why? Because of this thing, because we don't log things that are out of scope. As soon as we activate the scope, we stop logging anything else. And this is really important because sometimes we're not really interested in the other request that we make while searching for our, I don't know, exploit or something like that. We're just interested in the request we make to the scope. Now notice here what happens instead if I try to log in. For example, I say login. Notice here that this request is actually logged in the proxy. So like the proxy captures it and puts it in the HTTP history, in this tab. And we can make a request for login. So email address is invalid, let's put gmail.com, login has failed. Notice that we get this login request, we get this post. So we keep getting things that are in scope, we just ignore everything that is not in scope. And this, as I said, is really, really useful. Also because you have some filter settings. For example, before we had some Google requests before we activated the scope, right? Well, we can just delete them from this list. Or it's not that we delete them, we just filter the view. What does that mean? We click on here and we say, look, I only want you to show me items in scope items, show only in scope items. And then we say apply. And notice, we remove everything that had to do with Google. This is not deleted from the history itself. It's actually part of the history, and if we save this project with a professional version, we would still save the Google request being saved in the HTTP history before we activated the scope. But now we only see in this filter the request we make to the scope. So this is really useful at the start. I suggest to always do it because otherwise you will be flooded with requests. What happens, for example, if I remove this show only in scope items and then I reactivate the out of scope proxy traffic logging? So I say re-enable, and then I go here, I make a request on Google, and notice now that I have a lot of requests. Look how many requests are made just for a simple request on Google. This is why this idea of scope is really important, because otherwise your history is gonna be filled with random requests that your browser makes, like to access these websites and things like that. So that's the general idea. And so now we discuss the importance of putting things into scope. This is why we want to put localhost into scope. And once we do that, all the requests are just like, we are just notified about the requests that are made to that particular scope, and here we can also filter it. And notice here, this is another important feature of BurpSuite, which is the ability to filter things. So here you can filter with respect to a search term using regular expression. Then we can like filter it with respect to the type of the file, images, text, HTML. We can filter with respect to the extension, And we can also like just search. We can do search is only for the professional version, so not for the community version. We can search over all the requests, over all the data the burp has for specific patterns, but I cannot show you because this is only for professional. So at this point we talk about the history, we talk about the scope, and we talk about how putting things in and out of the scope. And I just like that it logs out of scope traffic disabled. I don't care about that. So at this point we can, for example, I don't know, let's just log in and let's just capture the request. Now we can use the proxy to intercept the incoming request as follows. So we go into intercept and we do intercept is on. At this point, any request that the browser makes goes to BurpSuite, then BurpSuite stops the request and let us see the actual request. Because if we go back to the history, notice here that for every request that is logged here, we have on the left the request, on the right the response. And this can be arranged in various ways. For example, I can have the request on top, the response on bottom, or I can have request on one tab and response on another tab. Personally, for small requests and responses, I think this is fine. When they become too big, maybe this is also useful because you have the more space. This one, I really don't like this one because it's not that useful. Maybe just for comparing stuff like that, but not that useful. And notice here also you can change the formatting. So you can you can either show, like let us show, or you can also, like in this case, it keeps going. So this is how it changes with respect to the visualization. Here we see the actual special character, like /r/n, and here is the wrapping of the line. I like the wrapping on the line because it's more useful, and also like to show the actual character, the actual special character. So this is really useful, so we can actually do it here as well. And so this is the basic idea. Now, when we intercept, we are actually able to change the request, because if we don't intercept, we are just seeing the traffic, right? We are just seeing the traffic, but we have no control over this traffic. We just see the traffic that the browser creates. Now, the useful thing about having BurpSuite is that we can change the request, and we can change it how we want it. So we go into intercept is on, and then we do login. Notice here that we get the request made by the browser, and we can actually change the username and the password. We can put other stuff for the password, and then we can do forward. So when we do forward, we send it to the web server, the web server sends us the reply, and then BurpSuite automatically forwards the reply to the browser. Now there is another behavior that you can actually have, and it's that we get the request here, we block the request, we change the username, and then we do action, do intercept, response to this request. So it's like we don't only intercept the request, we also want to intercept the response. So we do this, we do forward. Notice here, now this other thing, it is the response. It is not the request anymore, it is the response of the web server. We do forward, and then we say, look, login has failed. So notice here that we can intercept both the requests and the responses, and we can change anything actually. So remember that when we actually started this application, so here I have my notes, the credentials were admin@ssrd.io. So it's like admin@ssrd.io, and then admin, and then we do login. And here we have the actual page. So this is all the request. And so notice that from this, it actually got this kind of response. So it got this kind of response. So we do a good login, and it gives us the username, the ID, the cookie, and the status OK, the set action, and things like that. That's perfect. Now, remember what we discussed in the previous video. If you did not watch it, I suggest you to go back. That we saw also this request, which is get API, user get available funds. Like, give me the available funds for this particular user. You pass the user through this attribute here, this parameter of the get request, and he gives you the balance. Perfect. Now, what we can do is, if we are interested in replying a given request and changing maybe some value, we can send this to the repeater tool. So how do we do this? We can either click on this and say send to repeater, or since this is a very common action, you can say Ctrl R. Ctrl R, send to repeater. Now repeater allows you to essentially modify this request, and then it allows you to see the new response. So it allows you to send once again the request. If we send once again the same request, we essentially get the same response. So the one that was also in the proxy, we get the same response. It's just that now the data slightly changed, because from 10, 11, 10, now we have 10, 12, 36. It's just a bit later in time. However, the useful thing about this is that now we can test. For example, you can say, look, I want to test the authentication and the authorization of this web application. Like, here I am asking for a sensitive information, the available funds of a given user. And here I have the cookie for that given user, right? This cookie was set by the application here during the login. I do a proper login and it says, look, you have to use this cookie, YWR and so on and so forth, which is the same that we use here, YWR and so on and so forth. What happens if I remove this cookie? So now I've just removed it. Now, a properly implemented web application should tell me, look, you are not authenticated to see this information. Let's send this request to make sure that this is the case. If we send this request again, notice that it replies again with OK and gives us the balance of the user. What does this tell us? It tells us that this API endpoint is not properly authenticated, so there's no authentication and no authorization. This is a typical issue of broken access control, because anyone has access to the personal information of the admin account. Now, if we had other account enrolled, for example test, we could see their balance. In this case we do not have, but if this was a valid user, we would see his balance. And notice how we use this repeater tool. So once again, a quick explanation. We saw a valid request being made by the browser. It looked interesting. We send it to repeater. We go to repeater. We modify it by changing the cookie to test, to check for the proper authentication mechanism implemented by the web application. We send it and we see that they are not implemented. And so we have an issue that we can report it to our client. This is essentially how we use the repeater tool. So for example, another thing, let's see the detail here. I don't know if this request is interesting. For the detail, get available funds, get user transaction details 1. So it says okay. Notice here it says okay, details 1. Notice that this request is already different and it seems already more secure from the blueprint of the request. Why this is the case? Because previously, in this previous transaction, we had information about the specific user in a parameter of the get. Now the question is, why should I have this information here if it should already be included implicitly in the session cookie? The session cookie should be associated to only this account, so there's no need to put it here, this information. In this other case, notice here, we do not have any information about the users, but we only have this session cookie. So what happens if we remove the session cookie on this other request? We say send, and it says found, but it's doing a redirect to out login. It says 302. This is a typical HTTP response code that says, look, I want you to bring to a new place, to the login. We follow the redirection. Here, look on top, on this button, we follow it, and we go OK, and then if we render the response, we see the typical login page. So notice here that the responses, we can actually render them in HTML. So we see what the browser sees essentially. So this means that this API, this request, is actually properly authenticated. And this is a good thing. And that's the general idea of repeater. This is how we use this tool to modify requests on the fly. Notice here also that you can have multiple requests being made and you can keep adding it, and you can also create tabs, you can create groups in which to group together different requests. We can also ungroup tabs and we can also remove tabs. So this is the general idea of the repeater, which is one of the most useful features that you will use in BurpSuite. Now another feature that sometimes I use and sometimes I don't is the decoder. And sometimes I don't use this feature because I prefer to decode it in other ways. But essentially what we can do is, for example, consider this cookie. We can take this cookie, we can put it into the decoder, and we can just paste it, and you can say, look, I want to decode this as base64. And notice here, down here, it essentially shows me the decoded version of the cookie according to base64. So I want to decode it base64, I get this. I want to decode it URL, I get this thing, which of course does not make sense because this is not proper URL actually. And here there are a bunch of formats: URL, HTML, base64, ASCII, hexadecimal, octal, binary, gzip. In this case it's HTML. It's base64, sorry, this is base64. And notice here we can view it as text mode or X mode, and we can keep decoding it. So we can keep doing this essentially. So that's the general idea. And why we can keep doing this? Because sometimes you might have to decode multiple times. So that's the general idea. Notice here that if we just like remove this, essentially, if we just remove this, actually we paste it again. Notice that when we decode it as base64, actually we don't need to decode it 2 times, here there is some structure that we see. Because for example, the first thing that we see here is an email address admin@ssrd.io. So this means that the first part of this cookie is actually base64 encoded, which can be read by anyone. And this is typically not something you should do, because session cookie should not contain client information. They only should contain a unique identifier that the server is able to recognize. If you want to have client information stored within like the browser, within the client, then you should use other tools like JSON Web Tokens typically, because they allow you to implement integrity protection, so like encryption with respect to modification. Now with this cookie, notice here that, so like to understand the structure of the cookie, what we can do is we can send multiple login requests. So I send this to repeater, notice, and I say, look, send. And notice here we get this thing, then we can send it again, so like a new request, we send it again, and notice here we get this other thing. Then we can send this to comparer, we can send this to comparer, and notice here that we have, essentially, compare words, I would say. So we can compare the words to check what changes and what is the same, essentially. And in this case, so here you cannot see it too clearly, I don't like this kind of view honestly, but essentially everything is mostly the same. The only thing that changes is the second part of the cookie. So it's this part of the cookie, which is this internal part, while everything else is the same. Now to actually see it better, I really don't like this fuse. This is why I don't really use this tool that much, this comparer. I just do it manually, so I can hide it because I don't really use it. But the idea is that we can just write it on a buffer here, one cookie that it gives us, then we can send it again the request and we write the other cookie, then we can do once again the request and we write yet another cookie, and now we can compare these 3 values. So notice similarities and differences. The first part are always the same, and the third part is always the same. This middle part is actually what changes. This means that this cookie is combining session identification with client data all in one with this separator, which is this special character. So the first part is base64. The second part seems to be this hexadecimal random number because it changes every time. And finally, this third part is always 100. So to check the meaning of these bytes, I think that we can always do whenever we can register a new user is, okay, let's try to just register a new user, just to check what's up. So we do sign up, we say test.gmail.com, the password test, the confirmed password is test, the password must be at least 5 characters long. So I say test123, test123, we see the register, we have sent an email confirmation, we do test.gmail.com and test123, and then we log in. Now if you go back to the proxy tab and we check the the post to login, and we see actually the cookie that we get here. Notice here what changes with respect to the previous one. So this is an admin account, the first one. This is a not admin account. So there's this first part, which you can actually decode it manually, base64 decode, and it says test@gmail.com. So this always seems to be the email of the user encoded in base64, and the final thing here, it's not 100, but it's rather 0. So it's sort of like they use this last portion of the cookie to say whether you are an admin or a normal user. This is why whenever when we log in with the admin, we get 100. When we log in with a normal user, we get 0. And of course, you can do multiple tests on this. So for example, you can register another user and you will see that it's always 0. And notice also that in this response, this 0 is also in the user right. So it says user right 0. It's sort of like permission level 0. You're not admin. While if we check the previous login with admin, we say, okay, this is not good. We say this. We say, okay, user right, it's also 0 in this case, I would say. However, here we see 100. So maybe this web server does not properly set this user right, I think. Because, you just have to do assumption. Now, an interesting thing would be like this. Okay, let's say that I have essentially my cookie like this. So this is a session cookie. And notice here, there's another useful feature here. It's that whenever we are analyzing a request and we want on the fly to understand the meaning of a particular section, we can use the inspector here. We can use the inspector. It says, look, this selected text has been decoded from URL encoding to obtain, so here I just want this one, to obtain this other thing where it finishes with 0. Now, what I want to test is, okay, what happens if I send this to the repeater, but I change this from 0 to 100? Does this change anything? It says okay, but in this case, the API was not really authenticated. So this is not really that useful. We need to find an authenticated API that only the admin can access. Let's try admin store, for example. Now, if you go into admin store, as the normal user, as the test account here, what happens is that we go to admin store, which is a particular endpoint of the application, and we get back to the login. So if we analyze the actual response HTTP that our proxy has captured, what we will see is that, look, I am this kind of user, I want to go to admin store and I get a found. Now, what I want to do is change this last byte from 0 to 100, this last character, to see if we still get redirected. Notice that right now we are not getting redirected and we're actually seeing the special page of admin store. So what happened here? What happened here is that I changed the last value that represented my user rights within the application. Now notice, of course, this is completely insecure because the end user, which could also be a malicious user, can totally change the right by just modifying a simple byte of the cookie. This cookie is not even encrypted, it's not even integrity protected, and we were able to do this with the decoder. Now the decoder is not really that special because there's also like CyberChef that allows you to encode and decode stuff, which I highly suggest if you don't know about it. It's just a very handy tool from going to various formats. In comparison, this decoder just has few formats, so it's really not that useful, but in general you also have that. I think that the most useful part of BurpSuite are the proxy, the repeater, and now we'll actually see the intruder, and finally we will talk about the extensions, and then we'll end the video. So at this point of the video, we talk about the scope, which can be organized in target. We talk about the proxy, how to intercept it, how to configure it, and things like that. We talk about repeater. We talk about decoder, which is not really that useful. Now we're going to talk about intruder, which is really useful. Now suppose that you have an API endpoint and you want to understand how this API responds to different requests. So you want to make many different requests, each of which with different payloads, with different parameters, with different values. A typical scenario is the login scenario. Suppose that we know the email admin@ssrdo.io, but we do not know the password. So what we can do is we can capture a request in which we just failed, like here, and then we can say, look, send this to intruder. I send this to intruder. Then the idea is that I will send many requests, but each request will have a different password here. So we can remove this session cookie, by the way. And so the idea is that here we have different types of attack. We're just going to use the sniper, which is a single set of payloads. So from a single set of payloads, we will create our new requests. And the idea is that now we have to tell BurpSuite what kind of what data to change on the request. So here, for example, you say, look, I want the password to change. So here I say add this. So this is like, okay, now here you have to put here the payload essentially in this between these two symbols. And then you say, okay, the payloads, what are the payloads? Here you can have a simple list. For example, there are many different configurations, but here it's just a simple list of characters. For example, we can say test, password, administrator, then we have admin, the test2, just a bunch of things. And then we can define the resource pool, so we can create. So this is gonna do 10 concurrent requests, and it's gonna auto throttle, so it's gonna like decrease the speed depending on the response. Essentially, that's the idea. And then we can say this is like more settings. I mean, you can configure this a lot, but the basic idea is that once we have the basic request, once we told the BurpSuite what to change of the request, and once we told it how to change it with, so the various payloads, we can just do start the attack. So this is the idea. Notice here. Notice what we got. Here we got a 313, the length, because it's a bad request. While this is a different length of the other, which is 547, because this is with the admin password, and notice that the admin password is the correct password. So essentially the idea of Intruder is to make many different requests, changing a few fields, the one we are interested in changing, and then we can attack it. Of course, I think in the community edition, this Intruder is limited, but for simple brute forcing, like when you have a limited number of possibilities, this is still very useful. So this can be very useful also when you have a resource, so you can just do discard because we're not really interested. Also maybe where you have an API resource that is accessed through a numerical ID or things like that, when you have an IDOR, these kind of things, this kind of Intruder is really, really useful. And this is why I wanted to mention it. Of course, here there are a lot of configuration, a lot of options. Most of them I didn't even test myself, but that's the basic idea of Intruder. So essentially we talk about everything. So there is sequencer, which I did not talk about. There was, I think, the comparer, which I think I talk about, but I don't really like, so I don't really use it. Now, sequencer is used to analyze the randomness of a particular element in a given response. So for example, in the login, here we have this, so let's do a login that went well. Here we have this cookie, essentially. So what we can do is we can send to sequencer, and then we can say session ID, custom location. I want to change this cookie essentially, this cookie. So I want to send this one. Okay. And then I can say start live capture. So it's going to do many different requests. I'm going to do stop. I'm going to do yes, I'm going to do analyze, and then it's going to analyze the randomness of the various responses it got with respect to that particular value. And then it says, look, at a significant level of 1%, the amount of entropy is like, it does statistical analysis. This is why I think for right now it's not really that useful for us, because it's a little bit too complex for what we're trying to achieve. So you can just not care about this sequencer. And so before finishing the video, we'll talk about the dashboard and the extension. So with the dashboard, we can see all the scans that we have activated. This can either be active scans or passive scan. For example, by default, we have this passive scan, live passive crawl from proxy, all traffic. It means that all the requests that are sent to the proxy are first processed by this live passive scan. And it's just used to, for example, fill up this target map here, to get all this information about the various resources. And I think in the professional edition, it also gives you issues with respect to the things found. For example, if by doing these passive scans, it finds an outdated JavaScript library, it will show you on this dashboard. I think in the community edition, it doesn't do this, if I'm not wrong. Essentially, this is the idea. So anytime you're working in the background, BurpSuite is doing analysis on the traffic. And it can either be passive, when it just limits itself to the request sent by the browser, or it can be active, meaning that through the scans, it can make itself request to the web server. And this can, of course, introduce more heavy processing. So this is the idea of the dashboard. I would say that in the community edition, is not really that important. So the target is much better because we already see the resources, we already see what's in scope. Here, for example, we can say show only in scope items. We can say, okay, only localhost is in scope, and this is good. Here there's like issue definition, where are the various vulnerabilities, the severity, for example, broken access control, cookie unencrypted communication, XML injection. Like this is only useful when it comes to work, and in the community edition anyway it's limited, so really not that useful. It just gives you an idea of the various possible vulnerabilities with a description, some references, and the typical severity. But as I said, not really that useful to me. And now to finish off, we can talk about the extensions, because one of the cool thing about BurpSuite, and this is a really cool thing, is that by itself is a really good engine for sending and receiving HTTP request responses. It's like a proxy you can use for penetration testing activity, but even cooler than that is that you can extend the basic engine for implementing specific functionality. And this is done through the extended BurpSuite API. So there's like an API for extension for developing specific extensions, and these extensions can be written in 3 different languages. The basic one is the Java language, because this extension interface is actually implemented in Java. But then you have 2 different wrappers which allow you to write the extension in both Python and Ruby. And this is really cool. Right now I'm working on my own free time on an extension in Python. Actually, it is Python 2.7, which is actually Jython. So it's like a Python interpreter implemented in Java that it compiles down to Java bytecode. And so this is the general idea. With respect to extension, you can see the list of installed extension. You can see the store that it contains many different extensions developed by other people. And this can be really useful when you have to do maybe a specific thing, a specific activity, and it's always the same. And you're like, whoa, I don't want to do it anytime. You can just develop an extension for it, or you can install extensions written by other people. Here you have these APIs, so all the documentation on the various modules, on the various like interfaces, how to interact programmatically through programs with BurpSuite, and that's the general idea. And then there are these big checks, which are additional scans, like additional active scans, but these require BurpSuite Professional Pro. So like every time you process your traffic, you can add additional processing workload to this request other than the default passive one. So this is with B checks. And essentially this covers it when it comes to BurpSuite. As I said, to a final recap, the most useful features that I recommend are the target one to define your scope. So you can do like, this is all the domains we saw, and these are the only ones in scope, the localhost, very important. The intruder, when you have like brute forcing attack, but this is actually, you use it less times. Then you have the proxy. So in terms of importance is target to define scope, proxy to analyze the request, proxy settings, of course, to configure the proxy endpoint, interception, if you want to modify on the fly something and see the response on the fly and modify it before it gets to the browser. Then you have the repeater, super important when you want to resend questions that have been captured by the history. You want to modify a parameter to check how the server responds to it. Then you have the intruder when you want to do, for example, brute forcing attacks on password. When you want to do an IDOR enumeration, you found an IDOR vulnerability and you want to enumerate all the documents, all the users and things like that. And then finally, the extensions, which essentially allow you to extend the capabilities of BurpSuite in a very rich way. And in the future, I will make specific video on extensions because they are really cool, and maybe we will implement together an extension for BurpSuite. If you're interested, please let me know. So this is it. This ends the BurpSuite video, and from the next video on, we can focus on actual vulnerabilities. Hi everyone, and welcome to this new video in which I will continue my web exploitation series. In particular, in this video, we will talk about SQL injections. However, to make the explanation more clear when it comes to the actual vulnerability itself, which is the SQL injection, we will take a different approach than usual, and we will actually go through all the steps necessary to understand the vulnerability. Now, what do I mean by all the steps? First, we will start with actually understanding what is SQL, why SQL was introduced, and what kind of role does it fulfill in the context of computer science. So this is like detached from security itself. It's just general knowledge on SQL. Then we will talk about the concept of injections, which actually have to do with how code is read and executed by interpreters. So of course, SQL injections are a special type of injections. However, to understand the specific type, which is the SQL injection, I think it's very helpful to have a general idea on how injections work in general. There are other forms of injections, like XML injection, which is a very different form of injection that still belongs to the same family of vulnerabilities. And in our talk about injections, we will inevitably talk about interpreters. Interpreters, which is one of the main methods that we know how to execute code through an interpreter. Once we have all these basics done, so these are like the fundamental knowledge for understanding SQL injection, then we will see two practical examples. One is taken from the DEM vulnerable web application. It is a very famous, well-known application written in PHP with the intent to be vulnerable as a teaching tool. And the final one is SecureBank, the application we already saw. So I showed these two examples just to showcase the fact that even though these two applications are written with different languages, because DEM vulnerable web application is written in PHP while SecureBank is written in C# with the .NET framework, they still have the same vulnerability, just to showcase what is the essence of an SQL injection. And at the end, I will mention other more sophisticated forms of SQL injections, such as blind SQL injections. However, for now, for starting off, you don't need to understand the blind, you just need to understand the general idea of SQL injections, and this is one of the core knowledge that you will need regardless of what you will do. If you will work as a penetration tester or if you want to obtain the OSCP certification, you still need to know these basics. And so in this video, I will try to progressively introduce them to you and to give you a general idea on this specific vulnerability. So I hope the video is enjoyable. If you have any feedback, please let me know in the comments. Just share what you think about my explanation. If you did not understand anything, once again, just write it in the comments and I will try to explain myself better. So that's it, and enjoy the video. So we can actually start off with talking about SQL. Now, what actually is SQL? And I'm gonna actually create a notes.txt file in which I'm gonna write my thoughts. So SQL. Now SQL stands for Structured Query Language, which means that it is a language to give a structured query, so like to query something. Now what does SQL query? Well, if you want to understand SQL, you need to understand the concept of databases and of a database. Now, what is a database? A database essentially is a way to organize your information in structures, in very specific structures, so that you can link the information, so that you can obtain like various guarantees on the data you store. For example, if you store your data on a TXT file randomly on your computer, you might lose the integrity of your data, meaning that your data might get corrupted by some events, some errors in the operating system. When you're working with a database, the idea is, why did people even invent databases? They invented databases because at some point they had a lot of critical information to store and they wanted to have strong guarantees on the information they stored. For example, would it get corrupted just by some random errors? And they did not want that. So they wanted to make the data more reliable and more secure and to protect it more towards any sort of like malfunctioning of the operating system and of the software in general. But then they also wanted an efficient and optimized way to retrieve information from the database, to insert new information into the database, and to modify the existing information. So like complex ways to manipulate the information within the database. And for this end, they invented a bunch of different languages, and one of these is SQL, Structured Query Language. With SQL, you can essentially do anything in a database. You can add a new data, you can delete all the data, you can modify existing data, and you can query data. So you can extract information from the data you are using. So like databases, like added in order to protect data and to optimize data access and data insertion and to optimize typical operation done on data. So of course this is like very approximated way, but just to get across the idea, why did we need a database? Why could we not be fine with just simple .txt files? Because a .txt file does not give you these guarantees. And this can be formalized if you ever follow a database class in university or on your own. They will formalize all of this data. They will have specific properties, specific guarantees. Then you have different databases, have different guarantees and things like that. with SQL, you can interact with a relational database in order to, so here I say add new data, delete all data, and here I put the word relational database. And notice here that I use the word relational database. Now, what do I mean with this? With relational database, essentially it means that we have tables that are linked with each others, that can be linked with each others through various constraints. So the idea of relational database is that you have tables. So like you can think of a database as a series of tables. However, these tables are not simply data tables. They are data tables linked together through various constraints. So like for example, I can have a table here, and then I can say, look, the rows in this table have to have a field here, which is to be found in the field of the rows of this other table. So they are linked like this. So this is the general idea. Now this is like a very general introduction. Now to get more dirty on understanding these things, because at the end of the day we're gonna exploit this language, and we will see how, I decided to bring an actual practical example of a really simple database, and I will use SQLite. Now SQLite is a very simple database that does not have a client and a server like other more common databases such as MySQL, PostgreSQL, like MariaDB, which is a fork of MySQL, Oracle. It's like SQLite is extremely simple. You can download it from your package manager. For example, if you use Ubuntu, I think you have to do sudo apt install SQLite 3. This is in Ubuntu. This is also should work on Kali Linux. I think on Kali Linux, if you just do which SQLite 3, you will already have it installed. And if you're in Arch, you can do sudo pacman s SQL3. So you can do this, and it's going to install. I already installed it, so I don't need to do it. Now, how do we use this database? It's really simple. You say the name of the command, and then you say the name of the database, like test.db. And now we created this database. So now, if you go into the file system, we will see a new file. Actually, there's nothing yet because I think I have to add some information. And if I do .databases here, I see the main database here is in content, and it is a read-write database. So I can both read and write to it. Now let's create a simple table that contains various fields that we typically found in users, like in a user table. Now the syntax, this is already SQL, it's like this. We say create table to create a table. Here we put the name of the table, here in this user. Then here we have the various fields, the name of the columns, ID, name, username, email, and password. So this means that for every user, we will have this information. We will have an ID, a name, a username, an email, and a password. And then we say the type of those fields, like is it a text, is it an integer, is it a character of 32 bytes. And so we say int for an integer, text for a textual field of any size. So here the size is not specified because the name could be arbitrarily long. And then here we say char 32 to say, look, it has to be a character of 32 bytes. So the password is exactly 32 bytes. And then here we put, for example, the specific constraints we want to apply on the field itself. So we say primary key, which is a specific constraint in relational databases. And the idea is that every row of your table has to be identified by one or more field. And this is the primary key. The primary key is the main identifier for that row. So that if you have this field uniquely identifies a row in this table. This is like ID. And then we have, for example, not null when we always need to put some value in there. So this is the general idea. We can just execute this query as follows. We paste it in the SQLite prompt, and it executes. Now, if you go back here, notice now that the file has been created with 12K because now we have the information on the table. Now, this is of course pretty simple. How do we add? So this is how we create stuff. And all these commands will be available on my GitHub, so just look at the description and you will find all the necessary links. Now to insert new values, we can use this. We can say insert into the name of the table, then values, and then we put a tuple here with the various value for the values column in order. So this is ID, this is name, username, email, and password. So for example, I can say this, and now I've inserted my data into the database. Now this is where the query part of SQL comes in, because for now we did not query anything, we just created data and we just created even more data. So this create table is for the creation of the metadata, of the description of the table, and this insert into is for the creation of the actual data, the stuff we will put into our database. Now at this point we can start to play around with SQL, with the query part of SQL. So if we want, for example, a simple query that retrieves all the rows in our database, we just do like this. We do select, like give me, then we do wildcard, here we do this asterisk, and then we say from users, and then we do like semicolon. We do this, and notice what we get. We get 3 rows, we get 3 results, where each row of the result represents a row in the database. So for example, this first row is the first row here, this second row is the second row here, this third row is the third row here. So we have 3 rows in our database, 3 results. Now before I proceed, so this is the first example of a query. This is very simple query. And then we will learn how to read this, and at the end when we exploit this query, the idea is that an attacker will be able to modify the query that is executed on the database. So instead of doing something trivial, something that the application intended, something that was intended by the original logic of the application, the attacker will be able to modify this query in order to do many different things. Of course, depending on the context, depending on the specifics of the vulnerability and of the exploitation process. There are many variables here. However, the general idea is that the attacker will have control over how this query is constructed. Now, before going forward, here I put into the database secret the password in plain text. You should never do this. You should never do this, and I just want to take this opportunity to just mention this fact, which is simple but also really important. The idea, and I can make further videos about this specific topic because it's really, really important. However, the idea is that you don't want to have the plain text password in the database. Because if you have the plain text password, anyone, by just accessing the database, automatically has all the passwords of the user with no extra effort. It's just as simple as getting the hands on the database. Now we have to ask ourselves, can we avoid this? Because in the password field, we must put some information which will then allow us to authenticate correctly the user. Otherwise, what's the point of a password field? So here we need to put some information for authentication. Now, the trick aspect is that, well, there is actually a way to put information here that will allow us to authenticate the user when we need to, and that also makes the life more difficult for an attacker. So the question is, can we avoid putting the plaintext secret in the database? And the answer is yes. How do we do that? Through the usage of cryptographically safe hash functions. So here the main idea is to use a so-called hash function that is also crypto secure, so like a crypto hash function. Now what's the idea here? Very fast. For example, consider the command SHA-256-SUM. This computes the hash function of like something, like for example sheet, and this is the result. We have 64 bytes of output. This is called the digest, and notice that if I change a little word here, the digest is completely different. So what's the idea here? Instead of putting, for example, secret like this, I think if I do this, okay, instead of putting a secret, I can give this plain text to the hash function and I get this back. I put this into the database, so I put this here, like I would put it here, for example, and then, so I would put it something like this, I would put it here, and then when the user authenticates, he gives me his plaintext password, I compute once again the hash, and I check it if the hash computed is the same one as the one in the database. Now the benefit of doing this is that now I'm still able to authenticate the user, but now if someone gets access to the database, he does not see the plaintext password, he only sees this string. And one of the cool things about hash function is that to go back, meaning to go from this long string of bytes to the actual initial text, which is secret with the exclamation point, exclamation mark, it's really hard computationally. so an attacker needs to do a lot of computational work. And I just wanted to mention this because it's always important to know these basics in order to move forward. Now the topic of this video is SQL injections, and so we will keep talking about those. Okay, so far we saw the commands to create a table, the commands to insert some value into the database, and an initial query. How do we read this query? This query is sort of like select which column you want me to show to you, from tell me the tables you want to extract the data, and then there is an extra section which is where, and here there is a condition. For example, suppose that we are not interested in all the fields, because this asterisk means give me all the fields. Let's say we're all interested in the name. Then we do select name from user. And here I just get the name. Or let's say that we are interested in the name and the password. Then we say name, comma, password. And then we get the name and the password, separated by this separator. So that's the general idea of SQL in terms of basic syntax. So like this, like some syntax. Now the where clause is really important. So for example, let's say that I want to select the name of the password from the users. However, I want to do it only for the user whose ID is equal to 1. So I put where ID is equal to 1. So I put in a condition in the where. Now, notice what happens when I put a condition in the where. Essentially, I'm filtering these rows. So like the where is to filter the rows, the select is to filter the columns, and the from is to know where to take the data from. So by putting a condition in the where, I'm like, wait a sec, I don't need all the rows. I just need the rows which match this condition. And this condition is applied on the column of the rows, for example, id. So I go into the id value and I say, is the id of this row 1? If it is, I take it. Is the id of this row 1? No, because 2 is not 1. And so this row I don't take it. The same thing applies for the 3. I can, for example, since the second and third row have the same email, I can say where email is equal test@test.com. And notice now, I think I need to put some kind of parenthesis maybe. Yes, with this parenthesis, notice that I get the second and the third. Of course, and to understand that they are the second and the third, I can also make the database print the ID. So notice ID2 and ID3. So here I'm gonna just put this stuff. Of course, this is not a course on SQL. This is just to like get used to the fact that the where clause is used to filter out the data. And this is gonna be really important because when we do an SQL injection, essentially, most of the time our injection point will be in the where, meaning that we'll be able to add or remove conditions from the where. And one of the most used payload for SQL injections that we will see later on is this hyphen or 1=1 and then comment. Now, why is this thing used? Because the idea is that I want to inject myself in this where before I have the original condition, which was controlled by the programmers. So it was very filtering. For example, we can imagine in a login, I only want to extract the row with that specific hash for the password value. But then, if I put an or 1=1, what I'm saying essentially is like, do not really care about the condition on the left, because then it goes into an OR. So the OR truth value is just, if one of them is true, then everything is true. And notice what we put on the right of this. We put an always true condition. 1=1 is true for any row. It doesn't matter the row, it's always true. And if we say like this, we get back all the rows. And this is one of the most typical approach. Of course, it must be said that doing this in production systems can be dangerous because with this kind of payload, you are selecting over all the rows. And if the database has like thousands and thousands of rows, this could create havoc in terms of bandwidth, in terms of network communication. You could like crash the server if the server has not like proper system in place to limit the number of rows it retrieves. So be careful with using this payload. But the general idea is that why do we use this payload? We use this payload because it allows us to select all the particular rows. And so like typical SQL injection payload is like this, or 1=row, because it allows to create queries like the following, which select all rows. Note, be careful on using this in production system, as the underlying database might have lots and lots of rows, and retrieving all of them can be dangerous for the availability aspect of the application under test. Of course, because when we do security, we always have to account into the availability, meaning that if we do a test and we crash everything, and for example the system is on production, then we're actually creating havoc for the business we are working with. So it's not a good thing. We have to, okay, some example of queries. We have to be careful in general. Like when we do something, we have to be aware of why we're doing this, why we're not doing something else. So like be careful on using this typical payload. So that's a general introduction over SQL. I hope, I mean, as I said, this is not like a full course. I do not have the time to do a full course. It's just that I hope I give enough basis to understand where we're going. And now we can talk about injections. Now, to talk about injection, notice how we created this database. So we started a program, and we can exit with .exit. So we started a program, and we said SQLi3 testdb. And then we started to execute some commands, like for example, .databases, or like select star from users, semicolon. So like the idea of this interaction is we do some commands which are actually encoded as text, as a string, like as a string. Then this string goes into something that is then executed. So it goes into an interpreter. Like the text that we put is interpreted by a piece of code, by a piece of software, and then the result of this interpretation, if that something else changes, is the execution of our commands. This is also the same when we work with a shell. So this right below is a shell. I can do ls. The shell receives my textual command, then it processes it, and finally it executes this. Now, anytime we are interacting with this system, we have to talk about interpretation, essentially. We have to talk about how interpreters work. And to do this, an example is to create a Python file, so hello.py, because Python is actually an interpreted language. So we can say this, this is just general syntax, we don't need to explain this. We can define the main function, and then we can say print hello world. Now what happens when we write a file like this, and then we say, look, Python 3 hello, we get our results. But what's going on underneath? What are all the steps that partake in this process? What are all the steps of this process? Now, I do not know the technical details of all the steps in the process, because Python is an interpreter written in C. So like the idea is that there is this Python program, which is an ELF binary. I mean, you can literally like just do which, you do file. Notice this. Actually, this is a symbolic link to Python 3.11, and this is an ELF binary, 64-bit binary. So this is like code that is runnable on my x86 system, x86 64. So like Intel 64-bit with x86 architecture. So this is just a binary, this is just a raw program. Now the point though is that this program, the Python 3 interpreter, takes in input a string, which is this file. So initially, it will see this as just a bunch of characters. It's gonna read the string. Now, after it read the string, it's gonna process the string into so-called tokens. And after that, it's gonna create a so-called abstract syntax tree. Now, this is getting very abstract. So like, let's start to make like a bullet point list in my nodes.txt. So how do interpreters work? First, they read some text, then they split the text into tokens. So we have this first translation, this first processing, which goes from like the raw ASCII characters into special tokens. So for example, this is like a function definition. This is like the identifier of the name of the function. This is like a string. This is like an if operator, like a conditional statement. Like we have to split all this thing, and then tokens are combined into abstract syntax trees, ASTs. And an abstract syntax tree is sort of like an abstract representation of your program. It is literally a tree where the tree comes from the computer science data structure of the tree. Now, why do we represent programs like this? Because this representation is extremely useful when we need to process it. It's like this is a structured way to represent the same program, but now we have a structure, which means we can mold it, we can change it, we can navigate through it. And indeed, the concept of absolute syntax tree is that then we transform ASTs into different ASTs for many reasons. So we can sort of like manipulate the tree to like have different properties, to optimize, to do a lot of different things. And finally, once we're ready, we execute the ASTs. So we walk through the AST and we execute each piece of the code, each node of our tree. Of course, this is how interpreters work. There are also compilers, which after they read this abstract syntax tree, instead of executing it directly, they create a different program. So like they literally compile a different program. In this case, we're interested in interpreters because when you work with an interpreter, the code starts always as text. And this is where the injection comes in. I mean, why are we even talking about all this abstract computer science stuff? Because by understanding that interpreters, they are like programs, like ELF binary programs that take in input a text, and then they execute the text by processing it. It means that what happens if a malicious attacker here introduces himself in this middle step before, like actually here I would say, so like application prepares text to be processed by interpreters. So first an application prepares the text to be processed by the interpreter. And then the interpreter reads the text and then they do all this other stuff because the input of the interpreter, and this is all that I meant to say, the input of the interpreter is always text. It's a string. It's just a bunch of ASCII characters. And the output is a computation, of course. This means that, well, who prepares the text to be fed to the interpreters? Typically, it is an application, it is the logic of an application. However, what happens if the application is not secure and it allows an attacker introduces malicious payload to text? So what happens if an attacker like puts himself in the middle of this process? So like here's the app, here's the interpreter, and here's the text that goes to the interpreter. Typically, the client should be outside of this process. It should not have access to this text. However, a malicious client can, through a vulnerability in the application, can breach this layer, this abstraction layer, this defensive layer, and can modify the text. If this is possible, it can change the computation that is actually executed by the interpreter to have different outcomes, to behave in a different way, because the client has maliciously modified the text that is fed in the input to the interpreter. It's sort of like if, I mean, just think about this, right? If a person on the internet could choose what this Python code would do and then I would execute it, that person on the internet could like extract malicious data, could like leak data from my computer and things of the sort. So this is why we need to understand interpreters when we need to understand SQL injections, because essentially the idea of an SQL injection is that you have your application on one side, you have an interpreter on another side, they are connected through some application logic, so it is the responsibility of the application to prepare the text that is then fed into the interpreter, but the application is actually vulnerable. It contains a vulnerability and it allows the attacker to modify that input text. And once the attacker is able to do that, the attacker has control over the interpreter, which is a very dangerous thing. So before actually seeing these two applications with their SQL injections, I wanted to actually talk about the interface layer between the application logic and the database. And I will use an example that I've wrote for teaching a class on like SQL injections in PHP. This is just a snippet of code. It will allow me to talk about this interaction. So this is PHP code, as I said. Now, you don't need to be super comfortable with PHP. You don't need to know a lot of PHP because I will explain this snippet of code to you. Now, the general idea is that here we include some config.php and we start the session. This is just PHP stuff to like initialize the environment. Then the server checks if the request it received is a post, because you have to think that this PHP code is executed after the web server has received an HTTP request. So it's like the client prepares an HTTP request, which goes to the web server, and then the web server is connected to PHP. So it sends to it, sort of like gives PHP the request. PHP processes it, generates some HTML, which is then sent to the web server, which then sends it back to the client. So that's the idea. PHP receives HTTP request as input and produces HTML as output and HTTP responses as output. So in this case, the PHP asks itself, okay, the request I've received, is it a post? Because if it is not a post, then I will just print out some HTML. So that's it, it's just gonna print out some HTML. If it is a post instead, it means that someone is trying to log in, because this endpoint is called login.php. So this is implemented the login functionality. So how does it do that? Well, first we check if we have set some parameters in the post. So an HTTP post can contain various parameters. In this case we check, are the parameters name and password defined with the isSet function? If they both are, then we extract them. We extract the name and we extract the password. Then we compute the 256 SHA of the password. So we are hashing the password. And notice here what happens. Here we are defining a string called SQL. It's like select name from users, where name is equal to name and password is equal to the hash password. Once the query has been constructed, we execute it on the database, and notice here we do db query, and if you don't know where this b variable is, it is because it's defining config. We can just look for it. So essentially we read it from the file name with SQLite 3. So this is where we set the db variable. And then once we have executed the query, we fetch the result and we check if the result is correct or if it's not. Now, what's the vulnerability here? Because this code is actually vulnerable, and it is vulnerable exactly through an SQL injections. Well, the idea is this. How is this query constructed? Because as I said, the idea of SQL injections is that the application takes care of constructing the string, which is then passed to the interpreter. Now, the passing to the interpreter aspect is done through this call of db query. So here, the PHP code sends the query to the interpreter running on the database, and it is executed there. So this is like, this is done. When it comes to creating the text query, to creating the textual representation of the code, this is where this step is done. So here we are creating a string, which is actually code. It is code encoded as a string. And to do this, notice that we use values which are given to us by the client. So notice, here we use two variables, name and password hash. Now, we have to ask ourselves, who gives me these values? Well, name is taken directly from the post request that the client makes, while phash is the hash computed on the password. So this means that if the attacker puts something in the password, this something is actually changed by the hash. So it means that in a way, this phash is different than name, because an attacker has complete control over name, but not over phash. He cannot control what happens after this hash function is computed. So now we know that the attacker has control over name. Now what could this do? What are the problems here? Well, notice what happens here. Just let's try to do some guesswork. What happens if, for example, if name is equal to this single column here, and we just substitute? So we take this, we substitute name with this. So I'm just gonna remove this. Now notice that the query is gonna be like this. If we execute this query on a database, so like in our previous database, for example, so like we say SQL, actually, let's see if I have, I think I have the database here. Yeah, we can directly execute on the database. If I do this query, and then do the semicolon, actually, so like notice here, it's not even gonna work because it's gonna be stuck. There is like one column too much here. Notice here that there are too many single quotes, because this first single quote is closed by the second, and there is a third which never closes, and this creates a problem for SQLite. So if you put this payload, we sort of break the query, and we can just break it. However, let's be smart about it. So let's say that I put this thing here, and then I want to comment out everything that comes after. How do you do that? Well, it depends on the database essentially, but each database is a sort of like comment symbol that allows you to literally comment everything. So for example, in SQLite, I think it is like this. It must be like this, I believe. Now, if we put inside these quotes this value, notice what we get here. So the first column, the first quote is closed, and then we comment everything else. So this dangling quote is actually handled by the comment. Let's try to execute this one now. Let's try to execute this one, where of course here for the password, just gonna put 1, 2, 3 for now because it's not really that important. Notice now that I do get execution. I do get execution here. I get nothing as a result. I think it's let's say that so I don't know why it wants me to like put something here. Oh no, because it's commented, right? Because it's commented for sure. So everything that comes after this is comment, even this semicolon. So I have to put a semicolon before actually. So I have to put a semicolon here, and now it's gonna work because the dash is the perfect. So now it executes. I get no output, right? Okay, let's make it more interesting. Let's say that I do this, and then I say the or 1 equal 1. So like this previous payload now is modified as follows. Within the quotes, I put this payload. Now let's try to read this query. So I say select name, where name is empty. So this is not gonna select any row in my database, but this or equal 1 equal 1 is gonna select all the rows because all the rows match this condition. And then the dangling quote is covered by the comment. If I execute this one, notice what I get. And here once again I have to remember actually that then before the comment I have to put a semicolon here. So like this is the final payload that we have. Notice what I get. I get all the results, which in this case is just 2 users. So that's the basic idea of an SQL injection. We already exploited an SQL injection. And in this case, it was like in my login.php. Now we will see 2 more practical examples with DEM vulnerable web application and SecureBank. When it comes to the actual setup of this DEM vulnerable web application, I have a GitHub repository, which I will link in the description, that I developed for a series I made on my Italian channel. And essentially the idea is that you can run it as follows. You can just do this. You can just do this Docker run. So just if you have Docker, you do Docker run, and it should just start. So because I have already downloaded it, it's sort of the same as the SecureBank. And this is the ID, and we can check if it is running by going into localhost 80. And so in this case here it's running, and the default credentials are admin and password. And then we are inside. Then we say like create or reset a database, and then we say login, and then we say admin, and then we say admin and password again, and then we are inside. So this application is really cool because it has a lot of modules here, and you can just do SQL injection, which is the one we are interested in doing. And here I just started Burp and I let Chromium proxy into Burp. I've showcased this in the second video of the series, so if you don't know how to do this, just go there and watch the video where I talk about Burp. So here we can just filter on only in-scope items. And so here we can see, for example, the request. This is to get the login page, it is the get. And then we say admin password, and then we log in, and notice here that I get the post where I have the actual... This is the post that allows me to get inside the application, and here I put the parameter. So that's good. Now we can change the difficulty level because this application has various difficulty levels. So we have low, medium, high, and impossible. And we're gonna see the SQL injection here. And in particular, we will see the low level and the medium level of this DEM vulnerable web application. Now let's start with the low level. What do we have here? Here we have a simple form that allows us to put user IDs. So we can say like user ID 1, submit, and I get information about that particular user ID. So I can say 2, I can say 3, I can say 4, I can say 5, I can say 6. There's no user ID with 6. So it seems like we have 5 users and we can enumerate their values. For example, if we put 0, notice that we see nothing. Now let's go into my history here. So and notice the nature of the request here. So what do we have? We have this get at the endpoint vulnerability /SQLi we have two parameters, id and submit. We have a cookie with the PHP SSID, and then we have the result page. In the result page here down, we see, what do we see? We see this form. After the form, we see this pre-block with the information with the response of that particular ID. So we can send it to repeater, Control R. We can send it again. So here we have it again. Now, how would we attack this? Well, the idea is that what are the parameters that we can work on? So in this case, we see two. You see the submit and the ID. Now, submit is typically a pattern used to for the server to understand when something is being submitted. So we can leave it as it is. It is typically not processed that much. It is only checked if it is set. So we are not really interested in this. The ID field, however, seems way more interesting. So the most basic thing you can do to test for an SQL injection is you introduce some hyphens. So for example, here I introduce one hyphen, I go send, and look at this. I get an error. I mean, the web server replies with 200 OK. However, I do not see the HTML. I see an error. I see a pre-block with an error. And this error, it says, look, you have an error in your SQL syntax. Now, this kind of messages means that the attacker, the malicious user, which was I in this case, were able to introduce themselves in the loop, in the interface between the application and the interpreter. So we change the structure of the query, and this is the only proof we need. We have an SQL injection depending on the data. This should never happen. It should not happen that with valid data we get the result and with invalid data we get an SQL error. What should happen is that with invalid data, the web server should be like, look, there's something wrong here. There is an error. It is not an HTML error, an SQL error. You gave invalid data. There's like something wrong with your data, or like I could not process your request, or maybe even better, just return no answer. Just return like we did for 0. Like for 0, here we get all is good. We get the page, but we get no result here after the form. So like after the form here, there's no result. So why with this quote everything breaks? It's because we are manipulating the structure of the query. Now, how can we exploit this? Well, like it's really simple actually. We can say, let's do or 1 = 1, and then with a comment. So this is the payload. So this or 1 = 1, and actually I want to put this into URL encoding. So like I want to URL encode this, and I can say convert section URL encode key characters. So I put it like this. So notice now in this parameter there is actually this value. It is like what, or 1 = 1, like there's a white space and then there's a comment. Notice how the response I get. I say bad request. Okay, bad request because here there is a space, of course. This is the error of the web server, not of the application, of the web server, because between one parameter and the other of the get, I put a space. I remove the space, I get 200, and I still get an error here. It's probably because, let's try maybe with this. Let's encode this character with a different comment. Okay, so like for this database, the comment character, this one, the double dash did not work, but this other character worked. I don't remember how you call it, this other character does not works. So essentially the payload, the final payload, you can see it in the inspector tab here, is this one. So with this, we are actually able to exploit this, and notice what we get here. We do not get one user, we get all the users, and we can see it visually like this. So we can say this or 1 = 1, and then this comment character and then a white space. We get all the answer. We can also do this just to get practice with burp. We can say we can activate the intercept mechanism. So I can say intercept is on. I put 1 here. Then I modify this and I put or 1 = 1 with this. And then I put Control U to, I think it's Control U to encode all characters. I do forward. And I get the same. I get all the results. So that's the general idea. Now, to finish off this example, okay, now we print all the users, which means that now the query, we can force the query to be true for all the users. But this is not really that useful, right? Like, I would want more information, like first name and surname. It's already something for sure, but it's not that much. So what we can do is we can use a different payload and we can extract actually the password from this. So how do we do that? So it's like DVWA example low. So the basic payload that works is this. Okay. Then to extract password, basic payload to extract password, what do we do? With these hyphens, now we know that we can write other SQL code. So now here, we're not going to write or 1 equals 1. We're going to write union select. So we're going to do the union between two different selects. It's like each select selects something from the database and we can union them together. We can sort of like connect them together. When we do a union, however, we have to know how many fields of the first query are called. So for example, I believe that here we have 3 fields, id, first name and surname. So we're gonna have select id, like here it says first name, surname. Let's try like this, id, let's do null, null and null, and then a comment here. So the comment is like this. Why do I put null? I put null to check if the number of columns is good. So I do submit. Look, the select, the useSelect statements have different number of columns. So actually I have less column than this. So what about 2? What about 2? Let's see. Of course, here I can also just send it to repeater like this to make it faster. And just do this. And then I'm gonna encode everything with Ctrl U. And then I'm gonna submit. I get OK now. I get OK. So like this payload seems to work. The payload with 2, not 3. So like here, it's I have to remove 1. So I have 2 columns from the query. But okay, this is good. This works. So I have 2 columns, but now these columns I want, for example, username and password. So I want username and password. Let's see, what do I get here? I get a non column. So it says, look, username does not exist. And then I try with user. And then I try with user. And then I paste it. It says user. Okay. So user, let's say id. Let's say id. Because of course, here we'd have to understand a non column in field list. Let's say null then. Let's say null. A non-column password in field list. Oh, you're right. So here I was actually forgetting from users. All this time actually. I was forgetting from users because we have to retrieve these values from the user. So like here, let's say username, password, a non-column username, union select, let's say user from users. Let's say this. Okay, now it works. So here I did many tries because I did not remember exactly the name of the columns. The idea is that first I forgot the from users. We always have to select from a given table. So this is the first error. And second, the specific names of the column. One is user and the other is password. As we can see, when we are exploiting an SQL injection, we need to know the structure of the underlying database. In this case, I sort of guessed it. And notice here what we get. I get all the data. Not only I get the first name and I get the, you see here, surname, but it actually prints the password, which is MD5 hashed. This is like an MD5 hash. And so this is the first example I wanted to show you, to showcase that you need to know the structure of the database. However, there are actually methodologies which allow you to extract, to recompute automatically the structure of the database, the name of the tables, the name of the databases, the name of the columns. So this work of guessing is actually not really needed technically. Tools like SQL Map, their idea is that they use the metadata present in the database, which like every database has tables, has like meta tables that are used, so like meta tables that are used to represent the actual tables of data. And so, like SQL Map reads data from these meta tables in order to reconstruct the structure of the actual table. Once we have the structure, we can actually use the SQL injection to get that data from the table. And so we're good, and this covers this first practical example. The final payload was like this. This is to extract password. Now, if you go into security medium, here I just want to showcase this to talk about a different thing. So notice here, we have the same sort of functionality, user ID, and then it gives me information about the user. However, it seems like we have no control over the specific user ID that I send to the server. Well, this is actually not true at all. It seems we have no control because the logic implements, because the client, the browser, implements a certain processing logic. It says, look, you have a select, you have a finite number of choices. However, we always have to remember that when it comes to the protocol itself, these messages at the end of the day have to travel through the HTTP protocol. And notice here, this HTTP protocol, the value is this ID equals 3, which means that if an attacker is able to craft specific HTTP messages, he can just change the value here from 3 to 2 maybe, right? And I get the answer of 2. Here I get, where is it? ID 2, without going through the user interface. This also means that from here, I can put like an hyphen here, and once again, I get my SQL injection. So this is just to showcase that the checks you do client-side can always be bypassed by a well-knowledgeable malicious actor. In this case, the payload to actually win is you have to do like 1 or 1 equal 1, and then you do also this commenting. Why is this payload? Because at this point we have no hyphens, actually, we have no quotes. So with this payload, we actually, I believe, let's see, we get our result. Not this here, we get all the stuff. And the payload here, so I'm gonna assign this, I'm gonna use Inspector. So this is the payload. You can guess it through like trial and error essentially. Then I say another example of DVWA. So I say DVWA example medium, DVWA example medium, basic payload. Basic payload is this one without the quotes. To extract passwords, so what do we do? Well, we put the same payload, but this time we have this union select. The structure is the same. So like notice that, so here I can just change this and notice that it automatically encodes it. I say okay, and here I get all my hashes. So this is the same. Notice that once we understand the point of injection, the rest of the query sort of like is very similar. So the hardest thing to understand about the SQL injection is where you are being injected in the structure of the query. And the cool thing about this application is that it allows us to actually see the code. We can view the source code that we are attacking. So this is the source code. This is the source code for the medium difficulty. And we can see that here is how he creates the query. Notice here. In this example, there are no quotes here that protect this ID. So we can just keep like, you can just put a white space in the ID, and that white space in the ID is automatically transferred in the query. Once again, what is the problem here? The problem here is that there's no barrier between the text that is then sent to the interpreter and the input of the user. The input of the user has complete control over the text, which wouldn't be a problem generally, like if you can control a string. It is a problem, however, when this text is sent to an SQL interpreter to be executed on a database. So that's the problem. Having done with this then vulnerable web application, we can just start our SecureBank and see the vulnerability there. And so right now I've started the SecureBank application, which is a different application written in a different language. In this case, we're talking about .NET and C#, also with the intent to be vulnerable. And this just to showcase some example application in which you can practice these web vulnerabilities. This is the Docker command that I use to execute the SecureBank. Everything will be in the final like notes.txt file. So the application now is running, and we can clear the localhost of before because we don't need it, and now we can just, like the domain is the same, and we can just log in into the application. To log in, we're gonna use the account that essentially we use to start the application. So here the credential were admin at ssrd.io, and the password is admin. And now we're inside. Now where is the SQL like injection here? The SQL injection here is in this transaction table. Notice this input field. Here we can sort of filter for the various transactions. And in particular, what happens if we put once again a quote here? It says, look, warning. Table ID while the transaction table invalid JSON response. We get an error, and this tells us like, look, we need to dig deeper. We need to understand how to get from the error situation to the actual SQL injection. Now, if we just do union, so it's like this. So let's say that we want to do like, so we do this union, so we get a lot of errors here. So instead of getting a lot of errors here, we can just take the request, which is this one. Notice how many parameters. This sometimes happens in web application. You have a lot of different parameters and need to understand the one that is vulnerable. Now, let's say here is the search one. So is there any search parameter? So search value, this search value seems suspicious. Yeah, this is the search value we need to change. So what if you put here union select star from transactions, and then here the comment. So this is the payload. Let's execute this. Notice that we get an OK, and we get a JSON response here. So we do not get an error. This is very cool. What if we, for example, do not put the comment? Notice that here we get a different response. We get the error. But if we put the comment here, we get the JSON response. So once again, this shows us that this is the right syntax to exploit this. Of course, in this basic image of the application, we only have one transaction. So even if we select all the rows, we will still have one transaction. So let's try some other payload that allows us to understand exactly if we have an injection. So here is the basic payload in the inspector. So instead of doing from select a star, let's do like select null, or like let's do select string. Like I want a single string character. If I do this, notice that here I get like an error. It's sort of like I do not have enough columns. So I keep going. Once again, I have an error. So notice this can be very laborious. So this is why you have automated tools. Let's put 2 more. Let's see. No, we still have to put more. Okay, let's put 1 more, I would say. Let's put 1 more. Nothing. We have to put 1 more. Let's put 1 more. Still not working. Let's put 1 more. Okay, this is not working. So let's go back. Let's go back and say like this. Essentially like this. So notice what we get. Okay, we get, it could also happen. So if you notice from the data we get here, the data is comprised of 1, 2, 3, 4, 5, 6. So like 6 fields, and then the rest is null. Now what happens maybe was that before we try to put all strings, but maybe what we're getting here is not a string. For example, this ID value is actually not a string, it's just a number. So let's try to take this into account, to take the answer into the account, to say, look, the first one is going to be the ID. Then I'm going to have a string, which is the sender ID. Then I'm going to have another string, which is the receiver ID. Then I'm going to have a date. So let's like 02/24/2024. Then I'm going to have a reason, which is a string. And finally, I'm going to have an amount. Let's see if this works. This still does not work. So I would say let's try to do another string at the end. Another string at the end. Here I need to put comma here. Apply. Okay, now notice what happened here. So I would say this is the amount and the reference. The amount and the reference. So notice here, we have 2 outputs now. And the second one has been injected by us. Because if we change this ID to 10, for example, notice here, this ID is 10. So like this is like really cool. It's sort of like this payload, which I'm gonna save it here so that you can use it later. So it's like SecureBank SQLI. So SecureBank SQLI, we have to actually put this payload, which is nodes.txt. So here, wait, losing myself a bit in Emacs. Okay, so this is the basic payload. Now with this payload, so now we know that we have an SQL injection. Now let's try to change it a little bit to print out some of the information, such as, for example, in the last string I want to put the version name, and I say at version as name. So let's put it like this, or let's remove this as name for now. So now if I put the at version payload, so here I'm gonna just put the at version payload. Wait, where is it? Actually, let's open it up here so that I can just use it. Perfect. Actually, let's put a white space here because it's probably needed. Okay. I say okay. I'm gonna copy this, apply changes, send. So what do we get here? Notice here. In this reference, actually, we do not have a reference, we have the version of the database. It is running Microsoft SQL Server Edition 2019 with all the information. And with this, I'm going to stop the video because it is already very long. I just wanted to showcase this last example to show that not only can you get information regarding the data of the database, you can also get information regarding the actual like a server running. For example, the database version, the folder in which the database is running. You can even get remote code execution sometimes from an SQL injections. So things are not only limited to the data itself. There's a lot of things that you can do with an SQL injection. We talk a lot about SQL injection. I'm gonna close the video now. I hope it was enjoyable. If you have any feedback, please leave it in the comments. Tell me what you think. And in next videos, we will treat other vulnerabilities. And finally, I did not cover in this video because it's already too long, but I will make a specific video on blind SQL injections. Hi everyone and welcome to this new video. In this video I continue my series on web exploitation, and in particular we will talk about directory traversal. I hope the video is enjoyable. If you have any feedback, please leave it in the comments, and that's it. We can start with the video. Also, before actually starting, if you want to know all this material on web exploitation, you can go into the OSCP repository, and here I'm putting all the links to the web modules that we're doing. So we did introduction to web exploitation, getting used to BurpSuite, SQL injection, and now we will do directory traversal. For the future, you can expect the following topics: file inclusion, file upload, common injection, and cross-site scripting. So once again, that's it. We can start with this video. So, as I said, in this video, we will analyze another vulnerability, which is called directory traversal. Now, to understand this vulnerability, we will show some practical examples. This is because to learn this kind of things, you need to practice. You need to create vulnerable environments in which you can practice this sort of stuff. So in particular here in the content, here I have a word list and a directory called Tomcat. Here I have a bunch of configuration and a bunch of different web applications. And so we will talk about a static site, a dynamic site, and how to exploit a directory traversal, some possible remediation, and how to bypass those remediation. So we can start with Tomcat. So to actually run a Tomcat server, we need to download it. So here I have the URL. So I open the browser, I go into this tomcat.apache.org/download, and here I can download this star. So I can download it from here, from the site, or I actually prefer to do it from the command line. So this is the wget command to download it from the command line. And notice that we are downloading version 8.5.99. So now I have the tar, I can open it, and now it's open it here. Okay, so now we can configure the server. I mean, there's not much to do with the server. What I like to do is simply to change the opening port, the port where the web server is listening. I'm gonna change this from 8080 to 1337 to lit. And this is the file server.xml. So you go from the main directory of Apache, you go into conf, you go into server, and then you edit this connector. So just begin from the file, search for connector, and the first connector you see, it's essentially where the server will be hosted, the TCP port in which the server will be listening in. Initially it was 88, now I put 1337, so this is for the connector. So after we change the configuration file for the server.xml file, we can make the startup script executable if it isn't already, and we do this as follows. So the scripts are in the folder bin, and to make them executable, we do chmod +x .-bin, and then we do wildcard, this asterisk, .sh, which means make all the files that end with .sh executable with a +x. So we do this, and now in bin, we have a bunch of, actually not in bin like this, but in bin like this, we have a bunch of different files to execute. I like to execute the Catalina run. You can also do the startup. It's essentially a wrapper over the Catalina sh. So we do run, and notice now what happened. Now we have the server is being deployed, so we can go here, and then we can go into localhost 1337, and we will see our web server. And indeed, if we go to localhost 1337 here, we are seeing the default page of Apache Tomcat version 8.5.99. Now, Tomcat has a lot of components, so we will not really talk that much about the internals of Tomcat. However, it is useful to just describe them in general. So essentially, we have three main components: the Catalina, Coyote, and Jasper. Now, Catalina is the container of servlet Java. It implements Java servlets and Java server pages, which are also called JSP pages. Now, Java servlets is a way in which you can write a Java code, but then connect that Java code to a web application. So the idea is that for some endpoints, our web application will execute Java code to process the request of the client. So this means we will have an application in which the backend part, is written in Java. And this is typically the case for enterprise applications. Now, if you have maybe a small server, you can write that in Python with a backend in Flask in Python for a small API. However, if you have a big infrastructure, if you have like an industrial application, or if you just have an enterprise application, which is typically what happens most of the time, you either have like .NET or Java. So like you have typically Java, and there is this technology of Java servlets which allows you to execute Java on the backend in order to construct the final response that will then be sent back to the client. Now, of course, which means that we have a backend, so the backend is dealt with this Catalina. Now, Coyote instead is the HTTP connector of Tomcat. It is the interface between the TCP socket, which receives HTTP request, and the Catalina component. So like to actually get into the execution of Java servlets and of JSP pages, which we will see later on, the component which deals with the HTTP protocol, we could say sort of like the web server, is Coyote. So it supports the HTTP 1.1 protocol. It listens on a TCP port and communicates with the Tomcat engine to process the request and send back the responses to the client. So we have here the client, which is implemented technologically through a browser. The client sends HTTP request, like it talks about the HTTP protocol, to Coyote, which listens on the TCP port in which this HTTP connection is built, because remember that HTTP is built on top of a TCP socket, and then Coyote talks to Catalina. So essentially talks to Catalina, and of course, Catalina, there is also Jasper in this. Now, Jasper is used for the compilation unit for JSP pages. Now, what are JSP pages? These are Java server pages, which is a technology that allows you to have in the same file HTML assets, HTML, CSS, and JavaScript assets, which are typically handled, rendered, and processed by the browser, and also Java code. It's sort of like a way to combine these two technologies. What do I mean with that? Well, here I have an example. So here I have an example of a JSP pages, which is going to be vulnerable, and we'll try to attack that essentially. So if we go into web apps, and then we go into dynamic app 1, and we read this index.jsp, this is a JSP-like file. And notice that here it contains import statements which are processed by Jasper and compiled into Java bytecode, which is then executed by the JVM, the Java virtual machine, and here we have other Java code. And notice that this Java code is inserted into these special tags, which are processed by Jasper once again, but then you also have typical HTML. So like this is like a typical paragraph, and here we can say like it works, a typical H1 header. So JSP is a way to combine HTML with Java. Now, in this example, I do not have Java servlets, so I do not have a full Java servlet example. This is just to showcase the basic technology to exploit the path traversal, because this is what we have to talk about essentially. So how do we get this application up and running to discuss the things for the vulnerability? So I have this folder, which will be available in my GitHub, Web Apps. The idea is that if we go into the official Apache Tomcat here, we have this Web Apps folder with a bunch of different directories. Now the idea is that we want to remove all of this directory. So we can do rm-r with all the names of this directory. And then we want to copy from the previous web example, so it's Tomcat Web Apps, we want to copy these three applications. So you want to just move the application of Web Apps, these three, which is Static App, Dynamic App 1, and Dynamic App 2. You just want to move it on the Web Apps folder within the Apache Tomcat server. So now, the Apache Tomcat will contain these three things. And if you do a tree, just to showcase the directory structure, we have web apps with these three applications. Now, if we open once again the browser here, and we do a refresh, we get a not found because there is nothing in the root directory right now. However, we did put stuff into the web apps, it's just that they are in specific folder, like for example in static app, which is gonna be our first application that we will analyze. Now if you go into /static app, notice what happens. Now here we are loading an HTML page, so it's a simple HTML page. And indeed, if we go into the static app here, I'm gonna open a terminal here in the bottom. If you go into web apps, static app, notice here that what is the structure of the directory in the operating system. We file this index.html, a favicon, a CSS, a folder called files, and a folder called image. If you go into the image, here I see a bunch of different folders, icon purple, icon black. They are just PNGs, so they are just images. If I go into the files, I have a file test.txt. I open this, and it's written just hey. Now, why did I want to start off with this example? This example is to showcase what is the main functionality of a simple static web server and web application. Because when we have a simple static web application, the backend part actually does not really exist. The backend part processes nothing of the requests of the user. So we have the front end, which is the browser, which is the pieces of technology that the clients interacts with, makes requests to the backend, but in this case the backend does not really exist. What is there instead is just a web server. It's just a process which tries to look if the file requested by the user exists in the underlying operating system. For example, when we do a request to the static app here, notice that essentially we are getting the index.html. Notice here, we do into view source, we're getting just the same file. Here I can open it from the operating system or from the file returned by the web server. These two files are the same. And if I look into the other files that are present here, like for example, so here let's open another terminal. Here I have favicon.png, so I do favicon.png. Here I just get the icon. If I go into the image, if I go into the CSS, I do CSS main.css. Once again, here I just get the file. Nothing fancy about this. This is a static site, meaning essentially that we cannot do much. The most dangerous thing we can do is maybe we can try to find some sensitive file. Like for example, this test.txt. Now this file just contains an hey, but if it was some sensitive data, this could be dangerous. So in these sort of situations, the most vulnerable thing you will find is just some sensitive data exposed by the web server, because anything that sits on this directory is by definition exposed to the web server. So this is not really a vulnerability, it's just how it works. If anything, it can be a vulnerability if someone puts sensitive data in here. And this is the basic functioning of a web server. We give it a directory from the operating system that lives on the operating system, and we just expose to the TCP port over the HTTP protocol so that HTTP clients like the browser can request the files. So here there's really nothing vulnerable. And this is also to say that if you have to host some personal website or something and you do not need to do any sort of processing, then just use a static website like this one, because it's gonna decrease the attack surface area of your application. The only component here that executes codes is actually the web server. It's Tomcat itself, which is reading the HTTP request and reading the file from the operating system. There's no extra backend, there's just the code for the web server. If that is vulnerable, maybe you can craft a specific HTTP request which triggers some sort of vulnerability from the web server. But this typically requires to read, understand the source code of the web server, which is not trivial. Today we will see simpler vulnerability. And the idea is that, okay, we see this static app. What about the dynamic app? Here I have dynamic app 1, dynamic app 2. Let's try to analyze the dynamic behavior of the application without seeing the source code. So let's say I go into dynamic app 1. It says it works, need a file to read. Start with me. My name is index.jsp. Now to you, which param is it? So this sort of like, it challenges us to understand, okay, it's like, it needs a file to read. So it's asking us for a parameter, for some kind of data that the user has to give to the application. This means that this application is dynamic in the sense that it processes the data we send with Java code. And now we can actually start to talk about directory traversal. Because if we said that the objective of the web server is to get a folder and expose it to the HTTP protocol, to the web server, to the public, to everyone who can access the web server, the directory traversal has to do with what kind of files are we allowed and authorized to access. Because if it's just the public file, then this is not a vulnerability. However, if I can somehow force the web server to read and give me files that are outside of this directory, like for example, private file, for example, the passwd file of Linux, the shadow file of Linux, some configuration file with sensitive credential or sensitive data, some kind of source code file. Now, if I'm able to ask like files that are not in the public directory and therefore that should not be exposed to the internet, then I have a directory traversal. Now in this case, of course, it requires a parameter. How can we find this parameter? Now this introduces the idea of fuzzing. Now fuzzing is a technical word. It is used in many different contexts. In the context of the web, the idea is that an HTTP parameter is typically symbolized with something like a question mark and then something here. So, for example, you can put question mark user equals me, and this is a parameter. Now, of course, we need to understand how the parameter is called before we can actually exploit it. And the process of understanding how the parameters are called is called fuzzing, because essentially we have no idea which is the name of the parameter. We can use word lists, which have common names used for common parameters, and we can just try to make a request with those different names to see if something changes. So the idea is that we're gonna make many requests, and we're gonna see if something changes depending on the name of the parameter. Now to do this, we can use Wfuzz. So this is something that I used. So what we can do is, we can just, here I have a word list, a simple word list, and I've made sure that this word list contain also the parameter that is of interest to us. So for example, this word list is not that long, so we could do id equals test. Nothing changes, so we go into action equal test. Nothing changes, so we go into password equals test, and so on and so forth. You get the idea. But of course, we want to automate it, because otherwise we're gonna waste our entire lifetime to do this kind of thing. So how can we do it? Well, we can create a Python environment with Python 3-m vm. So this is a Python virtual environment. We can activate the environment with .vm bin activate, and then we can install pip3 install wfuzz. So we can install wfuzz. Once we have installed wfuzz, we can actually use it. How do we use it? Well, the idea is wfuzz -w, we put the word list, then we put the URL we want to fuzz. It's localhost /1337, which is the listening port. Then we say dynamic up1, and here we put, here's the keyword, here we put question mark fuzz equal test. So essentially the idea here is this one. So this is the code essentially. So let's try to open a bigger shell so that it's more clear. So this is the entire command. And the key point is this: we put fuzz in capital letters. Now that thing is gonna change depending on the words in the word list. So this is like similar to password cracking, but it is used in the context for fuzzing the name of parameters. Now, if you execute it like this, notice what we get. So of course it gets command not found because we need to activate the Python environment. So we activate it in this other shell too, and then we execute it. Now notice what do we get. For each payload, we have the response code, all 200, almost all 200. Notice what happens with the payload file. We will come back to that. Then we get the number of lines in the response, the number of words, and the number of characters, and the payload used. Now, why does wfuzz give us all this information? Well, the idea is simple. If we trigger some kind of code execution on the backend because we guessed correctly some kind of parameter, maybe the web server will behave differently from the typical static version with no action. So for example, if use username, it's gonna reply us with 31 words, 19 lines and 228 characters. And the same thing will apply to title, type, ID, code and so on and so forth. However, if we reply with file, we have a lot more characters, a lot more words, a lot more lines, and it replies to us with a 500, with a server error. Now, here we do not actually see the reply, so let's go to the browser and manually let's try with file. We do file equal test. And notice what we get. We get an exception. We get an internal server error. This is a Java exception that is printed. It's a stack trace of the exception that is printed to the user. And this by itself represents a vulnerability, an informational vulnerability, because now an attacker knows what's going on with the server. In particular, we get this, Java IO exception. An exception occur processing index.jsp. And notice here, we also get the code. We say, look, path. So we get the servlet context, we get the real path, and then we do file, which apparently is the content of the file itself. We do read all bytes of this path. So it's sort of like we read all the bytes of the file in memory into this array of bytes. And then we create a string coded with UTF-8, and then we just print the string. And if we see the stack trace here, we see the class being used. So we have Apache Tomcat, we have Jasper for the JSP compilation, and in general, HTTP servlet. So like now we have all the information and we have no such file exception. So this is the root cause. This is the main exception that was triggered that created this problem. Because it's sort of like it tried to read a file named test and this did not work. Now, once we have this code, what we can do? Well, the idea here, we do not have the full code, but what we can assume from this code is that, so the client gives as a parameter the name of a file, and the server, through this dynamic JSP code, this Java code embedded in a JSP pages, reads all the byte of the file, it converts it into a big string, and then it prints it into the reply, into the response, into the HTTP response that is then sent back by Tomcat. So in this case, we do have a backend. In this case, the backend is processing, is reading arbitrary files, which means that if there is no sort of validation of data, and this is a really key concept, data validation, if there is no validation of data, this file could be anywhere, because notice here what happens. So here we have a specific path, then we put this dash, which is the separator of directories, and then we put the value of the parameter. So like, for example, this is test. Let's try to read the full source code. What happens, for example, if here we put index.jsp, which is the name of the file, as we can see here. What happens like now? We see it works, and then we see like view source code. Essentially, we have this first, and then we have the entire source code of the page itself. So here we have the entire source code, and notice what we get. So we have a bunch of import statements, then we read the parameter from the GET request, so we do request.getParameter. So this is how the Java code interacts with the HTTP request. And of course, these data structures are handled by Tomcat, by the various elements, by the various components. Now, I do not know the internals, but the idea is that the abstraction of Tomcat allows us to interact with the HTTP request of the client. And now this is Java code that we can just process the data sent by the client, we can process it, and we can send back the response. So what we say is, if the file is null, which means that if there is no parameter file, then we print what we read in the page if we put no file parameter. So like this text. So we remove the view source, we just print this text. Need a file to read, here are the spaces, HTML encoded. However, else, in the else block, which means that if we have a file, we're gonna read all the bytes of the file and we're gonna print it. Now notice here, there is no data validation. What does it mean? It means that whatever we get from the user, we use it directly. There is no filter. There is nothing that is blocking this value when it is used in this way. Now, what this allows us to do? Well, as a malicious attacker, as a malicious actor, we can abuse this. How? Well, remember that when we have a Linux file system, we can use the character ... to go back one directory. And if we just concatenate a bunch of ... we can go back any directories. And once we reach the root directory, at that point, we can maybe go into the etc passwd and we can read those kind of file. So like, for example, let's prepare to testing a simple file outside the outside is kind of like, for example, a secret.txt. So like this file is very secret, should be kept hidden. So like, you know, just in general, this is just a file, and notice this file sits outside the Apache Web Apps folder, because the Apache Web Apps folder is here, so this dynamic application should have only access to the index.jsp, not to the secret. However, if we go back to the directory, we will actually be able to access that file. How? Well, the payload we'll use is going to be like this. So we're going to do ... and it's going to error out, because it says, look, this file is actually a directory, it's not a file. Then we do ... we do secret.txt. Let's see if okay, it says no such file or directory, because how many times do we have to go back? So we start from dynamic app here, we go back 1, we go back 2. Okay, we just have to go back 2 actually. We just have to go back 2. And essentially, let's see, it says no such file. Maybe you have to go back 3. Okay, we go back 3 and we read the file. So here we can just say this is actually just a file itself. So this is to say that we were able to escape the public folder. The application should have been constrained to just expose files within that public folder. But by abusing this directory traversal, and notice the payload, right? The payload is very simple. It is just a way to read files. We're just abusing the fact that in Linux, a valid file path can contain these characters. So like a malicious attacker just says, look, this is a valid file path, and it means go back 3 directories and then access the file secret.txt. The vulnerability here lies with the fact that in the index.jsp, so let's say that we do Apache Tomcat, Web Apps, Dynamic App 1, index.jsp. In this file, there is no validation that goes from the moment we get the parameter, so here, to the moment we use it. Here, we do not actually see if the value is a legit one or it contains malicious characters. For example, in a path read, in a file read, in a path name, the malicious character are the ... If we are using ... we are probably doing something suspicious. We probably want to escape the jail that should be like imposed by the web server to only the public folder, to access any sort of file within the operating system. I mean, in this case, I use this as an example, but I could also access the etc passwd. It's like, it doesn't really change that much. The idea is the same. We can just repeat it many times and then we access any sort of file. So that's the general idea. This is the idea behind the directory traversals. Now, to trigger them, there are various ways. This one was a very simple example that showcased no data validation at all, with some JSP, so that you become familiar with this kind of technologies. And then I prepare another example, Dynamic App 2. Now, Dynamic App 2 is similar to Dynamic App 1, meaning that we also have a file parameter. However, notice here, we can already see from the exception. Now, the file itself, there is some data validation. If we use the previous payload, like this one, like straight out this one, that works for Dynamic App 1, this time it does not work. So like for Dynamic App 1, this thing works. For this other, it does not work. And if we see the code printed in the exception, we see a file.replace. If you actually want to see the full-on code, it's essentially the same. However, we do have a sanitization step. We do have a data validation step, which is this one. So from the moment we take the value from the HTTP request, to the moment we use it to create the path, there actually is a filter. This is a typical blacklist approach where we say, look, the ... is malicious, right? Let's remove it. So it says ... to the empty string. It means remove everything that is a ... And this data validation works with the basic payload ... because once the data validation has been applied to this input actually becomes just secret.txt. So we have blocked the malicious user, the malicious actor, from going back into the directories. Now it's just able to access the current file in the public folder. Now, of course, the question is, does this work at all times? And the answer is simple, no. This kind of approach, this blacklisting approach, is not really that good because it can be bypassable with some other payload, with some more sophisticated payload. Now, let's get the code. So this is what we do. So we are replacing, so let's say we are replacing every ... with an empty string. Now let's take the same payload. Now what happens if I have like this thing? It's like this is done, it doesn't work. Now what happens, however, if I do this kind of modification? I add 2 more dots and 1 more slash. So this is the payload I'm giving to the web application. Now let's try to reason through what is going on, what is going to happen when this is going to be executed. So this is the input. So this is the input before replace. So this is the input before replace. Input after replace. So we are going to take this ... this ... in the middle, because this one is just 2 dots. So this ... in the middle, and we're going to remove it, right? Okay, so let's remove it. We're going to remove this ... in the middle. Now notice what happened. Now, after the replace, I have created dynamically another ... It means that this time, the ... is not put within the first value, within the parameter. Within the first value we send to the web application is actually a complex, a bit more sophisticated payload that takes into consideration the rules the web application uses to sanitize the data in order to make sure that after the sanitization, the payload actually comes out, the real payload. So it's sort of like hiding what it wants to be. Instead of being directly ... it's a ... so that these first 2 in the middle are going to be removed and you're going to be left with the first 2 dots and the final slash. And you can repeat this sort of construction with any sort of payload that you remove. The problem here is that you do one replace, but you do not check that after you replaced everything, you still have maybe the malicious payload for some reason. So like this .replace actually has to be recursively. First you replace all the instances of ... and then you have to do it recursively again to make sure that no instances have appeared through the previous computation. So indeed, let's take this one and let's just change it so that we have ... and let's do it with once again with the application. And notice we see once again the file. This file is very secret and should be kept hidden. So we have bypassed the validation for the directory traversal. So this is like the small example for Tomcat. Now we will see an example with the SecureBank application. The idea, however, is this. Anytime you read like a data from the user and then you use the data you read to access a file in your file system, in your operating file system, be careful on the kind of data that your user gave you. Because if it was a malicious user, it could trigger this sort of directory traversal. Now, as a last example, we can try to discover the directory traversal present in SecureBank. So we can log in SecureBank. Here I have my burp that is already configured. I showed how to do this in previous episodes of the series. So we can log in. We have the credential, admin at SSRD. The password is also admin. And so here we have our application. Now, when you search for directory traversals, of course, the idea is what kind of endpoints accept file path or resources that have a place in the file system. So for example, here in the search field, now this search field has nothing to do with the file system, with the path in the file system. So it's highly unlikely that there is a path traversal in that particular in that particular input, simply because we have to reason about how the backend will process that input. Is this input like a file path, a resource, or something like that? It simply isn't. If you go into the source, there's not much here. If you go into search here, there is this field, and if we put something here, it is reflected back to us. This is for another video. This is actually vulnerable to an XSS, and we can test it with this script alert one. But I will talk more about this on the cross-site scripting video, so don't worry about that. This is just a little spoiler. Now, if you go into the account here, notice what happens. Okay, here I did a logout, but essentially, if we analyze the request, so let's try to analyze this request. So we have this kind of login, nothing much. This post, I put the data as JSON, okay. Then we have transaction. As I said, here we have already analyzed this endpoint for the SQL injection. We have get available funds. This is vulnerable. We also analyzed this already in, I think, the second episode. Here I can put other email addresses and I will get a different balance, but it's not important. Then we have the transaction here. There's not much. We have, once again, we have this thing. So like, let's see. Get available funds, store, portal search. So what if I filter? I want images too. Now, notice what happened here. Burp actually removed the output, which was image. So like, it removed the responses which return PNG files. Now, in this case, we are actually interested in also reading the PNG files, because when I was messing with the application, I noticed, like, look at this application, right? So this application, actually, when we log in, there is this really important part of this user profile pic, right? And this is like an image. Now notice this localhost. It's localhost API user profile image user equal, and then there is a name here. Now, and it returns an image. So like, let's see profile image, exactly. So it returns a file. Now the question is, how is this implemented? Is it implemented through an internal database where to each email there is associated like a sequence of bytes, so you never interact with the file system? What happens if I put nothing here? I have this like image of nothing. Now, what happens if, for example, I try to put a lot of this and then I read etc passwd? Notice here what do I get? I get etc passwd. Now, this kind of vulnerability is not at all trivial to discover, especially if you are beginning to understand these kind of things. But the idea is that this functionality must be implemented by reading the file from the operating system, by taking this path and using it directly to read the file system. Which means that if we put a simple payload like ... multiple times, we're gonna be able to read all the files of the application. So this is like a really trivial exploitation. However, to understand that this endpoint was vulnerable to a directory traversal is not simple, because initially you might think, well, this is not a file, this is an email address. But the idea probably is that if we go look into the Docker, so we do docker container ps, we take the Docker ID, and then we exec a shell on it. So wait, I have to say docker exec it, and then I have to say bin sh, and then we go into the secure, actually let's do bin bash, which is probably much better. Then I do into the SecureBank, and I do into the www root, into the images. So images, not really that much. So what about, so let's try to grep for admin@srsd.io. So we grep for this. We get a lot of stuff, because of course this is used very much. However, actually let's try to see. Okay, we have API here. So maybe this is store API. No, this is store API. This is different. So it's SecureBank. Then we have secure files, documents. No, secure files, images. That's it. So if you go into this particular path here, the images are stored with the email. So like the email actually represents a file name. Now this might not be like a trivial choice for the developers to implement. So they were like, look, we just put the name of the file. This is why the exploitation was trivial. We just had to put the ... because this is actually a file. It doesn't look like this, but within the context of the application, this is a file. However, this file is accessible through this API. This API does not validate the data it receives for directory traversal type of attack, which allows us to simply read the stuff of any file within the operating system. And so this is it when it comes to this specific vulnerability. I hope you got the idea why this is dangerous, why accepting path from user is dangerous, why accepting data from users is dangerous, and the need to validate the data. The same discussion, of course, can be applied to the SQL injection that we saw in the previous episode of the series. In that case, the malicious payload was SQL code. So we needed to differentiate between SQL code and normal characters to put within the query. In this case, the ambiguity is between, for example, the name of a file and a file path, or like the name of the parameter, the value of the parameter, and the path in the file system. We do not want the user to access arbitrary files in the file system because that would represent a vulnerability which could be really dangerous for a company. So we need to avoid that. And I hope the video was enjoyable. Once again, if you have some feedback about it, please leave it in the comments, and to the next video. Hi everyone, and welcome to this new video in which I continue my web exploitation series. Now, on this series, we already seen other episodes. In particular, we saw these 4. So the last one was Directory Traversal. I have to update the OSCP GitHub repository. In this video instead, we will talk about file inclusion. And we will talk about the difference between file inclusion and directory traversal. So the aspects that are similar and the aspects that are different. And in particular, I will showcase 3 different examples. So I have an example written in Tomcat with the JSP pages that we also saw in the SQL in the directory traversal episode. Then I will showcase also PHP code that we already saw in the SQL injection episode. And then I will finish the video with a third and final example using the DEM vulnerable web application example, which is an entire application written also in the PHP language. This is because when we talk about file inclusion, there are actually 2 main types of file inclusion, which are the local file inclusion, often abbreviated as LFI, and also the remote file inclusion, often abbreviated as RFI. Now for the RFI case, we will focus on PHP, while for the local file inclusion, we will focus on Tomcat. Having said this, I hope the video is interesting. I hope it makes you understand the essence of this vulnerability. If you have any feedback, please leave it in the comments and we can start to explain stuff. Now the first is going to be about Tomcat. So let's go and download the Tomcat server. I already showed how to do this in the previous episode. We just download the zip file, the tar file. So we do tar, we do this Apache Tomcat. Then we go into the Apache Tomcat, we edit the server configuration. Instead of 88, I want 1337. I want to delete port 1337. So we just change this. And then on the web apps, we remove all the default ones. We remove all of this. And we actually put the ones that are present in here. So we just put them everything here with the R because they are directories. So in particular, in this case, I just have a single example, which is the app. Once I've done this, I'm going to make executable all the binaries here that end with .sh. And then I'm going to start the Catalina run. I'm going to do this. And now I'm going to activate the browser. And we can go to HTTP localhost 1337. And we see, of course, not found because our application is actually in the /app folder. And now we see our main application. We will analyze this application and we will see that this application implements a file inclusion mechanism. So what can we understand about this page? Well, we can also start burp actually. So I'm gonna just start burp. Gonna start burp. I'm gonna activate the proxy with the browser. So now on my left I have burp, on my right I have the browser. I'm gonna put the localhost into the scope. I'm gonna go into proxy and I'm gonna make sure that only the in-scope items are logged here, are shown here. So what do we see? Well, we see this main application, you see this app, this is the request our browser makes, and this is the response we get. Notice that we have this JSession ID, and this signifies that the application is running JSP code, Java code. So this is like a Java backend. And here we see the actual page. It's a simple HTML. Notice how extremely simple it is. We can actually just view it like this, view code. Now, what's up with this code? So it's like not really well-formed HTML. This is not really standard structure HTML. We just have an H1 and header, an H4 that contains a list. So this is like a little bit weird. What is interesting to us, however, is the list. Why? Well, because this list actually contains some links, which in HTML, they are called anchors. Okay. And so if we click on main, we see this what's your name page. If we click on files, we do not see anything else. We just see the files page. Now, what's going on here? Notice at the URL. So don't even consider burp for now. Just think about the URL. When we click main, we have this parameter page, which is set to the value main. However, when we are in the files page, which is the initial page that the application loads, we see this other file, this files page. And even though in this case the URL is not set to anything, it's just the /up/, when we click into files, we get page equal files. And this, of course, is what happens here in the anchors here. So those links, they are defining a GET request to the localhost domain at port 1337 with the protocol HTTP. The resource is the /app. And then here I have a get parameter. So this is like a get parameter. It is a way in which I can signal to the web server, look, I want this request, but I also want to give you some information on how to process that request. Because remember all the discussion we had in our first episode of the Web Exploitation series. We said a static site will never differentiate the content it gives to the client because it's a static site. So it gives to every client the same content. However, if we have a dynamic backend, then the requests that are sent by the client to the backend are processed by the backend. And this means that the parameters we send, they will be interpreted somehow. They will change the content we obtain from the backend, and in turn means that potentially they can change the execution of the backend. And of course, if we want to attack this application from a security point of view, what we want is we want a malicious change in a way. We want to change the execution so that we can get information, so that we can get access maybe to unauthorized areas, or so that we can get remote code execution. This is the basic idea of what we are trying to do. And in this particular case, we are changing the behavior of the page as follows. We are like, look, if page equal to main, you give me this. Otherwise, you give me that. So it's sort of like the page it loads changes depending on this on this page parameter. Now let's try to break it to see if the execution on the backend is actually dependent upon this value. So let's try to put here like a quote, an open quote. Notice what we get. We get an internal server error. And more than that actually, we get a stack trace. It means that some JSP code that was running in the background actually has crashed, and now we can see all the details about that crash. Now in this particular case, what we see is that it says JSP file not found. So it says like it tried to read a file, but it did not find any. Now let's put here something else. Notice here what we get. We get that something else .jsp not found. So it's sort of like it's trying to access like a specific file, and the file that it's trying to access is given by the parameter. So this looks interesting. Now, as I said, if I put files, it gives me this value. Why? Because in the server, in this simple example actually, there exists a file called files.jsp. So this file actually exists on the backend. This is why we're able to process it. And if we look at the server, if we go into the background and we actually look at the server, so we go into web apps/app. So the view of the server on the server side is like this. We have the index.jsp, which is triggered when we go into the directory, or when we go into the directory index.jsp, it's the same page. And then notice that we have a folder called pages, right? Now in this folder pages, we have two different files, main.jsp and files.jsp. So main.jsp is the one that is executed when we load the page equals main, and vice versa, files.jsp is the one executed by default, and also when we load the page with the parameter page equal files. Now let's try, for example, to read the source code of this main.jsp. This is a simple page. Notice this is like Java code embedded into an HTML page thanks to a JSP engine. So here we get the parameter called username, and we say, if the username is not null, then you print to the user hi and your username. Otherwise, you print what's your name. It means that the page that we saw previously, this one, when we go into the main here, it says, what's your name? Why? Because actually here there is a second parameter, which is called username. And if we put here, for example, Leo, it says, hi Leo. Or like test, it says, hi test. So this is just to say that when we have a page, there could be extra parameters that we just don't know about. In this case, this page has a single username parameter. And this username parameter, we can actually put, for example, a malicious script alert 1. And this triggers, for example, a cross-site scripting. This is a reflected XSS. Now, this video is not about XSS. We will cover that at the end of this initial web exploitation series. However, this is just to say that we have to be careful on what we print out to the users. Now, let's go to the main topic of this video, which is file inclusion. In the previous video, I discussed the idea behind directory traversals, and I said that generally, intuitively, the idea of a directory traversal is typically the web server is supposed to be bound by the folder in which it has its public resources, like for example, this app folder. Everything that lives on the app folder is publicly accessible, but the things that are outside this folder in my operating system should not be accessible by the web server. Now, when we switch from directory traversal to file inclusion, we actually have to consider the mechanism of code execution that is done by the interpreter of the backend. So for example, in this case, let's analyze the index.js. Let's do the index. Now notice here what happens. Here we try to get the parameter page. If the value is null, which means that if we did not put anything into the page parameter, then we set a default value called files. And then we have this line, JSP include, we put the page, and then here essentially we put the folder where that file resides with the variable page value. So we say essentially, here you put page value. So in the default case, this translates to this. So here we have this files.jsp, and here we have to escape these double quotes because they are inside other double quotes. So this is like an include statement. What does this mean practically? It means that when the JSP will execute this code, it's gonna read the file, for example, files.jsp. So it's gonna read this file, and then it's gonna actually execute the JSP contained within this file in the context of the application. Now in this case, there actually is no specific JSP code, but suppose, for example, in main there is actually, and suppose that we add it here on the bottom. So we add an extra code just to prove the point, and here we put hello world, a simple hello world, which is Java code. This is Java code in JSP. So suppose that we have some JSP code. In the mechanism of file inclusion, the idea is I include my file in the context. So like for example, this is the context of index.jsp, and then I include into this context a different file called files.jsp, But instead of just taking all the characters and just putting them inside my original file, I'm actually gonna interpret and execute the JSP snippets within the files, within the files.jsp. So it's sort of like I load the code and I execute it. This is the main difference behind, between file inclusion and directory traversal. Directory traversal is simply a retrieval of bytes from the operating system, going outside the boundaries of the web server. A file inclusion instead is different because we have also code execution, which means that it could potentially be more dangerous. So what changes now? We're going to our application and going to Chromium 2, and then we say, we go into app. Notice here, this thing that I get as a user, if I do for example with burp, the thing I get here, which is this hello world, I do not see the JSP raw code. I do not see this special character. Rather, I see the result of this computation. Here I could put also, for example, 1336 plus 1. And then if I execute it again with the repeater, I get 1337, which means that actually it's not just that the raw bytes are loaded in, but rather it's the fact that the JSP code is also executed. And so this is why I wanted to bring this small example, meaning that this is called a local file inclusion. Now, why could this be dangerous? Because that's the question, also abbreviated as LFI. Now, why is this dangerous? Well, let's think about it. So in general, for example, this application is being written in a way that it says, okay, look, whatever parameter you give me here, I'm gonna load that file in and I'm gonna execute the JSP contained within it. And the fact that it is local just means that the resources I'm allowed to load have to be present on the web server I'm trying to attack. So for example, in this case, on the web server I'm trying to attack, there are only these files. So we go here, there are only files.jsp and main.jsp. There are no vulnerable files in this case. The code that is executed here is very trivial. However, what could happen, for example, if we add a third file, for example, cmd.jsp? And so at this point, we know what a file inclusion is all about. The idea is to load a file and then to execute the JSP snippet within that file in order to compute the final answer that we will give to the user. Now, in the case of the main.jsp and the files.jsp, those files were pretty trivial because the JSP instruction they contain were not really malicious or dangerous at all. What happens, however, if we introduce, for example, a backdoor, a sort of hidden file is cmd.jsp. So what happens? If we check this file, essentially we're gonna get a parameter, a value from the parameter cmd, and then we're gonna execute through the runtime exec offered by Java, and then we're just gonna output the standard output. We're gonna print the standard output of our command. So this is sort of like a backdoor that we could put in a website. Now, if we put this backdoor in the website, then through the include, we will be able to get remote code execution. Why? Well, consider this. We have this page. Then we go into the page cmd, and this loads the page, right? But at this point, we still have to give the other parameter, which is the cmd parameter. And in the cmd, I can say, for example, who am I? And notice I get Leo. I can say ls. And notice that I get all the things present in the Tomcat directory, in the main directory. I can say print working directory, and I get the entire working directory which ends at Apache Tomcat, because that is where the web server is executing. This is all to say that depending on the file we include, we could have trivial behavior of well-intended page or dangerous and potentially malicious behavior. Because at the end of the day, with a file inclusion, we are executing code. If that code is then a general, for example, backdoor, or a reverse shell, or a bind shell, or any sort of code that executes other code, then it could be very dangerous. So we have to be careful. And this essentially covers the first example that I wanted to bring. So essentially what we saw is that file inclusion mechanism is a way in which an application can include other code inside the application context, include and execute it. And so we covered our first example of a file inclusion. In that case, it was just a local file inclusion because the files that we could include into the application had to be present on the remote server, on the server we were trying to attack. Now, typical ways in which we can exploit this mechanism is sort of like, for example, if we have a file upload mechanism, then we can introduce some malicious code. Then with a file include, we can first introduce the code through the file upload, and then we can include it into the application, and like that we can obtain a remote code execution. In a future video, I will talk about file uploads. Now in this case, this other example instead is written in PHP. So this is like a PHP application. We can start it with the PHP interpreter, because anytime we have a dynamic backup, we also have to have an interpreter of some sort. So we can start it with PHP 127.0.0.1.1337, and then once again we go localhost 1.3.3.7. I say not found, of course, because actually the thing is login.php. So this is our application. We can start burp and we can start analyze this application. So we can go into the intercept, let's say test. Okay, now what did we learn when it comes to SQL injection? Well, let's try to introduce some characters like this. Notice that the server crashed. We got an HTTP error 500 because this code is vulnerable to an SQL injection. And this application is actually the same one that I showed before in the videos about SQL injections. Now, what did we learn in the video about SQL injection is that anytime we're able to crash the server because we introduce some special character for the language of interest, in this case it was SQL, then we probably have an SQL injection. To actually use it, we can once again turn the intercept on. We can do test. We're going to inject on the name because typically the password is hashed. And we're going to do, we close the quote and then we do or1 = 1. We put the comment and then we URL encode everything. Then we do forward. This is the response. No, this is like another request. And now we are inside this application. Now this is like a pretty ugly application. We are not really that much interested in it. I just wanted to showcase the SQL injection. And now we can actually read the code of this application. Now here we have a bunch of PHP files. We can start off with the config.php. Typically these files contain always some kind of juicy information. So we read config.php. Now in this case we just have the database, and the database is being loaded with SQLite 3. So this is like an SQLite database. We have the database here. We can technically read it, but we're not really interested in that in this point. Then we have the login page. Now remember that this is the code we already saw in the SQL injection episode. And if you do not see that, go and watch it again. Now, as you can see, this code deals with the login, with the authentication using essentially SQL query in the background. So using a database, an SQLite database, and we actually read and analyze this code already in the SQL injection video. So if you did not see that video, I suggest you do before this one. So this is like nothing new. Then we go into the list.php. Now this is new. So how can we read this code? Well, here down below there is the HTML part, and essentially here we do a for loop for each note, and for each note we print the details of the note, such as the username, like actually the file name, the base name, and we also include the note. Now this include statement is key, because we're going to talk about file inclusion. Now this include statement, what does this mean? It means that a note is actually going to be a file path, so like a resource which points to a file, and PHP will read that file and will include that file in the current application context. And given that right now we're talking about PHP, so no more JSP, that was in the first example, this is all about PHP, it means that any PHP code contained within this note will also be executed once we do the include. So this is the general idea, and we will have to exploit that. Now, how do we do this? Well, let's try to read before. So here we include some static util.php. Then we do a session start. We check if the user is logged in. And if it's not, we do a redirect to the location login.php. Now notice this thing. This thing is quite interesting. So in the case that we are not logged in, we just do a redirect, but we keep executing here. What does this mean? Well, let's try to open burp. So we have burp and we go into the list. Let's see, let's go down here. We go into the list.php. Now, if we are logged in, we have this PHP SSID. So we have this and we see the Leonardo nodes, the nodes for Leonardo, which is the first user. Now, what happens if we remove this cookie? Now, what happens, notice here is that even though we have not the cookie, we do not have the cookie, actually here, we are printing virus stuff. We are still printing the page. This is really, really important actually. Why are we printing the page? Because after I do the header, I do not do the exit. I do not say, look, I'm done with the execution. Now, this behavior is actually a vulnerability, an extra vulnerability that I wanted to talk about. This is called execution after redirect, EAR, because we have a redirect here, but we still keep executing. How do we fix this? It's really simple. Anytime we want to redirect the user, we have to stop printing anything else. So we can exit from the PHP code, from the PHP engine, and like this, notice what happens now. I do the send, and now I get a found and no body. If instead there is no exit here, I get a found with a body. I put an exit and I just have a found. That's it. So this is just like to talk about this, but we don't care about that. We can remove that. So now we have essentially our page. So what happens here? We take the username, okay, then we check this parameter. If this parameter is not set, if dir is not set, then the directory we get is into the username. Since our username was Leonardo, we will go into Leonardo directory. So we go into nodes Leonardo. And here, for example, we have latin.emd, which is why when actually we execute this, we get this lorem ipsum. If you go here, we get this file, which is actually included into the application. This means that if here we put some PHP like echo hello, this PHP is actually going to get executed. Notice here, hello. This means that if I put a system with, for example, who am I, this command is going to get executed. For example, with ls, this command is going to get executed. So this is the danger of doing includes like this. Now, in this particular case, what's the idea? The idea is that if we put an explicit parameter dir, then we're not going into this default directory, but rather we have control over the directory we're going. However, to actually check this, to actually get to here, we have to go through this sanitize function, to this sanitize input, which means that first, our value is sent into the sanitize input, and then the output of that function is set into safedir, which is set into directory. And this sanitize input is set into the utils.php, util.php. Now this sanitize input is going to replace dash with the empty string. Now we already saw that this is not a fix for the local file inclusion, and we can actually use the same payload that we did for the directory traversal. Now, did you remember the payload dash? If we apply to this payload, we actually get back a dash, which allows us to go all over the system. So this is a first way in which we can exploit this code. Specifically, for example, we can put a PHP code here, test.php, and this test can be like a simple do system of get cmd. So just execute any command that is sent to the get parameter, to the cmd parameter of the get request, and then I go here and I do like dir. So I have to do dir, and then I have to go back. How many directories? Now let's try to put one dash, and then I do test.php, and then I do parameter cmd uguale wmi. Okay, this does not work. Okay, actually in this case, the value here did not have to be a file, actually it had to be a directory. So it actually has to be a directory like this. Okay, so like what happens if we go here? We have config list.php. So here there's some problem with respect to the declaration, the fact that I declare multiple times the same variable. So if I start the server here and I go into dir like this, it says cannot redeclare sanitize input. So actually what we can do is we can put this test.php into the tmp directory, and then we go actually let's create a tmp test. We move the tmp test.php into tmp test. So we have moved this directory. So now in the tmp test we have this single test.php whose content, remember, is like this. It's just a simple backdoor. And now using our this path, so we have to do it many times actually, because we are many directories nested. So let's try to do it. This is 2, then 4, then 8. Let's try and then TMP. Let's see if this URL works. And then we do test, and actually we do test. TMP, test. So this is not working. Maybe we need some more. Do we need some more? Because we are very nested. Okay, we have test.php. Now it works. Of course, here there was a mistake. This is like a close parenthesis here. And now to actually get code execution, by remembering that this file is just, we have to put the cmd command. We do end cmd equal UMI. And here I have Leo, for example, I could say ls. And here I have my command included in the file. Here I could maybe cut an RSA flag or things like that. So this is our second example of local file inclusion. This time is using the PHP include statement here, this PHP include. Now, and the idea here is that we're going to include all the files in a directory. We put then a backdoor within a custom directory that we then access later on with this directory traversal, with this by escaping the sanitize input. So it's sort of like the directory traversal has to do with fetching the file inclusion has to do with inserting the file in the context of the application and executing it. Now we are not done with this second example, however, because now we will see also our first remote file inclusion. Because up until now, the file had to be local to the server. So first we had to upload the file to the server and then we could execute it. What happens then if we can just serve the files to the server through a remote protocol, for example HTTP? So we go into our temp test directory and we start a Python server, so server 1338. So we have this web server at 1338. For example, we can access it as follows: localhost 1338, and we have the file here. We can download it, we can play around with it, whatever. Now, if we just download the file with a web browser, we're just gonna see this code. It's not gonna be executed. It's no fun. What we want to do rather is we want to include this file within the context of the application. And how do we do this? Well, if we read these read notes, notice how it is implemented. So here we say, look, if the file starts with HTTP dash, then actually we're gonna request it to the localhost 1338. So we're gonna request it to the remote, to a remote endpoint. And here we're gonna put the name of the file, which is obtained by the name of the local file. It's sort of like the local file is used to understand how to make the HTTP request to obtain the remote file. So how do we use this? Well, consider, for example, the server we just started. So I think it's this shell. So we're gonna start it again. And I'm not gonna make any requests now. Perfect. Now, let's go back to our, for example, nodes directory. So we go into the, essentially the idea is, I think it's here. This is pages, so this is Tomcat, this is not PHP. And then we do cd content PHP. Okay, we do www, we do page, we do notes, we do Leonardo, perfect. Now suppose that we add a new file here. Okay, this new file is to be HTTP dash because we want to trigger this if statement. And then we want to put a name of the file, like for example, example.php. Now, when the server is gonna execute this function, it's gonna fill up an array. This is a way in PHP that you fill up an array. And one of the entries of the array is going to be this localhost 1338 / example.php. That's one step, right? This is what is going on here in these nodes. Then, during the construction of the HTML here, we're going to iterate through each node. And for each node, we're going to include it, which means that at the end of the day, we will include a remote URL, an HTTP localhost 1338 / example.php. And when we do that, actually, we're going to receive a request here from the remote web server. So let's go to the browser. Now let's go initially, actually you just have to go to list PHP. Why? Because we put this file into the default directory from which the application reads. So it's like nodes/Leonardo. We go here, notice what we get here. We get a web request, and this web request is made on the form of example.php. If here I create another file, so I remove this example.php and I create HTTP hello world, and then I do again the request here, I get hello world. If I get please subscribe, once again, now I get 2 requests, hello world and please subscribe. So the idea is that now I've actually obtained a remote file inclusion. So it is a file inclusion, but now it's remote. There is an error here, it's remote. Why is it remote? Because the file I'm including in the application is not taken from the local file system of the server, but rather is taken through a network protocol like HTTP. Of course, the same attack could be done with other protocols like SMB, FTP, WebDAV, like a lot of other protocols. The idea is, if the resource I'm getting comes from the network, and specifically comes from an attacker control part of the network, like the attacker can control that part, then I have a remote file inclusion. Of course, in this example, it is worth to note that the remote part was defined here. It was specifically localhost 1338. So this is not like fully remote. You should have put like a public IP accessible from the attacker, but this is just to convey the idea. And the idea is that now we are not reading the file from the file system, but rather we are obtaining the file, we are including the file from a network protocol, which means that the attacker itself can give us the file. And this of course means that if the attacker has complete control over this URL, then it's easy. Why? Because not only can include a file, he can include any file he wishes without even having to upload it using other mechanism of the web application. He can just expose his own web server, his own malicious web server, giving the specific test of, for example, PHP resource, and then the application requests it. So for example, if I were the attacker, I would go do, okay, let's write this, and then here I would write HTTP test, and now when I refresh the page here, so I go here, I remove this, I go here, notice this test, and if I do cmd equal UMI, okay, I think it has to be test.php actually. It has to be test.php, yes, because this is what the web server gets. Yes, test.php. Notice here I get my whoami. I do ls, here I get my ls. And this of course is executing from the server point of view. However, the resource that I've included was given by the attacker. Now this is the general idea of remote file inclusion. I hope it was clear. If you have some problem understanding it, please write in the comments. And now to finish off the video, we can see the final example with the damn vulnerable web application. Now when it comes to the damn vulnerable web application, I have a GitHub repository, leonardo95/dvwa, and you can just run the docker command. So you need docker. So I'm just gonna run docker. I'm gonna put here burp, I'm gonna put here chromium. I think it's like 3, no, it's chromium 2, yes. And now if I go into localhost, I think it should be localhost, we get the login page and we put into the target, we have to change the scope, we have to remove localhost. No, actually I have to put localhost, but in this time, enable, so like let's do like this. Okay, we put it localhost 80 to the scope, and the credentials are username and password. So we're gonna intercept them. This is like the login, we can forward, we get in, we can remove the intercept. And we can clear and reset the database. So we wait a bit and then we log in. Admin password. And we go into security low. And then we go into the file inclusion. So this is the low functionality. It says the PHP function allow URL include is not enabled. Now, what does it say this thing? Well, if we go into the Docker of the machine, so we do Docker compose. And here I have my Docker exec bin bash. Here I have the thing. Now, if I go into etc PHP, I go into the 7.0, and I go into the, I think it's Apache 2, Apache 2, and go into the PHP ini, and I grab for allow URL include. Notice that this is off. Now, the fact that this is off, this specific configuration, means that the include will not allow for network protocol, for remote URLs, like for example the HTTP payload that we tried previously. Now, why did it work in my machine? Because in my machine, if you go into the etc PHP ini, and then we grep for the same, allow URL include. Just for the sake of this video, I set it on. So in my machine, just for the sake of the video, I experimented with putting it on, and this is why it allows us to do a remote file inclusion. In this case, it's off, meaning that it will not allow to do a remote file inclusion. And I believe that by default, it's off. Anyways, let's go to the challenge. Now notice in the top here, we have a bunch of files, file1.php, file2.php, and file3.php. Notice here, page equal. Now this payload should remember us our first example, right? Well, because this page equals, what if we put, for example, ... We get nothing. What if we put ... again? We put nothing. What if we put dash again? Also nothing. What if we put a bunch of them, and then we put, I don't know, etc passwd? Notice that we get the etc passwd of the remote machine. So essentially we are including this file, and this is not sanitized at all. Now, of course, etc passwd is not a PHP file, right? However, we can also include PHP files. In this case, for example, we could include file4.php. This actually isn't listed on the damn vulnerable web application, but it was a hidden. I just guessed it because it's like file 1, file 2, file 3. Here in the view source, the code is pretty simple. We just put into the file variable the get parameter we put on the page parameter, and then in the bottom, the code we don't see is gonna do an include. It's gonna do an include of file. So anything we put on the file variable is gonna be included in the page. And in this case, this included PHP is sort of like the header, if we want. And the page 4 is actually this like let's see, page equal. Let's see if I just load it like this. File 1, it's the file 4.php is the hidden one. What about file 5? What about this one? This one is not even shown. File 4.php. And if you actually go into the, where is it? var, actually it's var www, I think it's var www html, and then we go into the vulnerabilities LFI, actually FI, file inclusion, and then we say file4.php. And it says this is the PHP code that we included. Actually, there isn't any PHP code, it's just the page equal body, so it just adds to the body this string. So essentially, this code is just adding to the body of the page, which is later rendered this text, which is like file for hidden. Good job. Now notice this thing. In this output, there's also this HTML comment. It says, you did an even better job to see this. Now, why this is the case? Because when we saw the output, actually, remember, this is not the HTML text that we see. It is the HTML being rendered by the browser. This means that someone could have put a comment into the HTML code, and we do not see the comments in the rendered vision of the browser. To actually see the comment, we have to check the source. We always have to check the source, because in the source, that could be even more hidden things. So it's sort of like this is hidden because the file 4 was not listed, but within this hidden file, there is a hidden comment, and you always have to check the source code to make sure that stuff like that does not happen. Now let's go into the medium difficulty, into file inclusion. So let's check the code for this one. Now for this one, we have the typical validation for this sort of like thing that I already showed. We already know how to break this, so here it's like no big deal. And if I put file4.php, we got it, but we can also do that dash. We repeat it a bunch of times here. So like let's put it once again, and then we do etc passwd. And here we can go into any folder, into any files. And if we sort of like get a PHP file, then we can also execute that file. So not only we're able to like get any file, we're also able to execute any PHP file within the remote server. So this is for the level medium. For the level high, we go into the file inclusion. We check the code, and it says, look, input validation. This time, the input validation is done through this fn match, which is sort of like a wildcard. This is like expands, and essentially it says, if the file is different from include.php, and it does not start with file, then I did not find anything. So what's the idea? The idea is that with this, we should only be able to read include, so this we can read. Also, we can also read like file4.php. We can read this, but how do we go like other than this? How can we read, for example, the etc passwd? If I put this, notice that this does not work anymore. It says file not found because in the code, I think it's like in the code here, it says file not found because this rule is not matched anymore. However, notice that this rule is sort of like it asks that the string, the parameter page starts with file, but then it can be anything. So let's make sure that our parameter starts with file. So it's like file, like maybe file4.php, but then I do dot dot dash, dot dot dash, dot dot dash. I put a bunch of dashes like this, and then I do etc passwd. Notice I once again get back the etc passwd file because I actually match this rule. This rule only asks me that the parameter would start with the string file, but then in the path, in the way the path is actually interpreted by the web server and the PHP engine later on, this is actually a valid path. It says you get this file, but then you go back one directory, until you go to the etc passwd directory. And so discover all the difficulties of this level, the impossible level. What does it do? It simply hard codes all the possible pages. So this is a whitelist of all the valid resources. When you have to expose file like this is a very useful approach. You just include the file you want to include and nothing else. No file4.php, no etc passwd, and no other file whatsoever. Now, before I finish off the video, there is another thing which is very useful when we have a file include. Given that in the file include we can execute PHP code, there are so-called PHP filters which allows us to convert the file we are including into base64. In particular, I want to talk about the following payload. So we have, for example, it's localhost. So we have localhost. Here we have the payload of the local file inclusion. But instead of putting directly this, so it's like instead of having this thing here, that would just give us, so for example, in this case, it's because I have to lower the difficulty to low. So instead of having this, which would just give us the etc passwd row, that's it. We actually put before the payload this thing, php filter convert.base64 encode resource equals this thing. Now what happens if you use this payload instead? Notice that here we have a big string and this is base64. And if we decode this base64, base64d, we get back the etc passwd. Now, why is this trick useful? I mean, why did I want to show in this video of file inclusion? Well, the idea is that even if we have a file inclusion, for example, we could include the, I think it's like include.php. However, we do not see the PHP code. We just see the result of the execution of the PHP code. But suppose that we were interested in actually seeing the PHP code. Then a way would be, instead of including the PHP code row that is then executed by the web server, what I do is I include the base64. I include the base64. I think the payload was here, yes. I include the base64, and given that base64 is not PHP code, when the PHP code sees this base64, it tries to execute it, but it's just a raw string, so it just prints the string. And in this way, we're actually able to leak PHP code. So the idea is that, suppose now I want to put here include.php. I go here, I do this, and I do this. I get another base64, right? But now, if I do this, actually, let's do in another shell. If I do this base64d, well, notice what do I get here? I'm getting PHP code. This is PHP code. And I can put any sort of thing I want. The idea is that because I'm first converting in base64, and only then I'm including the file. So there's sort of like a transformation pipe going on here that it says, you can include this file, but first convert it to base64. Once I've converted to base64, the characters, the PHP characters, are now masked. They are hidden, and therefore they are not interpreted as PHP code, they are not executed, and I get back the raw base64 bytes. I can then decode them with a later tool, and I have my PHP code. I have leaked PHP code. And of course, this works the same in all sorts of scenarios in which we can first encode and only then include. And to do this, the payload is this one. So I wanted to showcase this one to just finish the video with this source code leak technique, which is a PHP filter. So we've covered an example in JSP with a Tomcat server with Java code. I showcase the idea behind local file inclusion. I then showcase another application, this time a PHP code. We read the code, we analyze, and then we did another local file inclusion, and then we also talk about remote file inclusion. And finally, I showcase the 3 levels of the damn vulnerable web application, and at the end, I talk about this technique to leak PHP source code using the transformer to base64. And also remember that I talk about this execution after redirect vulnerability, which happens when we keep executing the PHP code after we do a redirect. This is a vulnerability because the attacker is able to read the HTML portion after the redirect happens, and we do not want that, as it could leak potential secrets, potential sensitive information, and things like that. Anytime we do a redirect, we have to stop immediately the execution of the PHP engine and just send the redirect. So that's it for the video about file inclusion. In the next video, we'll talk, I think, about file upload. So see ya there. As always, of course, if you have any feedback about the explanation, if you want me to explain something more in depth, please let me know. Please write some feedback, subscribe to the channel, and keep watching because I will create more content like this. And that's it. Let me know what you think. To the next video. Hi everyone, and welcome to this new video in which I continue my web exploitation series. In this episode, I will talk about file upload vulnerabilities, and in particular, I will showcase different ways in which we can attack a file upload functionality. I prepare an example written in the PHP language. This is the code, and we can execute it with php-s, and here we put our port that the server is gonna listen to. So this creates a local PHP server, and then we can go with our browser into localhost 7070, and this is the application. I've already burp set up, so this is already set up. So this is the application, and at the end of the video, I will also showcase file upload vulnerabilities in the PortSwigger Academy. Now, this is a free resource available to everyone, so you can register to the Academy and you can explore these vulnerabilities, and I will showcase how to solve some of the file upload vulnerabilities. Not all of them, but just some of them, so you can get a clear idea on how to actually perform these attacks. Now, the first thing I do, I always put my domain on the target in BurpSuite, and I can only log out, I can only log in the history in scope items. I always do show only in scope items. Essentially, this allows me to remove everything else. I don't need anything else, I just need these kind of things. So this is the web application. It's running on localhost 77, and the way I ran it essentially was through this command. So through this php-s, and then here I put the IP address, the localhost 127.0.0.1, which represents the localhost interface, and here I put the port that the local server is listening. And this is PHP server. So when we use this application, the client sees this. We have a profile pic that is missing, however, so here there's nothing. And if you open the DevTool tab here, and we go into network, or maybe into error, it says, look, I'm not finding a particular resource. So he's trying to load an image, but he cannot find this image in the server. And we can check the HTML code, And we have a simple title, some style, and then here is the HTML. Now this is really simple because I wanted to build a really simple application that just showcases the file upload functionality. Now in this case you can see that the profile pic request, there is this image tag underneath the paragraph with the profile pic, and this source points to a folder in the web server, uploads/level1 thumbnail.png. However, if you click on it, we find not found. There are no files in this uploads folder. And we can double check that there are no files. Why? Because we actually run the server locally. So we have access to the client part, the browser, as any other clients would do, but we also have access to the internal server components. Now this typically does not happen in servers you're trying to attack, but since I'm doing this, I'm recording this for educational purposes, and I will let you have the code also, of course. Since I'm doing this for educational purposes, it's useful to also remember how the server is configured and to play with that. And so we can simply open a shell. We go into the uploads folder. So this is the root directory of my application. Let's say that here I add hello.php and I just print echo hello. So I add this, and then I can simply go to localhost 77 hello.php and I get my hello. This is just to showcase that we have full control over this application. Now, of course, the idea is to attack it exploiting the file upload functionality. If we go into the uploads folder, this folder is completely empty. There are no files, and this is why we get a not found, because here is trying to reach a resource in this folder, but there is no such resource in this folder, therefore we get the 404 not found. I mean, this in Burp is essentially this kind of thing. So we get, so we go into the history, and we get a 404 not found. This is the HTTP error that returns when we do not find the resource on the server. Now, if we keep analyzing, however, the HTML code after requesting the image source, we have a div section, so we have a div, and then we have heading of level 3, H3, level 1, this is a paragraph, and this is an upload form. And graphically, it's even simpler to see because we have level 1, level 2 and level 3. Now each level allows us to upload the files. This is written in Italian, it's called scelli file, which means just choose the file to upload. And if we just use it, like we click on it, it opens up the file explorer where we can pick our asset to upload. For example, here I'm gonna pick the thumbnail for my OSCP free guide, which is available on my YouTube account. So I uploaded this and then I can do submit. Once I uploaded this, notice that this thing changes because now he actually finds the assets because I've uploaded it to the web server. And now, if you go into the uploads, notice that we see this thumbnail, which previously was not here. And if you do a file command on it, we see that it's a PNG image. And if you open it, it is the same PNG image that the browser is now rendering. So what exactly happened here? Now let us assume that I remove this image. So we go back to the initial state. Now when I do this upload functionality, we can now intercept the traffic with BurpSuite, or also we can also check the history. So essentially here we have a post request to the script upload.php. So this post request, this one here, is the request that is made by the browser in order to upload the file to the server. Now notice the format of this request. So it is the post, this is the HTTP verb of the request, it is a post, this is the endpoint upload.php. It means that the code that will be executed on the server is gonna be the script upload.php. Then we have this content, so like here it's content type, this is very important, content type, it's called multipart form data. So essentially it says that we are submitting to the server not one parameter, not two parameters, we are submitting to the server multiple parameters, multiple data. So this is called multipart form data. It is the data that comes out of a form. And in particular, notice here, there is a boundary value. Here is called boundary. Now, why is there this boundary? Because in the body of the HTTP request, we actually see a lot of data. Notice how big this body is. And this data is actually split up by different components. So this boundary is used to sort of like get all the body of the request and split it up by the various components. So for example, notice it starts here with a boundary. So it says here starts a new component of my form, which in this case is the actual file. Notice we have a content type image PNG. So it says this element of the form is an image of type image/PNG. It is named file name, and there's both a name and a file name. So the file name is because it's the actual name of the file that was present in the machine of the client. So when the client uploads a photo to the server, it chooses a file. And this file has a name, and this is gonna be the file name. Instead, the name value is gonna be the attribute of the HTML form. Because when we got this form, if we just analyze here, we have this form, and this form has various inputs, and the input that contains the image, which is this input type file, it means I want an input that is gonna be a file on the client's machine. The name of this input is file name. So here we have a difference between the value of file name and the value of name. This can be confusing, so once again, name is taken from the HTML form that is sent by the server to the client and that is used by the browser of the client. So the browser of the client sees this form, renders it the form, and then I can click on it and I can interact with it. And so the name of the particular field is gonna be the value of the name attribute here, while the file name attribute is the name of the image of the file I'm trying to upload. So there is this slight but important difference. Then we see all the bytes of the file. So this is the bytes of a PNG image, and this is the magic bytes of the PNG. Then what we see here is if we go down enough, we're gonna see other values, because this form does not only contain the bytes of the image, it also contains different information. At the very end, we find here, I'm scrolling down, we find the value of the submit and the value of the level. Why? Because once again, if we go back on the form, here we have 3 types of input, and each type of input goes into the body of the request in a different boundary. So once again, why do we have to use the boundary? Because the idea is that I'm gonna have boundary 1, and then I'm gonna have content 1, then I'm gonna have boundary 2, and then I'm gonna have content 2. So like each input that we put in our form is gonna be separated by the boundary. And this is why it's called a boundary, because intuitively it has to separate all parts of the input. This is so that the server at the other end can split up the content back to the various components, so he can understand which is the value of level, which is the value of submit, and which is the value of file name, which is this name file name. So this is the structure of the request. And then we got a 302 found, it printed some stuff, and then it actually uploaded the image on the server, and after it uploaded, the browser was able to fetch it. Because initially, right now, it cannot fetch it, because if I check on the operating system of the server, in the uploads folder, there's nothing here. It's completely empty. When I upload an image, like for example this one, and I say submit, now there is this image, and so the browser is able to fetch that content. And so this is the idea. We can also open like this. And so this is sort of the flow between the client side. We are seeing only stuff from the client side because right now we have access to the HTML, and with Burp we have access to the request that is made by the client. Now, to actually understand how this payload is processed, we have to go into the upload.php code, because that is the code that is executed by the server. Now, I have it here, of course, and so we can simply read it, upload.php. So this is PHP code. What does it do? First of all, it checks if the submit value is inserted into the post. So we say if is not set submit of the post, or is not set level of the post. So if those two parameters are not set, then we do an exit and we say, look, the request is not valid. Now we can check this. How? Well, very quickly. We can just create a custom image. Like for example, we can start to intercept. Then I'm gonna upload another image, like maybe this one. Gonna get submit. Here, I'm gonna change, I go to the end, and I'm just gonna remove this part. I'm just gonna remove this part, and I'm gonna do forward. Notice what it says is, request is not valid. Now, why did it say this? Because by removing submit and level, this if was true. Because the submit was not true, was not set, so not is set, this is gonna be true, and so we enter into this if. So this is the idea. Then we define this move file function. So we are not calling it yet, we're just defining it. Now we are doing a bunch of echoes, so we are printing a bunch of information. In particular, this is how the PHP code is able to access the information sent by the client. Now, of course, this depends on the backend that you will use. Because if you use PHP, it's gonna be this code or code similar to this. If you use Node.js, it's gonna be a different type of code. If you use a framework that is built on top of PHP, like for example Laravel, it's gonna be even different. So this is the basic bare bones PHP code. And the idea is that in the files variable here, we have the information on the various files that we uploaded. And in particular, here I'm asking, give me the information on the specific file called file name. Now, how do I know that it's called file name? Because in the HTML that the server created, the input file has the specific name of file name. So these two have to match. Because if they don't match, I'm not fetching the right file. So the file that I uploaded with this name has to be taken from the server using the same label. There has to be a matching here. Otherwise, I'm gonna get a different file. Here I'm just getting the parameter level sent in the post, in the body of the post. Now here I'm actually printing out the temporary name that has been given to the file name. Now, why this is important? Well, if you go back into our burp here, I'm gonna remove the repeater, I'm just gonna go into history. Notice here we have all these variables printed out. Now, if instead of for example, instead of doing var dump files, so we have array. So look, this is the first thing we print. And notice that this thing has various information. This thing has all the information regarding to this specific file, which means in particular it has a name, it has a full path, it has a type, it has a temporary name, it has an error, and it has a size. So this is all the information for each single file. So for each file, PHP saves this information. Now this temporary name is a temporary directory in which the PHP engine saves the file before it is actually being processed by the code. Why this is important? This is important because the code can choose whether to save the file or just discard the file. In order to sort of understand what to do with the file, first PHP saves it onto this temporary name with this temporary name in TMP, and only afterwards it will decide, okay, I want to save the file, okay, I want to delete the file, and stuff like that. And also notice that even though we do have information on the original file name of the file, the temporary name that is created by PHP is different. And this, of course, is different for security reasons. Because essentially it says, look, I know that you can control the file name because each client can control this file name, but PHP has to save it in a way that the attacker cannot guess how this file name is called. And this is the idea. Then we print the temporary path, actually TMP path it's this, level 1, file name, file size, and then we say successfully uploaded to. Now, of course, these are just informational elements that a real server should not disclose. Here I just wanted to put it to show you how you can extract information on the PHP side. Because when we talk about web exploitation, we are also talking about web development, and we always have the two components, the client and the server. Each of these two components has different information flows, and so we have to understand how can we extract the information that has been sent us by the client from the server and vice versa. Now, after this, we check the level variable. If the level is 1, we execute this block of code. If the level is 2, we execute this other block of code. And finally, if the level is 3, we execute this other block. So this is sort of like levels. Each level has a different difficulty, sort of. So level 1 is the easiest to bypass, level 2 is a little bit harder, and level 3 also. And so we will discuss how to bypass these 3 different levels. Now, to start off, let's consider this first level, where there are no checks whatsoever. What does it mean? It means that what we do is, starting from the name of the file, we extract the base name. Now, what is the base name? Suppose, for example, that I am in this directory, right? So I am in this directory, and suppose that I want to consider the file, so here, I want to consider the file index.html. Now, the base name of this is just the final portion of this entire path. So I do not consider all the directories. I just consider the index.html. This is the base name. It means that if I have this entire string and I take the base name of this string, I'm just gonna read index.html. And so essentially here I'm just reading the base name. Now after I read the base name, I'm actually executing this path info with the base name and this path info extension. Now this piece of code simply extracts the extension from the name. Now what is the extension? It's essentially the final portion of the file name, the one after the last dot. So for example, in this case, the extension is HTML. If I have an image, image.png, the extension is gonna be PNG. So I extract this value from the file and I use it to create a new string. And this string is gonna be the target path. So the target path is gonna be the file that I will write to the server. So I'm using essentially the file that has been sent to me from the client, and now I'm writing it somewhere on the server, and that somewhere is in this target path. Essentially, it boils down to uploads level 1 thumbnail.png if we upload a PNG file, of course. After I've computed this target path, I can use the function moveFile. I can move the file saved in the temporary name into the target path. And then here I write header location /index.html saying do a redirect to go into the home page. So this is why I do this header, and that's it. Now this moveFile uses an internal PHP function which is called moveUploadedFile. It takes a current path and a final path, and it moves the file in the current path to the final path. So essentially, how does this traduce itself to like the actual practical thing? So the idea is that suppose I remove this. When I upload something, like for example, so here I go back, I choose a file like this. So the thing is, the PHP engine is gonna read the file, it's gonna save it on the temporary directory, then it's gonna process this code, and it's gonna check, look, the level is 1, so I'm gonna compute the base name, then I'm gonna compute the target path, and then I'm gonna move from the temporary location into the target path. And with this move, I have permanently saved the file. So it is no longer just in the temporary path that is deleted after a few minutes, but it's gonna be saved on the server for long-term storage. So that's the idea. I do the thumbnail. Here we can even put some kind of echo to just check what is happening here, target path. And then here I can just open burp, I can put the intercept, I can do submit, I do action, I want to do intercept response to the request, because I also want to intercept the response. I do forward, and this is the response. Notice what do I get here. I get this is the like thumbnail.png is the name, and uploads level 1 thumbnail.png is the target path. So it has printed one after the other without new lines, but that's the general idea essentially. This is the base name, this one, and this one is the target path, dot slash blah blah blah. So that's the idea, and we have successfully uploaded the file. Now it's on the server, and we can just forward it, and now the browser is able to display it. So how do we attack this? Well, it's actually really simple, because here we do not check whatsoever. Now, what is our end goal in this case? Well, for example, our end goal could be to upload malicious code, because if we can upload malicious code on the server and we can execute the malicious code we uploaded, we have remote code execution, which is one of the highest form of attack you can do to a server, of vulnerability that a server can offer. So for example, we can go into here and we can create in assets. So you have the shell.php. It's a really simple PHP shell. It's just a file, right? And we want to upload this file. Now, depending on the checks that are done server side, this can be easy or hard, or sometimes impossible or very, very hard. Now, for this first level of exploitation, it's really easy. Why? Because I just choose the file, shell.php, I do submit, and I've actually uploaded the file. Now, if I go into the server, into the storage of the server, I have this level 1 thumbnail.php. And if I go into uploads, level 1 thumbnail.php, and I do, for example, cmd who am I, so not this one, not with the PNG, but with the PHP, I get code execution. I get code execution and I can do anything I want. So this is like a small example. So in this case, it's like this. So this first level has no control whatsoever. Now, what is the dangerous thing here is that we do not control anything. First of all, we do not control the content of the file, and we also do not control the extension of the file, because the extension of the target path is actually controlled by the attacker, by the client, because look, it's computed with path info based on base name, right? But base name is computed with files from name, and name is chosen by the client, because name is whatever we put in the burp request here. We just go into the upload request here, repeater. Whatever we put into this name, actually into this, I believe it's file name here, it is whatever we put here. For example, let's say that here I put ABC. I do send, it does found, whatever. Then I go into the uploads, I go into terminal, uploads. Notice what I have here. Down below, I have level 1 thumbnail.abc. And I can put other stuff here. It doesn't matter what I put here. I can put YUI. And then here I have YUI. So this is because I have total control over this base name and therefore over the extension. And so we are done with the level 1. It's the worst level. It's the easiest level because we can just change the file name. And when you find yourself trying to exploit a file upload, you always have to understand, but do we have control over the file name? Because if we have control over that and the server does not sanitize it, we can, for example, upload directly a PHP script and then we can execute it. Of course, also notice that to actually have a full exploit here, there were two requirements. The first one is to have control over data. The second one is to have control over extension and file name, sort of. And the third one, so there are actually three requirements, is being able to access the uploaded file. So we need to know where the uploaded file is if we want to exploit it. In this case, we could control the data because it did not check anything on the data. We could control the extension because it's just computed from this parameter, which we had full control. And we understand where it was uploaded because by analyzing the previous behavior, we saw that, look, all the files are uploaded to the uploads directory. And typically, if the application is not too complex, you can understand where the files are being uploaded to. At that point, you have to understand, does it try to check on the content? Does it try to check on the extension or to enforce specific extensions? And this brings up to the second level. So let us now analyze this second level. First of all, if we were to try to simply upload, for example, a PHP shell in the second level, so here we do level 2, we try to upload this PHP, we do submit, and it says error invalid type, so it prints out an error. Now notice why. If we check the code, we still compute the base name using the parameters sent us by the client. Then we compute this type, which is also sent us by the client, is this type field, and then we do a check. If the type is image PNG or image JPEG, then we upload the file, we move the file to the final directory. Otherwise, if the type is different, so it's neither PNG nor JPEG, we print invalid type. So it means that there is sort of a check being made. Now the problem is that this check is easily bypassable. Why? Because where does it find this file name type? Well, we go back to the request in burp here, and this thing is actually taken directly from the request in the content type image/png. Now, even though before it was much easier because we could simply upload a PHP file, if we now simply upload a PHP file, Burp is gonna set up a content type accordingly, because the browser is not Burp actually, it is the browser who says, you want to upload a PHP file? Okay, your content type is gonna be application/xphp. This content type is sort of like a description, a category description of the nature of the file we're trying to upload. And the browser noticed that our file ends with a .php extension, therefore it sets the content type to application/x-php. Now, of course, the issue here is that if we just send this, we're gonna get error invalid type. However, what happens if we sort of change maliciously this content type? So now we are doing something with Burp that the browser would not typically do. However, since we have our man in the middle for proxying, for penetration testing, we can definitely do that. And even a malicious attacker can do that. A malicious attacker has full control over all the data in this HTTP request. So it takes nothing to just change this field. So if we change this field to image/png and we send here, we get an OK and we get successfully uploaded and we get level 2 thumbnail.php. So if we go into with the browser to essentially uploads level 2 thumbnail.php and then we do cmd who am I, we get once again our code execution. Now, why did this work? It worked because even though the file name has an extension.php, the content is of a PHP file, we are telling the server that the content type is of image.png. And since the server simply checks the content type here with this type check, we are fooling the server because it's making a trivial check. This check is easily bypassable. So, is it a little bit better than the first one? Well, yes and no. I mean, we are checking something, yes, but this check is easily bypassable. And so, this cannot really work, and we still have our code execution. Now, moving on to the third level, and this is going to be the end for this custom example. So, the third level, what do we do here? So, essentially, it's a bit more complex, because what we do is, we compute once again the base name, we take the temporary name, and then we do if getImageSize works, then we move the file. Otherwise, we say, look, it's not an image. Now, to actually assess the security of this piece of code, it is really important to understand this function. What does it do? What does getImageSize do? So in input, we give the temporary name of the file that we have uploaded. So right now, it's just uploaded to the temporary direction chosen by the PHP engine. And here we are just checking if it returns something different than null, different than 0, then we upload the file for real, for long term. Otherwise, we say, look, it's not an image. Now this function, if we just check the PHP documentation, it computes the size of an image. So this function will determine the size of any supported given image file and return the dimensions along with the file type and a height with text. So this is the idea essentially. Otherwise it goes into error. So like, look at this, we do the getImageSize. If we have a size, we have a content type, otherwise we have an error. So essentially what this code is trying to do is trying to read the file as if it is an image, and it's trying to read the size of this image. If it cannot read the size of the image, it's going to throw an error. The problem with this is that if we just, for example, upload our shell, in this third example, we go here and we say shell.php, we get error not an image, the file is not an image. But right now, even if we start to mess with the content type and stuff like that here, we put, I don't know, image/png, it's still gonna say it's not an image. Why? Because now the code works directly with the bytes of this file, and it will treat the bytes as if they are an image. Now in this case, the bytes here, they are not of an image, they are of PHP code, and this in terms of underlying bytes is just a series of ASCII. So this is just written in ASCII. Now if we remember previously instead, a true image is very different. Like let's see a true image, like this is a true image. So if we upload this, this is gonna be a true image. And notice here the first bytes. They are very, very peculiar. They are bytes of an image. Now, for example, in the PNG format, you can go and study the byte encoding of a PNG image, but essentially, the first bytes have a specific structure that contains a lot of information of the image. And one of the information is, for example, the width and the height. And those kind of bytes are read and used by the getImageSize function. So the idea is that if we do not give a proper image, this code is gonna complain. So how do we get around it if we can ever do that? Well, the idea is that this function, yes, it will check the bytes, but not all of the bytes of the image. Since information like the size is only inserted at the start of the image and it's not repeated, there's no need to repeat it, it's just inserted at the start. What does it mean? It means that if we can put inside the image a malicious code, like for example, here that I am roughly in the middle of the image, here, if I put like some characters like this, and I upload it, okay, this says request is not valid, but let's just take this. So I'm gonna take this, I'm gonna use this third, so I'm gonna do intercept, I'm gonna upload an image like this, I'm gonna submit, and now here down below, I'm gonna put some characters like this, and then I'm gonna do forward, and it says successfully uploaded image. So the image has been successfully uploaded. Now, if I just take the previous image, and instead of the random AAA characters that I put, I don't even remember, I think maybe here, I don't even remember what character I put, maybe I put it again, successfully uploaded. Now, if in here, I put a PHP shell, so do PHP ecosystem post cmd, so this is a typical PHP shell. Notice here, it says successfully uploaded. So I've inserted malicious code within a valid PNG image. In this way, the getImageSize code is still gonna work because that only takes care of the first bytes of the image, and I did not touch the first bytes. The first bytes are those of a valid image. To actually check the malicious content, you would have to go down over the bytes, and this can be an expensive operation to do for every image that is uploaded by your service, to your service by the various clients. So typically, what to do most servers do, they just check maybe the first bytes. But now we put this image, we put this payload, malicious payload, in the middle of the image, and it is successfully uploaded. And notice indeed that if we try to read the image with the PNG extension, something weird happens. The first part of the image renders correctly, but then something breaks. And this is because we actually have broken the PNG encoding, so the browser cannot render all the section of the image, but only the first. Now we still cannot execute the PHP code, because the PHP engine sees this file as a simple PNG file, so it does not try to read within that file to check for the presence of PHP snippets. How do we fix that? Well, we have to work with the extension. We have to put as the extension not anymore PNG, but we have to modify the extension here to, for example, file name equal thumbnail.php. If we do this and we do send, here it says, look, I've moved it into level 3 thumbnail.php, so now the PHP remains here, PHP. So now what happens here, I'm loading, here I'm gonna have to remove this thing. So I'm loading all the bytes of the image, and at some point, if I do, for example, who am I, in the middle of this, I should have also my output. Let's see. So let's see here. I'm gonna do cmd, who am I, maybe ls. So in this case, I could not actually find the output because there was an error in the PHP execution. Here I have the stacktrace because I'm also executing the server. It says undefined array key cmd. So I think that I wrote the payload wrong, so we can do it again. So the idea is that this is the level 3 image, I believe. Yes, this is the level 3 submission, and we can put it maybe here, not even that far. So we can let's copy the good one that we already tried. Let's copy this one. We're just gonna paste it. So like, let's just take this and let's just copy it here. Okay, and then as the extension, it's gonna be .php. Okay, I do it like this, and let's see what do I get here. Do I get see if I get something. cmd while ls. Maybe I'm gonna do it like this. Okay, notice here, I have code execution. So I was able to upload the malicious code and I was able to execute it because what happened is that the code checked only the first bytes of the image with this get image size. But I put the shell not on the first bytes, but rather towards like the first, after a while. After a while I put the bytes. Here I don't even remember where, here. So there were like 30 lines or something, maybe like 15 lines. And only after that I put the malicious payload. So this get image size worked correctly and it gave the correct size to the code. And so the code thought that the entire image was valid. However, the image was suspicious. Also notice that to get the full exploitation, once again, I had to manipulate the extension. So here I have to do path info. The extension is computed based on the base name, which I have full control because the base name is this file name value here. I put the .php there and boom, I have code execution. So these were just 3 examples of like showcasing all the stuff that can go wrong when uploading image. So the idea is that you have no check whatsoever on the content, or you can have some initial preliminary check, but based on data that is completely controlled by attacker. And also you can have even more in-depth check based on the content of the file itself, right? But remember that you have to check every single byte if you want to be 100% sure that no malicious payload can be introduced to your files that the clients upload. So this is one of the most common way you can attack this system. Just put your payload not at the start, but after some bytes. Now at this point I want to bring some laboratories taken from the PortSwigger Academy. Now this is a free academy, you can go register yourself and do this exercise. Here I'm doing all content on labs and I'm gonna search for file upload vulnerabilities. So here I've solved a bunch of them, not all of them, and we're gonna check, for example, this first one, remote code execution via web shell upload. So this is the lab, I can access the lab with this. So I'm gonna do access the lab, it's gonna create the lab and then I'm gonna go with burp in this lab essentially. So I'm just gonna wait for the lab to be executed, and here's the description. This lab contains a vulnerable image upload function. It doesn't perform any validation on the file users upload before storing them on the server's file system. To solve the lab, upload a basic PHP web shell and use it to exfiltrate the contents of the file /home/carlos/secret. Submit this secret using the provided button in the lab banner. You can log in into your account with the following credentials. So now the lab has been spawned, is this URL here on the right, and I can add it to my scope, and here into proxy, as always, I can say only in scope items. So this is the laboratory, and we have like, this is the get with the basic HTML. Here we have a bunch of posts here, and we have my account. Here we can log in with the credential given to us, which is winner and Peter as the password, and we can log in. And here we have this avatar, this update avatar. So here we can upload an image as the avatar. For example, in this case, this image, I can say upload. Stream failed to close correctly. What does it mean? Maybe I need to resend it. Okay, the file avatar/thumbnail.png has been uploaded. So here, notice that it has uploaded the image and I can go and check it here. It's saved in /files/avatars. So this is the directory in which it is saved. So in this one, so in this case, we know the directory. This is /files/avatars/thumbnail.png. Now let's try to actually upload something malicious, right? So how do we do this? Well, we can just take this request. So let's say it's this one, my account avatar. This is the request that was used to upload the image here. And we're just gonna do this. We're gonna modify this PHP. And here I'm gonna put the shell exactly like we did the other time here. I'm gonna put it here. Actually, let's go here and I'm gonna put the malicious PHP. We're gonna do send. Let's see what the server answers. Taking a bit to reply. So let's try to, okay, it says stream failed to close correctly. We send it again and we get an okay. And we say the file avatars thumbnail.php has been uploaded. So once again, we go here, but this time we're gonna do PHP. So PHP, and then we're gonna do cmd equals to whoami. So let's see, there is page source. Let's see, typically the user is like www data or something. There is no www data, but let's maybe try with a different payload, ls. Okay, here, notice here, there is thing. So if we do who am I, we're gonna be this Carlos. So we are Carlos. We have uploaded successfully our PHP web shell. And to solve this lab, we have to take this file. So we have to take the file in home Carlos secret. So we can just do cat. So like we can do just, so like a second, we can do cat home Carlos secret. So we do this cat, and here we have the value. So here we have the value, and we can submit our solution, and it is solved. So this was the solution. We did exactly what we did in the third step. We modify the file name, we put a .php, and then we insert our payload within the bytes of the image, but not at the start, but a little bit later. So we can now do the second vulnerability in this category here, which is this one, web shell upload via content type restriction bypass. So we do this, we do access the lab, but we wait a little bit for the lab to get set. So now we add this to the new scope. We eliminate everything before. Perfect. So this is the new stuff. We go into my account. I think we also have to winner Peter. So it's the same username and Peter is the password. So I actually prefer to have burp on my left. I'm just gonna change this. Perfect. So if we just intercept on once again the request and we do a shell.php. Okay, here we get the request for uploading the shell. If we just send it like this, we're gonna get a file type error. But if we send it again, so let's send it again. Okay, let's send it again here. Okay, and this time I'm gonna send it, not this one, but this one. And this time I'm gonna send it, but here I'm gonna put image/png on the content type. Okay, so if I do that, it's gonna work because I have shell.php has been uploaded. And then here I'm gonna go into avatars, shell.php. So here I can remove the intercept. And let's see, cmd, who am I? I am Carlos. And I can say home Carlos secret. And here I can print the thing that I can then use here back to my account, submit solution, and I solved the lab. So this was also pretty easy because we just needed to modify the content type. And the last lab I want to treat is the third one, and it's gonna be a mix between a file upload and a path traversal. Now, I already done a video on path traversal, so this is gonna mix the two vulnerabilities. And essentially the idea is that here we can still upload the file, however there is a restriction on which file we can execute. So where we upload the file, we cannot execute them directly by PHP. To actually get PHP execution, we have to use a second vulnerability, which is a path traversal. So we will tell the server like, look, fetch me this resource, and in this resource we're gonna access the PHP shell through the path traversal, and this is gonna allow us to upload the malicious code and also execute it. So once again, this is the third lab. I've added it to the target. We can go to my account, we can go to winner Peter, go to the user, and we have the file uploaded. Now, if we upload our PHP shell, it says it has been uploaded. So this could be like, okay, it's easy, I just upload a shell. However, if you go back to my account and we try to sort of like request the image here, we do not get code execution. We just get the PHP like code, but it's not executed by the server. Now, why is this the case? This is because the server has been configured in such a way so that all the resources that are fetched from the avatars folder, and specifically from the /files/avatars folder, all those resources are images, and therefore the PHP engine does not even try to execute those files. And this is the request we make to get the shell, and this is the response. We just see the code. We do not get it executed. Now, how can we overcome that? Well, typically, as I said, it happens that often you configure a specific directory to not execute PHP code. However, if this shell was found to be in a different directory, then the server would try to execute the PHP code. So how can we do that? Well, during the file upload, so this is the post for the file upload, we can send it to repeater. So this is the post, we can send it again, just to make sure perfect. So during this post, we're actually here, we're putting the file name, right? So we're putting this thing. Now, if we put, for example, ..dash, we could try to sort of like tell the server to save this in a different directory, sort of like go back one directory and save the file. So we are traversing through the directories in a way that was not intended by the original developer, because the original developer just wanted to let us save the files within the avatars directory. But if we send this, we get the file avatar/.php has been uploaded. So even if we put the ../, meaning go back one directory, we have nothing changes. This is probably because there's some escaping, there's some mechanism to like avoid this kind of thing. For example, what happens if we put ../. This is a typical payload that I use to exploit directory traversal. If I put this, once again, nothing changes. Another thing we can do is we can try to URL encode it. So we can say, look, these 3 bytes, the ../, these 3, I actually want to URL encode them. So I go right click, convert selection, URL encode all characters. I do send, and notice here what happens. The file avatars/./ shell.php has been uploaded. So it seems as if the shell has been uploaded in a different directory, not in avatars/php, but in file/php, in file/shell.php. And in this directory, we actually get code execution. And so we can say chmd equal who am I. And so once again, we are Carlos. And if we check the get request here, so this other get request, not this one, this one, not this one, this one, here we do not get any content, and here we trigger the execution. Look at this content type, is text HTML. Before here, there was no content type, I believe, in the first one, which is shell.php. This one here, there's no content type. Maybe go a little bit before there is. And so with this, of course, now that we have our web shell, we can just do cat home/home/carlos/secret, and we can check the code here. We can put this solution, we just paste it, and we solve the lab. So it's important to understand that here the idea was to combine 2 vulnerabilities. The first one was that we could upload any sort of file. The second one was to understand that by manipulating the file name parameter of the file upload, we could also choose to save the file in a different folder. So the fact that we could upload malicious PHP is a vulnerability. The fact that we could also change the location of our uploaded file is another vulnerability, is a directory traversal, and by using that, we are able to execute our code. And this, I repeat, has to do with the fact that the web server was configured so that the files within the avatars folder were all considered images, and so they were not executed by the PHP engine. The files that were outside the avatars folder were considered PHP files, and so were executed by the PHP engine. And this is it with this video. I showcase around 6 vulnerabilities, 3 custom that I wrote and 3 other that I took from PortSwigger. They were also very similar with each other, and the final one also had a path traversal aspect to it. So the general idea for this introduction is that anytime you have to deal with a file upload functionality, you have always to ask yourself, first, what kind of files can I upload? Can I upload malicious code? Second, what kind of control do I have where the file is uploaded to on the server? Do I know the full path? Can I access the uploaded file through the web server? Do I have control over the extension? And if I have control over both the content and the extension and the file path, then I'm able to execute a remote code on the server and trigger a remote code execution. And to showcase this, I showcased 3 custom examples and 3 vulnerabilities from PortSwigger. I hope the video was interesting, and to the next video. Hi everyone and welcome to this new video in which I continue my web exploitation series. In this episode in particular we will talk about command injections, which is a really important class of vulnerabilities that is close to the idea of SQL injections because it is another type of injection vulnerability, but in the case of command injection, instead of attacking the database using the SQL syntax, we will attack the interface between the web application and the underlying operating system. This is why this vulnerability is often called OS command injection, operating system command injection. So in this video, we will analyze this vulnerability and then we will see it in practice how to exploit it using the DEM vulnerable web application with the virus levels, low, medium, high and impossible, and also with 3 labs taken from the PortSwigger Academy. I hope the video is enjoyable, I hope you get something out of it. If that is the case, please leave some feedback in the comments, subscribe to the channel, support me, thank you very much, and we can start the video. To get some theory regarding command injection, it is useful to go back to the third episode of the series where we discussed about SQL injections. Now, if you remember the structure of that video, it was structured as follows. First, we introduced the idea of structured query language, SQL, which is the language we use to interact with databases. So we have a database, we have an application, and in this case I showed the SQLite database. So a typical architecture, a very simplified of course architecture, is we have a DB, we have a web app, and then we have like the browser, which is our client. So the client uses the browser to interact with the web app through HTTP. So this goes all over the internet using the internet protocols and in particular the TCP/IP stack. And this allows browser and web app to communicate using the HTTP protocol. Internally, the web app serves the data to the browser using a database. And the communication that is implemented between web app and database is done through SQL. Now, some web frameworks have wrappers over SQL, abstraction over SQL. However, in its most simplified way, under all the abstractions, the web app communicates with the DB thanks to SQL. And the idea behind SQL injection was this. The browser, by sending maliciously crafted HTTP messages, is able to modify this interaction. And specifically, if the web app logic is badly implemented and is vulnerable to SQL injection, an attacker, by modifying HTTP messages, could modify the interaction that happens between the web app and the database by injecting SQL code. So the injection happens in the interaction layer between the web app and the database. Now, if we have this same idea in mind, understanding the idea behind command injection is really simple. Because in this case, it is not that we are interacting with the database, but rather that the web app is interacting with a different component, which is the operating system, also abbreviated as OS, operating system. So the idea is that how does the web app operates with the operating system? How does it interfaces with the operating system? And this is done through a series of commands, through a so-called command shell, which is also known as a terminal. So essentially we have a terminal, like for example sh or bash. Now, to actually understand the interaction between our web app and the operating system, that is, as I said, done through commands, we can first start to understand what is a shell, what is a terminal, how do we interact with the operating system. If you are a programmer, you might be used to interacting with the terminal. For example, in this case here, we have a terminal. I can say various commands to this terminal. I can say, for example, pwd, which stands for print working directory. If I execute this command by pressing enter, I get back a result. So like I am interacting, it's sort of like an interaction, a conversation between my process, which in this case is a terminal, and the operating system. And this interaction is done through the shell. So it's sort of like we have the terminal, which is the graphical application that lets me enter commands. We have the shell, which is the interpreter of those commands, and then we have the operating system. The terminal is used to send input to the shell. The shell interacts with the operating system thanks to system calls. We don't need to know what system calls are, just know that there is an interaction between the shell and the operating system. The operating system gives back some results to the shell, which is sent back to the terminal, and the terminal displays it to us. Now, in this case, the web app does not use an interactive terminal, it just uses a shell. It means that the web app can send simple commands to the shell and get back simple responses. Now, if we want to understand what a command injection is, we just need to understand how shells work. In this case, for example, I'm using the shell called bash. Now, there are many different shells. Bash is a typical, very common shell found in Linux operating systems. But with the command I think it's like the command is this one, chsh, which stands for change shell. And with the option -L, you can list out all the different shells in your system. So we have binsh, binbash, binzsh, and stuff like that. So we have different types of shell. Now, as I said, we can do various things with the shell. For example, we can say, give me all the files in this directory, which is done through the command ls. Or we can add options to the command. For example, ls-lha. To have this, to have more information, not only we know that there is a file called nodes.org, we also know the creation date, the user who owns the file, the permission that are assigned to the file, and other information like this. Now, why did I want to talk about all of these concepts? This is not gonna be an introduction to the Linux shell or to the Linux terminals. Later, in the Linux playlist, I'm actually gonna talk specifically about an introduction to the Linux terminal and shell. In this video, I want to talk about command injections, which instead is a web vulnerability. So the idea is that we will have an application that is gonna send the exact same commands, like for example ls, to an operating system, and it's gonna get a response, and we will inject command in that particular flow. So that's the idea. For example, another typical command is the ping command. We can use ping as follows: leonardo.xyz, and here we have a response. We are sending one ECMP probe to the domain which is host my website, and here we get a response back from the command. Now, in our first example, which is the then vulnerable web application, which we can run with Docker, we will exploit the way this command is created by the web application. So the idea is that the web application will sort of like create this command with part of input that is given by the user. In particular, this domain is going to be given by the user. And by understanding how the shell works, we will be able to inject our own commands. What does it mean? It means that not only we will force the server to execute this command, but we will also force the server to execute other commands of our own choosing. It means essentially that we have a remote code execution on the server, and this is one of the highest privileges and attacks that you can do, to execute arbitrary commands on a target server. And we will do this by simply injecting some character. Like for example, if we inject the semicolon in this command and we also write who am I, we will not only execute the ping, but we will also execute the who am I. So in this case, I'm doing this with the terminal, but now we will see how we can inject such commands through the web application so that we will force the web application to execute not just the ping command, but also the payload of our choosing, like for example, who am I? So to do this, I have to start burp. So here I'm starting burp, I will start the browser, and then we will start the exploitation. So here we are, we have the usual setup with the web application on the right. This is the browser. On the left here I have burp, and I've connected the browser to burp so that every request goes through burp. And I've showed how to do this in one of the first videos of the series, so go and catch up on that if you haven't. So we can start, we lower the security level to low, and we can go into the command injection module. So by going into the command injection module, we can start to analyze the low level, the security level low of the damn vulnerable web application. So here we have a simple HTML form. Here it says enter an IP address. So for example, we can put 1.7.0.0.0.1. This is the typical localhost address. And then we click on submit. We wait a little bit, and after a little bit, notice the output that we get. Now, what does this output remind you of? If we remember, I just showed previously that I tried to do a ping, and look at this. Let's do a ping. Let's just do like a ping like this. Notice what do I get here. I get the same type of output. The first line, it says ping 127.0.1, etc. It's the same as this one. Then I have the various statistics for the various pings. It says 64 bytes, 64 bytes, 64 bytes. It says the ECMP sequence, 1, 2, 3, 4. The time to leave, which is always 64. And the time it took to receive the response, which is 0.039, 0.052, and so on and so forth. Slightly different, but overall very close. So, what can we say about this? Well, the idea is that from this behavior, from this output, we can infer that this web application written in PHP, in order to offer the ping a device service, is actually executing the ping command. So the idea is that the web application is calling a shell command, and this command has to do with the ping command, and in the creation of this command there is the input of the user, which is the IP address. Now, how can we exploit this? Well, the idea has to do with injection. So like we have to inject data, a malicious payload that is able to be interpreted by the shell. So a payload that only makes sense to the shell interpreter that we are interacting with. We know now that DVWA, this application, is actually interacting with a shell. And of course, our browser is interacting with the application. This is done through HTTP, and this is done, for example, through the PHP language. Now the question is, wait a second, can I somehow manipulate this interaction? Can I somehow inject malicious commands that are then sent to the shell and executed by the shell? Because if the logic of the application is not robust, is not good, and is vulnerable to common injections, then I will be able to interfere with this layer, with this communication. And this is exactly what we're gonna do. How? Well, for example, if you put 127.0.0.1 and then we put a semicolon and then we put who am I and we execute it, remember it's the same payload that I showed you before here. What we expect is the ping command is going to be executed and then the who am I command is going to be executed. If the web application does not understand this and does not properly sanitize this kind of data, we can get a common execution. I sent the payload, we will wait a bit for the ping and notice what we got back. So we have the output of the ping command, but then we have more. We have the output of the whoami command. And in this case, it tells us that the user that is executing this web application on the operating system level is www-data. So this is the user. And notice that here I can put any command I want. Not only 127.0.0.1 whoami. For example, I can put ls. This is another type of command. And here I get the files in the current directory. Another command could be, look, I want to cut all the users. So I do a cut of etc passwd. And this is another type of command. And once again, here I get the etc passwd of the Docker container that is running the application. So here I can put any sort of command. And if we check the source code of this with the view source, what do we see? We see simple PHP code, and it says, look, if the submit parameter of the post has been set, which means if we are sending a post request, and remember this was the case because here in the request that we send, notice here, look at this, we have always the submit parameter with the submit value. Now the value here does not really matter because we do not use the value, we just check that some value has been set. And so we check, is the value been set? Okay, we have a post request, we get the EP value, which is this one, and then it determines the operating system. Now, why do we need to do this if? Well, the idea is that our web application is an abstract piece of software that can run in many different operating systems. Like for example, I can run a PHP application on both Linux and Windows machines. However, if I want to interact with the operating system, if I want to send a command to the shell, I need to know exactly what operating system I am running on. Otherwise, I will have different commands and therefore different interactions. This is why it does this if. Essentially with this if, it tries to understand if we are on Windows or if we are on Linux-based systems. And the difference here is in the options essentially, because if we are on Linux, we have to specify to do only 4 ECM pings. Because if we do not specify it, the ping command by default would just keep going indefinitely and it will never stop. So we have to specify it. However, in Windows, there is a different behavior of the ping command, and by default, without any special flags or options, it's gonna stop after 4 ping, if I remember well. After a certain amount of pings, it's gonna stop, and this is on Windows, while on Linux we have to specify with the -C4 flag, which says only send this amount of probes, which in this case is 4, to the target. Now, this is an interesting function, shell exec, and it's the same in both Windows and Linux, because of course PHP internally does also this check. So internally it checks, look, are we on Windows or are we on Linux? However, in the user interface that is exposed by the PHP engine, we can just call shell exec. Now this function, as I said, it's interesting because it is the glue sort of that connects the web application with the operating system. And the only parameter it receives, there's only one parameter here, it's a string. So a sequence of characters, which in this case is ping followed by the target. Now, how do we connect the user input to the string that will be executed by the operating system? With a simple concatenation. It means that we do no input validation. It means that whatever the user put on the value of EP is going to be concatenated with ping initially. We will form this string, and this string will then be executed as an operating system command. And this is exactly why, if you understood well SQL injections, you should not have a problem in understanding OS command injections or simply command injections, because the idea is always the same. We have a web app, this web app prepares a string, so there is a string, and then this string is interpreted, there is an interpreter, and once this string is interpreted, some side effects are caused on the computer, on the machine, on the server, and we get back the results. So when we have these 3 components, a web application, a string, and an interpreter, the question is always the same. How do I make sure that the string is well formed with respect to the original intention of the application? Which means that how do I make sure that the string cannot be manipulated maliciously by a malicious actor, a malicious client? How do I divide? Because of course the idea is that this string, by definition, by design, will have to contain data taken from the user, from the browser, from the HTTP request. And of course, this is trivial to understand, because if we put nothing of the client, what kind of service are we providing? We want to provide a service, and typically this service depends on the question, on the needs of the client, of our clients. So we have to construct this string. But the next problem is, okay, but how do I make sure that this string is safe to execute on my system? Because if I just concatenate the command with whatever the user has given me, things can get a lot messy and the attacker can do anything. Like for example, in this case, why could I have a simple code execution like this with this semicolon? Because in the shell syntax, in bash syntax, if we have a semicolon, essentially it says you try to execute the first command and then you execute the second command. It's sort of like a separator, and here I can have a third command and then I can have a fourth command. So here I can have many different commands, and if I put all of them in the same box, so here for example we can say not Leonardo, but let's make sure that we have a different command like 127001. I copy this, I put it here. So we can have many different commands because in the way that the string is computed, so here notice, this is the output of the ping. This is the output of WMI. This is the output of ls. This is the output of cat etc passwd. So we can just keep going. And there are other special characters. So notice here that this semicolon is not just a character in this context, because when it is fed into the shell interpreter, which in this case it's sh on the server, when it is fed into sh understand this as like, okay, you execute the command on the left and then on the right, and so on and so forth. So this command is not a literal semicolon, it is a special character for the shell. And so once again, the trouble comes when special characters are inserted into the string that is then executed by the interpreter. Remember, in the case of SQL injection, we inserted, for example, this special character with select, with union select, with or 1 = 1. So like characters that had a special meaning for SQL, for the database they were being executed on. This case is exactly the same, it's just that the type of characters that we use are different, the effects that we have are different, but the idea is the same. We have an injection when a web application interacts with an interpreter, and when the user of the application is able to modify the interaction between the web app and the interpreter in a malicious way, introducing malicious side effects. So that's the general idea, and this is the lowest level of this command injection. We can just put the special characters, another characters, so like here is the first payload that works. So here, to go faster, we can just avoid altogether the IP address and just put like a semicolon here and then the command we want to execute. And this is gonna do it very, very fast. So we can put whatever command we want here and it's gonna get executed. Now we can move on to the medium level difficulty. Okay, now I switch the level of difficulty. This is medium level. So let's try with the previous payload with this semicolon WMI. Okay, now it doesn't work. Let's check the code. I mean, the request is literally the same. It shouldn't change. The request does not change. Here we do a post. This is the same. It's just that security here is medium instead of low. Now, if you go into view source, notice that now in the medium level, some things have started to change. So the idea is that here we also execute the command and we get back the response, same as previously. But now there is a validation aspect that is being added on for increasing the level of security. So the idea is that after we get the target, after we get the input from the user, which represents the IP address that we want to sort of ping, we have a blacklist. So we say, look, if our IP contains the character end or the character semicolon, then we want to replace those characters. We want to remove those characters with the empty string. And so we say string replace, and we replace essentially, if we find those characters, they are replaced by the empty string. So this is the idea, and this is why the command does not work anymore. Because essentially, here we have, if we do 127 and then this, we're gonna get the first, I believe, we're gonna get the correct ping, but we will not execute the WMI afterwards. It's sort of like if we do just in the shell, here we have the shell, and we do ping 127.0.0.1, then we do WMI, it sort of says this thing. So it sort of goes into error. In this case, the error is handled, and everything else, we just execute the ping essentially. So this works. Now, how do we bypass it? Well, in this case, the approach was to use a blacklist, which means we sort of defined the keywords that we want to avoid, and we try to filter those. Now, the problem with blacklist-based approaches is that if I find a way to bypass this kind of blacklist, I'm still back in the game. I'm still able to execute any arbitrary code. So the idea is that can we bypass this blacklist? And the question is, does this blacklist contain all possible characters that can introduce malicious commands to the shell, to this call to shell exec? Well, in this case, this is not the case because this blacklist is far from being complete with all the commands. So for example, what is another command that can be used? Well, we can try it in our own shell. What happens if we do this pipe? If we do one pipe, we only get the second command, which is who am I? If we do like this, we once again, so like the pipe is another way in which we can sort of like combine characters and then combine commands, execution of commands. So if you do 1.7.0.0.1 pipe ls, what do we get here? Let's see what we get. We get the command, the output of ls. If we do 127 and we do cat std password d, once again, so this means that this is another way to break this system. And the payload this time, so the payload this time is with the single pipe. So the single pipe who am I? And we have common execution. This means that blacklist approach, sometimes they do work, but generally they are not as reliable. You cannot rely on them 100% because someone smart enough might just find the right payload to avoid that blacklist. And when you avoid that blacklist, you can execute anything you want or anyways a lot of stuff. So we can go into the high level. We go into command injection. So this is security level high. And we can check the code. Now look at this. So the way, if you use a blacklist approach, the way to increase security is just increase the blacklist, make it bigger, include all the possible special words. And look, in this case, there are a lot of them. There is the and sign, there is the semicolon, there is the minus, there is the dash, there is the dollar, there is the parenthesis here, there is this other kind of quote, there are the double dash, and there is the single dash. So it seems like, look, we cannot really do anything because these are all the special characters that are interpreted by bash and that allow for the concatenation of different commands. But here there is actually a problem. Let's see if you can spot it actually. Like notice exactly what is being blacklisted. And this typically happens. There is a small typo that makes this configuration actually insecure. Now remember our previous payload. It was, I have a p address, I have a space, I have a pipe, I have a space, and I have who am I. And I can see the spaces with white space mode. Here I can totally see that there are like these two spaces, just things are spaces. So if I just use this for the way that the application is written, I should be fine with this. Like this should not work. Let's make sure this does not work. I execute the ping, that is fine, but I do not execute the who am I because I'm actually being blocked. Now, however, here, what is it that blocks me? It's not the double pipe, right? Because I have only a single bar, a single pipe, not the double one. It's the double, but here the string actually contains the double, the pipe, and a white space. So this thing matches actually, and it is removed. Now what happens if I have the pipe and right after the command? Now in this case, this single pipe and white space is not gonna match anymore. I'm gonna bypass the blacklist. And if we actually try this payload, like here we go into paste, notice what we get. We actually get execution. We get our execution. And if we want to make it faster, we can simply remove the IP address. We have this small payload like this. And once again, here we have remote code execution. Here we can inject commands on the operating system level, and therefore we can execute anything that is executable by the user that runs the PHP engine, the web application running with PHP. And so this is the level high. So if we check from low, medium to high, this initial remediation effort was all based on making bigger and bigger blacklist. Is this, however, the most reliable and stable approach? Is this the most recommended approach? This is not the case. This is not the best approach. Blacklist, they can be useful, but they are generally not the final solution. So what is the final solution? Well, the final solution is to think not in terms of blacklist, but rather in terms of whitelist. What does it mean? It means we know that we want to ping an IP address, right? So we know the structure that the data has to have. It has to be an IP address. It cannot be anything else. It cannot be a string. It cannot be a word. It cannot be any simple number. It's actually an IP address. I have information on the structure of the data that I expect from the client. Therefore, when I process that data, before sending it to the operating system to be executed as a shell command, I want to make sure that my ideal structure of the data is actually respected by the actual data that I'm working with. It means that I have an expectation of the data, but then I have to make sure that that expectation is actually respected, because this is where vulnerability arises. Is when the developers of an application have certain expectations, and then the attacker is able to sort of like bypass those expectations, is able to go beyond those expectations in order to make the web application behave in a way that was not intended. So how do we make sure that we are dealing with an IP address? Well, we go into the impossible level and we see how it's done. So let's see the source code now. And look at this source code. It seems way more complex because it is in a way. So the idea is that here there is a check for CSRF tokens. Now I will not discuss the CSRF vulnerability, which is the cross-site request forgery vulnerability, because this goes beyond OSCP level. I will do it in a later series after I'm done with the other series, but this is not important for our case. The crucial thing here to realize is that we're gonna get the input from the request as before, but now we will first remove all the slashes. We're gonna strip the slashes with this strip slashes function. Then we're gonna explode, we're gonna split the string into 4 octets with the dot. Why do we do this? Because we know that an IP address is an octet here, like for example 25, then another here, then another here, and then another here. We know this is the structure. We know we expect to find exactly 4 elements here. And so the idea is that I'm going to remove the slashes, I'm going to split it into 4 elements, I'm going to check that each element is numeric. So this check is like, is the size of these 4 and are all of these numeric? And then if they are, I'm going to combine them once again, and I'm going to execute a command. So I'm going to check essentially if I have 4 different numbers. And now here you can even make more checks. Like for example, is the number between 0 and 255? This is another check I can make, because once again, I know the structure of an IP address, I know what expectation to have on the data that is sent by the client, and therefore I can validate it. Now this step that is done before the usage of the data is called validation, and I have to properly validate my data if I want to be safe in using it. When we get it from the client, it can be dirty, it can be malicious, and we don't know. So we have to add a barrier. Remember, we have the web app here. So here is the web app, here's the operating system, and here is the interaction, which is done through PHP and through the shell essentially. So PHP is used to construct the shell command that is used to sort of interact with the operating system. So we could say PHP leads to the shell command. And then we have the browser here. Now, when we get the data from the browser, we don't want it to fully control this layer immediately. We want to validate it. We want to put a barrier here. We want to make sure, look, you can only do what I want you to do. And this is the idea behind validation. And this is a very simple but important example of validation. Of course, to implement a proper validation procedure, a proper validation, you have to know the structure of the data. The more you know about your data, and the better you are equipped at protecting your application flows. This is the basic idea. And this is why most people are not secure about this, because either they do not really know the structure of the data at that moment and only later they realize it, or they simply forget to do this validation step, which is crucial, because if you do not have this, then a malicious attacker with enough skill can attack your server and cause a lot of damages. And so this is it with respect to the damn vulnerable web application example. I hope it was an interesting initial example to get an intuitive idea regarding common injection vulnerabilities, why they are important, how you can defend against them with both blacklist and whitelist approaches, and also we also discuss why whitelist is much better than blacklist in terms of protecting your data and validating your data. The more you know, the more equipped you are at defending your application. Having said this, we can now do the PortSwigger Academy. In particular, I brought once again 3 different labs that we will discuss before ending the video. So here we are in the OS Common Injection. There are in total 5 labs and we will do the first 3. So this is the idea. We will start with the simple one, OS Common Injection, simple case. And so we can start with this one. I'm going to do access the lab here. This lab contains an OS Common Injection vulnerability in the product store checker. The application executes a shell command containing user-supplied product and store IDs and returns the raw output from the command in its response. To solve the lab, execute the whoami command to determine the name of the current user. So this is the idea. This is the lab. We can now solve it. So let's explore here the lab. Here we have a shop with a bunch of items. For each item it seems like we have an image, some view details. And if you go down, perfect, let's do view details. Here we have the description. And here we have a list of shops. For example, London, Paris, Milan. And we can check the stock. So we do check stock. And here it says, look, 62 units. So it's sort of like, it seems like it's using an internal API to change this number, right? So if I have Milan, I have 52. If I have London, I have 62. And if I change here item, I go to a different item. Here I have all the same 3 shops with different units. Now, if you check into the burp, here we see that the request that actually is used in this API is the /product/stock request. So for example, here I can say, look at this, I have product stock, and then here I have the response. Now I can go into the repeater, and I can send it again, and I also get 73. So here we have a product ID and a store ID. Now let's try to put something in a product ID here, and it says, look, sh, syntax error, unterminated quoted string. Now remember, we put some special character and we got an sh error. This signals to us that we have a command injection. Why? Because it is the similar case as when we have an SQL, we put some kind of hyphens or like some kind of quote character and we get an SQL error. If a PHP application gives us an SQL error, it means we have an SQL injection. Now, the same story happens with a command injection. If a PHP application gives us an SH error, we have an SH command injection. Now, let's go back to product ID 1. I think it was 1. It was 3. And let's put it here now. Let's see. Once again, we have unterminated quoted string. So what happens if I put one like this, then some space, then a semicolon, and then a whoami command like we did in the damn vulnerable application. And of course, I'm gonna encode everything in URL encoding with a Ctrl-U keybind. I do send, and notice here, I get Peter. So I was able to get the username, and therefore I solved the lab. Of course, I can also say ls, and it says the script. I can also say cat stockreport.sh, so I can get the value of this script essentially. And this script, notice what this script does. It simply uses here, number 1 and number 2 are the arguments that are used within the script. And there is no validation, which means that if the second argument contains a semicolon, here a semicolon is going to be put here, and it's going to be interpreted by the eval function here, and therefore essentially we have a common injection. So this is the vulnerable code. Of course, you can analyze it in depth, but the idea is that by manipulating this value with special SH characters, we are able to introduce malicious payload and execute them. So that's the first lab of PortSwigger, and we can go on the second lab. So it's not this one, but rather it's, so it's not this one, where is it? OS common injection is this one, this blind OS common injection. So we do access the lab, we wait a little bit, and then we put it into target. So I started the second lab. Notice that in this case, the lab, it tells us that the lab contains a blind OS common injection in a feedback function. The application executes a shell. However, the output from the command is not returned directly in the response. What does it mean? It means that instead of getting back directly the output, the idea now is a little bit more sophisticated. The idea essentially is we want to cause some side effects that tells us that we have control over the command. In this case, the side effect that the lab is asking us to perform is a time delay, a 10-second delay. So we can access the lab here. Notice that we have the same shop as before, with no stock here, but we have the submit feedback. And in the submit feedback, we can put various stuff here, right? Submit feedback, and here we can put an email, like for example test.@gmail. Now we have captured this request, of course, it's a post, submit feedback here. So let's try to put something in the name here, like this kind of character, and nothing changes. Let's put it into the subject, and nothing changes. Let's put it into the message, and nothing changes. Let's put it into the email, and it says internal server error, could not save. So if we put these characters on name, subject, and message, nothing changes. We cannot understand if anything has been done differently by the web application. However, if we manipulate the email and we put these special characters, suddenly we have a 500 internal server error. Of course, this does not mean that we have for sure a common injection. However, it is interesting to notice that the web application has problems handling this case. So we can go and do like this. Okay, let's put space, semicolon, sleep 10, and we are encode all of this, and send a send. And it says once again, could not save. Let's put a semicolon here after the 10, and notice what happens here. It's not answering us immediately. Let's see if after 10 seconds the server answers to us. If it does, we have a win. And look at this. The reply time was 10,000 milliseconds. So we have 10 seconds of reply time, and we have solved the lab. So here the payload was this one. So this is the payload, which I can send to Decoder. So Decoder, and I can say decode as URL. So this is the payload. We have the email, then a semicolon, then the malicious payload, and then another semicolon. If we do not put this final semicolon, the command does not work, and it just says internal server error immediately. However, if I put this other semicolon, I can control it. I can, for example, say sleep me for 1 second, and I wait 1 second. Sleep for 2 seconds, and I wait 2 seconds. Sleep for 3 seconds, and I wait 3 seconds. At some point, we realize that we actually have control. Now, how do you exploit, how do you get information out of this time delay is a complex matter that can definitely be learned, but it's content for other videos in the future. I think it's a really cool thing, but for now, let's just focus on completing the final lab. But the idea is that this kind of information can be used to exploit and extract information from the server. It's just that we do not see directly the output, but we have to go it into more complex ways. We are still able to inject commands. It's just that we do not see the output. So this is the second lab, and finally this third lab. So let's go access the lab. And here it says, the application executes a shell command containing the user supply details. The output from the command tool is not returned in the response. However, you can use output redirection to capture the output from the command. There is a writable folder at var www images. So that's the idea. So we can execute our command and we will redirect the output of the command into that specific folder. Now, to learn how to do this, you need to understand how output redirection work, for example, in Linux systems. And as I said previously, in the future, I plan to make a video on how the shell works on Linux, but the general idea, the very fast, too long didn't read idea is this. Suppose I have an echo command, just prints out the hello. If I want to redirect and say, look, I don't want you to be printing on the terminal. I want you to be printing on a file. And then I redirect the output, the so-called standard output, which is also called stdout. I will do a redirection and I will say, look, the standard output, do not write it on the terminal. Write it on a file called, for example, output.txt. I execute the same command. Notice I get no output back from the server. However, if I do an ls, I have a new file, output.txt. And if I open this new file, it contains hello, which means that I have redirected the output of the command into that folder. And this is the idea for this lab. We can sort of like, let's put it into the target. So here I remove this from the scope. I think I have to remove this and I have to add this one. So I'm gonna clean the history here. So what's the idea here? Okay, we have submit feedback, I think. So let's submit a simple mail, test. Let's try to put characters in the various fields. For example, here, and nothing changes. Here in subject, and nothing changes. Here in message, and nothing should change. And then here in test mail, in email, and we get an internal server error. So the point of injection seems to be the same. Now in this lab, they want us to retrieve the value of the whoami command, right? So what do we do? Well, we can do like this. Let's do semicolon, whoami, redirect output to, for example, var www images wmi.txt. Let's see if this works. Of course, I have to encode everything in URL encoding. Let's see if this works. It does not work. Maybe I can do a semicolon once again. It still does not work. However, let's see if this has actually been taken. I'm gonna check. I can go into the image, file name equal 31.jpg. Let's do wmi.txt. And notice here what do I get. So the idea is that the command actually worked. So let's review slowly the flow. Here I have this form, this feedback form essentially. I have submit, no, this is the other lab, I think. Yeah, or no, I think this is the correct lab. So that was the correct lab. So the idea is that I have this submit form, and this is the submit, is the request, is the HTTP request it sends when it wants to submit something. I change the email field with this thing, send to decoder, decoder's URL. So this is the payload, and notice in this payload, I'm gonna actually zoom in because with burp I cannot really zoom in properly. So this actually, let's do into this other buffer, and let's remove the white space mode. So this is the final payload. It was the original email, then a semicolon, then the injected payload, and then another semicolon. Now this injected payload is the whoami command with an output redirection. And the output redirection writes to a file that is writable by the PHP user that is executing this command. Otherwise, I will get a permission error, but that I can also access from outside the PHP engine. Meaning that after I've written the output of the whoami command into the whoami.txt file, using the browser, here using Chromium, I can also go, like if we just check the images, how are these images given to us? Well, we just go here and we say, look, here it says a file name equals. So if you go file name equals whoami, I'm reading this particular file which contains my output. Of course, notice that here I could also put, like, for example, let's put into the repeater, not this one. So here I can do with inspector. I can say, not this one, but I can say cat etc passwd, for example. And then I refresh it. So I have to send it, of course. First I have to send the request. Then I refresh the resource. And notice here what do I get? I get the etc passwd of the lab of this of the content of the server that is running this PortSwigger Lab. And this was the third and final example that I wanted to bring when it comes to command execution. I hope all these examples have helped to understand what is the idea here. As I say, the idea is actually pretty simple and it has to do with injections. We have a browser, we have a web application, and we have an interpreter, which can be SQL interpreter or an OS command interpreter. And the idea is that can we inject something in that flow? Can we give something to that interpreter that it shouldn't have? Is the logic of the web application vulnerable to this kind of injection? If it is, we have just found a remote code execution. Of course, to actually analyze the risk, we also need to understand what is the context of the server running these commands, what kind of data do we have access to, and things like that. So it's not that trivial. But that's the general idea when it comes to the intuition behind command injection. I hope the video was enjoyable. If you find it so, please leave some comment, spread the video, subscribe to the channel, and just let me know what you think of it, and to the next video. Hi everyone, and welcome to this new video in which I continue my web exploitation series. In this video specifically, I will talk about cross-site scripting, often abbreviated as XSS. Now, there are many different kinds of XSS. For example, we have reflected XSS. Reflected is the first kind. We have stored, we have DOM XSS, and so on. Now, the idea, however, is that all of these attacks are client-side attacks. And so in this video, we will discuss what does it mean to have a client-side attacks and why XSS is the first client-side vulnerability that we actually discuss in this web exploitation series. Now, since I'm targeting this series for those of you who want to do OSCP certification, I will not discuss in super depth about XSS. And indeed, I will just briefly mention the three types with some examples for each type. I will not do too many examples, however. This is because for doing OSCP, you do not need too much of XSS. You need XSS if you want to do bug bounty or if you want to do pen testing, and later on I will of course make more detailed videos about XSS, but for now, for targeting this series just for OSCP certification level, I'm not gonna go too much in depth about XSS. Anyways, I hope the video is interesting. I hope it gives you a good overview about what is an XSS, a cross-site scripting attack, and I hope you get something out of it. If you have some feedback, please leave it in the comments, subscribe to the channel to support me, share the video with the people you think are interested in this kind of content, and that's it. We can actually start the video. Now, I will use the dem vulnerable web application to explain this vulnerability, so we can run the Docker. This is the command to run the Docker. Here I have already the normal setup, so we have burp on the left and the browser on the right, and the browser has been started with the flag that tells it to proxy the traffic through burp. So burp will act as our man in the middle for analyzing the traffic. So we can log in into the web application with the credential admin and password. So admin and password. Let's go again because the token was incorrect. Okay, we have the setup here. We can say create or reset setup and we can do login. So we can say admin password. And now here we can go into the security, it's low, perfect. And then here are the three levels for XSS. We have XSS DOM, XSS reflected, and XSS stored. I will do a small example for each of them, but I will start with the XSS stored. However, before discussing the vulnerability itself, I will talk more generally about the idea of client-side attacks and why having a client-side attack is very different conceptually from having a server-side attack. So to explain the idea behind client-side attacks, let's go back to what we already covered in this series. So we discussed about SQL injection, we discussed about file inclusion and file upload, command injection, and also path traversal. So we discussed about a lot of attacks, right? But all of the attacks, all of the vulnerabilities that I showed in the previous video were always server-side vulnerability. Now, when we say server-side vulnerability, what we are saying essentially is that the target of our attack is the server, or anyways, something that is stored on the server, something that is saved on the server, maybe an asset saved within the server, like data in a database. So this is the target. For example, SQL Injection. They attack the database. They attack a server-side component, a component that is on the server. The same thing for file inclusion and file upload. Both of these vulnerabilities, they attack the server because they can allow maybe a malicious attacker to obtain remote code execution on the server. So the target is always the server. Now instead, when we talk about client-side attacks, what we are saying is that the target of our attack is not the server itself, but rather it is another client of the application. So for example, here we have DVWA. So this is an application, right? And we have DVWA. Now this application is used by multiple users. I can be user 1 and I can be user 2. I have many users that use the application. With a client-side attack, the idea is to use the logic of the application in a way that I'm not targeting the application directly. However, I'm interacting with the application in order to attack another user. For example, I could be user 1, I could be a malicious user, user 1, and I could interact with the application in order to attack a different user, user 2. Now, what does it mean to attack a different user? Well, for example, I could steal the other user's data. I could steal cookie that contain session information. So like, what is the current session of the user 2? Maybe I can steal it. And once I've stolen it, I can impersonate that client within that application. And I can access his data. And maybe I can perform transactions using that particular account that I just impersonated. So the most important thing to realize is that with client-side vulnerabilities, we are targeting the other clients of our application. Now, this does not mean that from the point of view of the server, of the developers that write the code that runs on the server, these vulnerabilities are less important. Actually, they are extremely important. This is because if by using your flows, if by using the flows that are encoded in your application, a malicious user is able to attack other users of your application, well, the other users will not trust you anymore, so they will not use your application anymore. So the idea is that it is client-side, but it is still extremely dangerous to have. And now we can start by analyzing this XSS stored. So let's try to analyze this functionality. This functionality allows us to post comments on this page. So for example, we can say Leo, and we can say, please subscribe as a message. And then I can sign the guestbook. Once I've signed the guestbook, anyone, by going into this page, will see this specific message. And I mean anyone. So the key aspect to realize here is that this message is visible by all the other users of the same web application. Right now I'm logged as admin, but if someone else logs with their account, then they will see this message. And there's nothing wrong with this, right? This is not a vulnerability yet, it is just a functionality. And if we check how it is implemented, we can expect to have a simple form, and here indeed, this is the simple form. So we have a form that does a post to the endpoint guest form. Then we have the various fields, right? And we can just intercept, for example, the communication, and I say Leo, and this is like test. I'm gonna assign. So this is the HTTP request that is done to fill up this guestbook. I can intercept the response. I do forward. Here is the response. And notice that in the response, I'm getting the contents of this signbook here. Let's see. This is it. Div ID equal guestbook comments. Div ID equal guestbook comments. So we have a series of divs, one for each comment, that contain the content of the comment. So the initial one was the test one, and then there were the two mines, the two like posts with the name Leo. Please subscribe and test. So that's the idea. If we do forward to the browser essentially previews this for us and for every other user in the application. So where is the vulnerability here exactly? Well, the idea is this. Consider what happens when, for example, in the name we put Leo, but in the message we put script alert1, and then we close the script tags. Now, what is this code? Well, this is a JavaScript code. What is JavaScript? It is a language that is interpreted by the browser. As we said in the initial episode of this series, the browser is an extremely complex piece of software that is able to interpret various languages such as HTML, CSS, and also JavaScript. While HTML gives structure to the web page and CSS gives style to the web page, such as colors and things like that, JavaScript is used to make the web page dynamic. It means that now the user can interact with the web page and the content will change accordingly without sending more requests to the server. It's sort of like we have put in JavaScript the logic necessary to change the page without sending other requests to the server. And this is done by manipulating a structure called the DOM, which stands for Document Object Model. It is essentially the abstract representation of the HTML code. When the server replies to our HTTP request, it sends to us HTML code. I mean, look at this. This is HTTP, right? Okay, but why do we use HTTP? Well, we use it just to send HTML. The end result is HTML. When the browser gets this HTML, it renders it, right? And we can check the rendering by doing into the DevTools here. We can actually put it here down. I think I prefer it like this. So here in this Elements tab, we actually see the DOM being rendered, which is this representation for the HTML. This HTML is parsed and it is put into a tree, and this is the DOM. And JavaScript allows us to modify this DOM to interact with this structure, which is a tree, and we can change it up and stuff like that. To do that, we have JavaScript. We have the console JavaScript and we have the JavaScript tag which contain JavaScript code. This means that HTML includes both CSS tags and also JavaScript tags. When the browser gets the entire HTML, he sees, okay, this block is a CSS and I will use the CSS interpreter for that. This block is JavaScript and I will use the JavaScript interpreter for that. So for example, what happens when we do an alert1 in the console? Well, we just get a simple message, alert1, because we have executed some JavaScript code in our page. So this is the idea. I repeat, why do we have JavaScript? Is to make the web page dynamic with respect to the manipulation of the DOM, and also, for example, with the interaction to the web servers and stuff like that. So it's to give more functionality to the browser. This, however, comes at a price, because now we can execute this kind of code. Now, what happens when the user tries to write this message? So we have the name is still Leo, so there's nothing special about that. However, in the message field right now, we have some special characters. These characters are identifying a JavaScript piece of code. If I just do sign guestbook just like that, notice what happens. I press OK. I'm gonna intercept the traffic here, okay? So I press OK here. The browser sends this request, which is captured by BurpSuite. And here I can see it's making a post. This is the endpoint. The host is localhost because it's a local application. Here is the payload. In the content type, we also specify application/xwww form URL encoded to say, look, the data of the post is sent in the body and it is URL encoded. So this is really useful. And then in the body, we have our parameters, which are text name, text message, and BT sign. Now, BT sign is the action we want to perform, while text name and text messages are the parameters, is the data that we want to use while performing this sign guestbook action. And of course, this data is, as I said, URL encoded. So we can visualize it like this. We can open inspector, we can say URL encoding, and this is the URL decoded data. So let's now intercept the response. So we send this to the server, and this is our response. We get a 200 OK, so the server is saying, look, everything went fine, and here is the resulting HTML. Now remember from the previous response that in the HTML, we also get the content of the guestbook that was signed by the various users, right? With the message that was used by the various users. Well, notice here now what happens. We have the first messages, which are trivial and they do not pose a threat to the security of the application. And then we have this other div, which contains our latest message. Well, notice what is inside the message here. It's message, these double colons, this colon, and then it's like script alert 1. What does it mean? It means that now we have inserted the JavaScript code within the response. So when the browser will read this response, it doesn't really know where this JavaScript comes from. It just sees a JavaScript tag, a script tag, and it just executes it as if it were JavaScript code using the JavaScript interpreter. So again, they say forward, and notice here what we get, 1. It means that when we try to read this page, we also executed the JavaScript. But the most interesting thing of this all is that it is an XSS that is stored. And being stored means that the payload is now saved onto the server. So anytime we go back to the page, we will get the same execution of the same JavaScript. Now, is this to be considered a security threat, you might ask? And this is what we really need to understand in this video. For doing OSCP, you don't really need to know this kind of attack too well. However, it is extremely important to understand in your career as a penetration tester why this is actually an extreme threat to the vulnerability of a system. Now, let us ask ourselves, is this behavior problematic? Does this behavior pose a real threat to the users of the application or to the server that is running the application? And the answer is yes, it does. It is extremely powerful and dangerous. This is a mechanism which could be abused to create havoc throughout the application. Now, why? Consider this. Here I have the viewpoint of the one who inserted the payload. But now let's try to split our viewpoints. So someone else inserted a payload there. We do not know. We are not that user. We are just browsing the application and we are having fun maybe. And then at some point we stumble upon the page that has JavaScript, that has the JavaScript payload. Now the question we have to ask and answer is, well, who put this code? Why suddenly is now some JavaScript being executed on my browser? Well, the idea is that who put this code was a different user, which could have also malicious intentions. So what could it happen with a user with malicious intention? Well, a simple alert 1 of course does nothing. Like, okay, he executes alert 1 on my machine, what's the problem? However, JavaScript is way more powerful than that. A typical attack in using this kind of XSS is this. The JavaScript payload actually will do an HTTP request to an attacker control payload, and in that request, he will put some sensitive data belonging to the user and to the browser session that the user was having with the application. So the idea is that no longer a simple and trivial alert 1, but rather I go into this page and suddenly some malicious JavaScript is being executed. JavaScript that I do not choose to have, JavaScript that the original developer of the application did not choose to write, but rather that was written by a malicious actor. And when this JavaScript executes on my machine, then I could lose sensitive data. And this is the key to understand why this vulnerability is very dangerous to the security of a web application. So let us now see a real attack and how it plays out. This will help a lot in gaining some intuition on why this kind of attack are actually quite dangerous. So here I cleared the guestbook. So we can put messages, but we can also just clear the textbook, and it's really simple. So the idea is to use a way more complex payload than simply alert1. And the payload that I want to use is actually this one. It's still relatively simple, but it's a little bit more complex. So let's try to understand it. Here I'm using JavaScript to make an HTTP request. However, the request here is to an endpoint that is controlled by an attacker. Now, in this example, of course, I'm still gonna put localhost because this is a demo. I'm running everything locally, so I am both the target and the attacker. But you should imagine that here is actually a URL that is controlled by an attacker. Now, notice the cool thing here is that in this URL, here I'm doing a get, I'm putting the value of document.cookie. Now, what is document.cookie? If you go into the browser, the JavaScript can access this cookie actually. We can say document.cookie. It can access this cookie because not enough security configuration has been done on this server. There are ways in which you can disable JavaScript from accessing this value. In this case, it is still enabled, so it is dangerous because it means that we can steal it through an XSS. So of course, for this example, I'm just gonna say when it is enabled and when we can access it. So with document.cookie, the JavaScript interpreter, the JavaScript environment is able to get the cookie of the page of the user. And with this cookie, we can of course impersonate the user on the application. Now, however, right now we are running on the browser of our target, of our victim. So of course we see the cookie. However, we want to extract it from the attacker server. So what do? As we said, we have to have a server running on this endpoint. How do we do that? Well, we can simply use Python. So we do Python 3-m http.server1337. So this is gonna simulate our evil server that is waiting to get the cookie of the user. And this is the JavaScript that we want to execute on the target browser. It means that the victim will execute that JavaScript. That JavaScript will send a GET request to my attacker control web server, and here in the log of this server, I will get the cookie of the user. So how do we do this? Well, it's simple. We use a different user, and we go into the web application and we write a message and we put this payload. Now notice here what happens. It seems as if we are blocked, right? Because we cannot write too many characters here. However, this limitation is only an illusion because it is not enforced server side. It means that if we use the browser, we cannot write more than this amount of character. However, we can simply do this. We can just get the request with burp. We can intercept it here, we can intercept it, and we can change here the value to put our malicious value. Here I'm going to, of course, encode everything in URL encoding. So at this point, I'm going to forward this. It did not work. Okay, so this did not work. Why? Of course, because I made a mistake. So what kind of mistake did I do? So here we can just drop this. Here we can go into... So here we have the history, and here we actually have to put our payload. However, I forgot one thing. When we put JavaScript within an HTML content, within an HTML document, we actually have to wrap the JavaScript code with the JavaScript tag. So here we have to say script like this. Then we remove all the new lines, and then we put all in one line like this. And so we can once again just write this here. We can once again encode everything in URL encoding, and we can once again write it. We can send it to the server. So we can, okay, it said okay. Now we go back to the page. Notice what happened to our attacker control web server. So now our victim went to the XSS stored page, and our attacker received a GET message. But the key aspect here is that in this GET, we have leaked data that is sensitive to the client. We have leaked the PHP SSID, which is a session cookie used by the application to manage user sessions. If you go on the page again, once again, we have the same session, but you can imagine that for every user that visits this page, we will get their session cookie. And now you can see why among all of the various XSS, the XSS stored is actually one of the most dangerous, because it is a client-side vulnerability, meaning that it attacks the clients of the application. However, with the cross-site scripting stored, the payload is actually memorized on the server for long-term storage. It means that all the user who ever load the page will get the payload, and this makes it extremely dangerous. Because we can, for example, steal all the session IDs, or maybe we could script using JavaScript some action within the web application, like send me some money, maybe in a banking application, or maybe delete the account, or maybe change the password of the account. And depending how these actions are implemented with JavaScript, we might just be able to perform those actions and to, for example, maybe impersonate or like get access to the accounts of other users and things like that. I think at this point you should get the idea. This is a very dangerous vulnerability, and this is just the first type, the XSS stored. Now, to continue this video, I'm not going to do the other difficulties like medium, high, or impossible of the XSS stored, but rather I'm going to talk about the different two versions of XSS. Because the same vulnerability, which has to do with the injection of JavaScript code to the client browser, the same vulnerability can be done in different ways depending on the dynamics that allows the attacker to inject JavaScript to the client browser. So depending on the dynamics of the attacker, we have different kind of XSS. The stored is just one of the most dangerous one. And it's also conceptually simple because we just have a server that stores some data. And in that data, this is an attacker maybe. This is an attacker and this is a normal user. This is attacker and this is user. Within a store XSS, the attacker does some request to introduce an XSS payload here. And the next time the user does the request, he gets the payload, and so the attacker is able to introduce JavaScript on the browser of the user. And this is the XSS stored. When we instead talk about the XSS reflected, the cross-site scripting reflected cross-site scripting, the situation is a bit more nuanced. Why? Consider this form. We have a simple what's your name form. We can put a name, Leonardo for example, we can say submit, and we have our result. Now notice what happens when we put, like, for example, bold Leonardo. So we are putting some HTML tags here, right? Notice that these tags, they are not escaped, they are not encoded, they are displayed exactly as we put them in the form. And indeed, the bold have as an effect on the page itself. We have modified the HTML itself. So once again, a key thing that you need to learn is to understand, to reason about this kind of behavior. We have to ask ourselves, is this behavior a potential vulnerability threat? Is this a vulnerability? How and why? If we have to reason about this, the first thing we have to do is we have to try to make it like exploitable. We have to make an attack out of this. We have to make a scenario in which we can potentially steal users' data, or we can change the state of the application in a way that was not intended and that can have dangerous effects on the user. So we have to reason about these kind of things. Well, in this case, once again, if the bold tag had a direct effect on the HTML, let's try with a script tag, like alert1. What could be a good hypothesis here to have? It could be that the web server simply gets this value from the form and simply sends it back as it is, without any proper validation, without any proper encoding. And so the browser just gets the script alert1, which means that it will just execute the alert1. If we do the submit, what do we get? Indeed, we got the execution of the alert1 script. Now, to understand the dynamic here, the dynamic involved here, it's a little bit more complex, right? Because the idea is that we have a GET request here. So this is the GET request, and this is the response. This is the response to our GET request. Now, our GET request contains some payload, and then this payload is processed by the server, and the server sends to us simply the final HTML. Now, in this final HTML, notice here at the end, what do we have? Here, hello, script alert1. So it's sort of like this payload present in the request was able to like form this output, this script alert1 script, and this is going to be the response of the server, which is going to be sent to our browser. At this point, the browser simply sees a script alert1 and simply executes it. It's not a vulnerability of the browser because the browser was intended to execute script tags like alert1 and things like that. The problem here is that an output of the user was able to introduce JavaScript on the server response. Now, of course, here the key aspect to remember is that this response is not stored on the server. This response is computed on the fly just for our request, to reply to our request. So the flow is, we make a request, the server make a response, and this response contains some JavaScript code, because our request contains some malicious payload. So it's sort of like we reflect back the malicious payload and we trigger the execution of the XSS, of the JavaScript. Once again, can this be weaponized? Is this dangerous? Yes. In a different way than the XSS stored, there is a different level of risk involved here. However, it still can be dangerous. So consider we have all the tabs closed, right? And this is our victim client that we want to attack. And through a phishing scenario, we induce the client to click on this link. So he goes here and he puts this in the URL of the browser. And then we get JavaScript execution. Now, once again, this JavaScript execution can, for example, steal cookies. So we can have the same scenario as before. So we remove the server before and we create it back again. So we have once again this Python server. We have once again the malicious code here. But now the payload is going to be inserted into the get parameter here. So we have this. Of course, this actually must be URL encoded. So must be URL encoded. I'm going to go here. I'm going to paste this. And I'm going to encode as URL. So this is my payload. And we say, we force the client to click on this. Of course, it doesn't really look trivial. However, let us assume that through phishing, maybe we can hide the link. We can do some other kind of phishing attacks. And then we say, okay, the client is going to click here. Notice once again, what do I get? I get the cookie of the client. Now, of course, as I said, is this still a vulnerability? Yes, it is. However, there is a different level of risk. Because with a reflected XSS, we also need a phishing component. We also need other vulnerabilities to trigger it. And this has to do with the fact that with a reflected XSS, the JavaScript payload is reflected back to the request. So there is a request with a malicious payload, and then when you do that request, the server responds with a malicious response with some JavaScript. However, it only responds that to the request that contain a specific malicious payload. So we have to force the client into making that specific malicious request. The client wouldn't do it on its own, right? Because we don't want to put JavaScript on our own that sends our info to an attacker. However, if we can induce a client to perform this request through other vulnerabilities, right? For example, through phishing, then the client will make that request, the server will respond with that extra JavaScript, and then the client will execute it automatically, and this will trigger the vulnerability, and the attacker gets the data. So the difference here is in the threat model. The type of scenario in which an XSS store can work are different than those in which a reflected XSS can work. Different scenarios that have to be analyzed differently, but it is still a vulnerability. And once again, the basic idea is we want to get some information out of the user. And if we check the code, here we see that the server does nothing essentially. It just prints on the output page the parameter exactly as it received from the client. How do you even fix such a vulnerability? Well, the idea here is that you do not want to print out exactly the same value that you got. You want to encode special characters. For example, the script tag. you want to encode those characters because those characters can be dangerous. By encoding them, you are separating the good script tag that your application has from the one that were introduced by malicious actors. However, given that this video is not a video on remediation of XSS, but it's just to build some intuition regarding XSS, we can just move forward to the next vulnerability, the last one, which is XSS DOM. These are the most sophisticated ones. Now, at this point, we discussed about XSS stored, XSS reflected, and we analyzed the difference between these two. In the store case, the payload is actually stored on the server, which means that every client will access it when they browse that particular page that is vulnerable. In the case of the XSS reflected instead, it's a little bit more complex, right? Because the payload is reflected back only to that specific request and not to other requests. To trigger the vulnerability, you have to make a specific request. Now, in the case of the XSS DOM, it's even more complex than that. And it has to do with the DOM, which is the document object model that we discussed previously, and it is the HTML representation in memory that is created by the browser. So the browser receives the HTML page, it then parses it, and it then creates this abstract structure that is saved into memory. This is the DOM. Notice that, for example, here we can interact with the dev tools of Chromium. We can say, look, like this, select an element to inspect it, and here we are essentially navigating through the DOM. Anytime here I click on something, on the lower side of the screen, it opens up the relative DOM element. For example, vulnerability DOM-based scripts, cross-site scripting XSS, and here I can edit. I can remove this stuff, and I'm changing the page. I'm editing the DOM, and I'm changing the page dynamically. Now notice here the format we have is still difficulty low, and we're going to discuss DOM XSS. Now notice this thing. So we have English, French, Spanish, German. You can select a language, and that's it, essentially. Nothing much changes. And notice that when we select a language, here in the select, there comes as a first option Spanish, and this is German. Now, if we look into the page itself, we go to view source page, we have essentially this JavaScript. So we have this script tag, which is executed every time. So we say, look, here, the way the select statement is created, the way this element is created in HTML, in the HTML document, is through JavaScript. So here the JavaScript is used to form the DOM, to give structure to the DOM. In particular, here we have this document.write, document.write, document.write. Document.write is a method offered by the JavaScript API that allows you to modify the DOM structure, to write within the DOM structure. And in particular here, for example, we are writing the tag option value equal English, option value equal French, then we close the option French. So we are writing the various options using JavaScript. So what's the problem here? Where's the vulnerability here? Well, notice this. So the first line here is that, look, if document.location.href index default equal is greater or equal to 0, then we go into this if. And then, essentially, we take the language and we write option value equal lang, decode URI lang, and then we close an option. Then we write this dash dash dash. So essentially, we write this thing here. And notice up on the page, default equal French. So essentially, in these two lines of JavaScript, in this first line of JavaScript, we are extracting the value of the default equal. So default equal is a get parameter. The value, for example, here is German. We are extracting this, so lang is gonna be German, the string German, and then we are using it to write as a first option, lang. However, here we use the method decode URI lang. So we are URL decoding the parameter. Now, what can we do with this? What happens, for example, if here I put, let's try to put like script alert1 script within the default parameter. Notice once again, what did I get? I got an XSS. So very, very interesting. Now, one of the most complex things to understand here is that now if we check on the page that has been created with this payload in the default here, we go here, then we say, look, we can just disable this, we go here. Notice here, in this select, the first element of the select is actually a script, and this is fine. And then we have this other option value. So this is the default script. Then on the first option value, inside we have another script. And this is the script that we actually execute. This is the script that is actually malicious. Now, the thing here is, how does it work exactly? What's the difference between a reflected and a DOM-based XSS? Well, the idea has to do with where the payload is created. Who creates the malicious payload, the server or the client? In the DOM XSS case, it is actually the client itself that creates the malicious payload. While if we remember from the reflected XSS, it is reflected by the server. So it is the server who creates it, reflects it back to the client, and then we have execution. In the DOM, it's even more nuanced than that, because, for example, we can say this. So we can say, let's do like, so we have default. So here we have the parameters, right? So here we have the parameters. Let's open burp. Let's go to intercept. So intercept. So this is the request to intercept, right? And for example, let's try to intercept the response. So we do intercept the response to this request. Now, in this request, there's nothing, of course, malicious. And in the response, so we do forward, this is the response. In the response, nothing, that there's also nothing malicious. Now, what happens if we put a malicious payload, right? So we put a script, alert1, script, right? So we put this. And then we say, okay, now we have once again intercepted the request. This is a get. Now here, this is actually quite malicious in terms of payload. However, let's see how the server processes it. And we do intercept response to this request, and we get the response. Now, the key to understand here is that in this response, actually, there is no JavaScript tag malicious. There is no malicious JavaScript tag. Here we do not see the alert1. Why do we not see that? Because the alert1, the script alert1 script, the malicious tag, the malicious JavaScript, is actually constructed by executing this script. It means that when the client browser receives this response, it receives this script tag, which is a good tag. It's one that was intended by the developer, right? However, in this tag, the JavaScript will change the DOM and will introduce within the DOM the XSS. And in particular, the line that is vulnerable is this decode URI lang, because lang is obtained from the parameters of the request, which is the malicious script tag, and then you just put the script tag into the body. And this is why when you forward it, you get an XSS. So the idea is that in a stored, we store the malicious payload on the server, and then the server distributes it to everyone. In the reflected case, we create a request with a malicious payload, and the server replies with the payload in the response body, in the response HTML. So the server creates the payload and puts it into the HTML. In the DOM case instead, the server does not put the payload in the HTML directly. Rather, the server simply replies with the typical JavaScript of the application, and it is the JavaScript of the application client side that puts the malicious payload in the client side itself. It's sort of like the DOM is modified by the initial JavaScript, and this initial JavaScript introduces into the DOM the malicious JavaScript. And this is why it's called DOM-based, because through manipulations of the DOM, malicious JavaScript is inserted into the page, which is then executed. And this is a simple example. Notice here that server side, here the server does nothing, so we have to stop intercepting this. Here the server does literally nothing. Now these types of vulnerabilities are actually quite sophisticated, because sometimes you might even be able to hide the payload from the server. Now in this traditional exploitation, we just send the entire request, so the server actually received this malicious payload. It did nothing with it, it just gave the normal response to the client, but it still saw the payload, right? However, we can make it even more nuanced than this. How? By simply put an hashtag here, we are gonna exclude this part from what the server sees. Now if we send the request here, notice that here the server sees literally nothing. It does not see the value in the URL because this is called an anchor in the URL and it's only client side. However, if we intercept the response, we just see normal HTML and JavaScript, sure, but this JavaScript is the typical JavaScript that is served by the application. No vulnerability here. However, with this URL here and this JavaScript here, when the browser reads this JavaScript and executes this JavaScript, the malicious one will be added to the page and executed. And thus, we get an execution even though the server sees nothing. How can we use that? For example, with phishing attacks, we can make a user click on the link, the server does not even see the malicious payload, and we get JavaScript execution on the victim browser. We can get their session cookies, we can do actions on behalf of their account in the application, we can do dangerous things. And so this is the basic intuition behind cross-site scripting in its three forms, which are DOM-based, reflected, and stored. Of course, this is not the whole story, because there are various mechanisms here that they have been developed throughout the years in order to protect as much as possible from these attacks. Here I did not talk about the security you can enable at the level of session cookies. I did not talk about the content security policy and stuff like that, because this is just an introductory video. So remember that in the real world it is not this simple. There are certain configurations which allow you to protect much more and to make your app way more robust against this type of attack, but this is the general idea. At the end of the day, it is dangerous to allow the execution of JavaScript code, so when you get a field from the user, be careful to simply reply it back, because you might trigger a reflected XSS. Be careful also in storing it somewhere in the database and then in displaying those values into the HTML without proper encoding, because once again you might trigger a stored XSS. And be careful on how your JavaScript process the information, because you might trigger a DOM XSS. And that's it, the video is over and to the next video. I hope it was an interesting watch. Hi everyone and welcome to this new video in which I continue my web exploitation series. Now at this point we are almost done with the series. We have seen a lot of different attacks and so far these are all the episodes that we've covered from 1 to 8. An introduction to web exploitation and web application. We discuss about BurpSuite, which is one of the most used tools in this context, in the context of web exploitation, and then we started to see specific attacks. Now, the way that I chose this attack were in regards to OSCP. So my objective was, let's reach an OSCP level, a level that you can comfortably do OSCP with, and let's analyze the main vulnerability you will be required to exploit. And these are SQL injections, directory traversal, file inclusion, file upload, common injection vulnerabilities, and at the end I also wanted to mention cross-site scripting. Now when it comes to cross-site scripting, I do not think you need to be an expert in XSS when it comes to OSCP. Probably you won't even use it most of the time. However, it is important to know it, and I wanted to put in this introductory web exploitation course because cross-site scripting, XSS, is a first example of client-side vulnerability. So I wanted to discuss a vulnerability that attacked the client and not the server, while the other, SQL injection, directory traversal, and so on and so forth, they were server-side, meaning that their objective was to attack the server. Now that we've seen all these different attacks, at this point I want to talk about enumeration, and in particular the next 3 videos will all be about enumeration, and they're gonna be about, this one is enumeration of files and directories. The next one instead I'm gonna talk about enumeration of virtual hosts, and what are virtual hosts and how they work, and also the difference between virtual host and DNS domains. And then we're going to talk about the enumeration of parameter. So like get parameter, post parameters, how do you discover the parameters of a page and stuff like that. The 12th episode we will talk about brute forcing credentials. So this is with respect to maybe HTTP login forms, but also maybe SSH instances, FTP instances. It is true this series is all about web exploitation, but at the end I want to discuss a bit about network protocols and brute forcing on network protocols specifically, and the last video that I want to do has to do with DNS zone transfer attacks. For now, this is the list of topics that I want to cover. Maybe before finishing the series I will actually change them up. And so in this specific episode we can actually talk about enumeration of files and directories. So the first thing we need to do is we need to build this Docker image. So this Docker image is defining a specific Docker and we need to build it because the Docker compose file actually uses this Nginx lab image. And by default, you will not have this because this is custom made. And to create this image, you need to build this Docker file. Now, how do we do that? It's pretty simple. The command is docker build -t. Then we put the name of the image, so Nginx lab, and then we put a dot, and this dot will represent the current folder. This is because in the current folder we have the Docker file, file, which is this one. It's the file that specifies how to build the image. So we can do docker build -t, the name of the image, and then a dot. We wait and then it builds. Now since I've already built it, it takes nothing, no time for me. For you it will take maybe a few minutes. At the end, you should have this Nginx Lab latest image. Now, after you built the image, how do you actually use it? Well, it's really simple. The idea is to use this Docker compose file as follows. You do docker, compose, and then up. You wait and the server is up and running. So it created an instance with this Docker. And if we check this file, we can see that it's gonna map the 1337 port of my host into the 80 port within the Docker. And notice indeed, on the right, I went with the browser into localhost 1337, and here I see the page that I wanted to showcase for this demo. Now, what is enumeration? Why do we have to talk about enumeration, and why enumeration is extremely important in the context of OSCP, but also in many different contexts? Well, the idea is pretty simple. When we have a web server, we are offering resources to the various web clients, and we have come accustomed to that all throughout this course and this series. So the idea is that the client will make an HTTP request, and the server will respond with a certain HTTP response. We can see, for example, a simple request with the curl command. So we say curl-v to print out the HTTP codes, and then we do HTTP, which is the protocol, localhost semicolon 1337, which is the port. When we do this command, notice what we get. So here, initially, we get the get/http/1.1. So this is the request we are making, and this is the response that the server is giving us. And after the HTTP response, within that response, it is also contain the text/HTML answer. So this is what the browser then process and renders to the user. Now, what's the idea? Suppose that we try to ask for a resource which does not exist. For example, the file hello.txt. Let's do it in the browser, hello.txt. Notice what we get. We get an Nginx error code which says 404 not found. Essentially it means, look, the resource you asked is not present within this web server, therefore I cannot give it to you. and the standard error code associated to this event is the 404. So HTTP standardization has standardized the fact that when a resource is not found, you reply with a 404. And we can see the same thing with curl here. It says HTTP, instead of 200 OK, this time is 404 not found. So there is this specific return code which has a both numerical and textual part. The numerical is this 404, the textual is not found. Now, why is this important? Well, the idea is that sometimes in our page, like for example here, right, we have a really simple landing page. If we check the source code of this page, we will see a bunch of HTML, a really simple CSS, and a really simple HTML in general. And then we have different pages. We have the about page, we have the contacts page, and we have the miscellaneous.html page. So we have 3 different pages, and if we check those pages, they are pretty much similar. It's really like simple, it's almost empty, you could say. It just says this is the about page, this is the contacts page, and this is the miscellaneous page. So nothing special. And as a side note, I always suggest you to look at the HTML code, because if someone inserted HTML comments, you would not see them in this rendering of the page. To actually see the comments, you have to go into the view source. However, in this case, there are no comments, so all the information that we could see in the render view, we can also see in the code. There is nothing new added. The question here is rather different. Instead of having something in the code that we do not see, the question we have to ask ourselves is, maybe the person who configured this web server has set a specific directory within their server to host to give out all this content, right? And in this folder there is an index.html page, which is the page where we are seeing, and then there is a pages folder with all the different about.html, contacts.html, misc.html, so with all the different pages. Now the question is, could there be more? Could there be more pages? Like for example a secret page or an API endpoint or whatever else. The idea is that just because those resources are not mentioned in the HTML we get from the server, it does not necessarily mean that they do not exist server side. At this point, we know nothing about server side. We just know what the server returned to us. Is there a reason to believe that there could be more resources? Well, it depends. There could be. We have to test out these kind of things. We have to be like, wait a second, how can I test if more resources are actually offered by the web server? And this is where the idea of enumeration comes in. So we talk about enumeration, which is a term that comes from computer science. To enumerate is to list out all the possibilities. So let's say that you have a logical puzzle, like or also a game of chess. Whatever like structure you have, to enumerate is to list out all the possibility. So you say, okay, this is one valid move, move 1. Then you have another valid move, move 2. Then you have another valid move, move 3, and so on. You make a list of all the possibilities. In the context of web exploitation, and in particular web enumeration that we are doing in these videos, to enumerate means to list out all the resources that the web server offers. And the question now is, of course, how do I do it? So how can I enumerate all the resources that the web server is offering? Well, the idea is that we have to do it in a try and see what happens sort of way. What do I mean by this try and see what happens? Well, the idea is that we tried, for example, to access the resource, let's try hello.txt, and we get a 404. Now, how can we interpret this? We can interpret this in a really basic way. A basic interpretation could be that, look, in the server, there is no file called hello.txt. Now, how much information did we get from this query? Well, we understand now that hello.txt probably does not exist on the server, and then we can try for another, like command.txt. Once again, we get another 404. So we also know that command.txt does not exist on the web server. Now, as you can see, the main idea behind enumeration is to just list out a bunch of potential possibilities like file 1, file 2, file 3, file 4, file 6, etc. and then try all of them one after the other. So we try to access that resource, and depending on the way that the web server replies to us, we check saying, look, this does not exist, this exists, this returns me a 302, so a redirect, this returns me a 500, so an internal server error, and things like that. The idea is that if we find a resource for which the web server returns us with a 200 OK, then it could be the case that that resource actually exists on the web server. Now, this is not always like this, and at the end of this video, I will show an example where this is actually not the case, and in those situations, we have to be a bit more nuanced and sophisticated. However, for a starting point into enumeration, it's a pretty good framework to have in mind. So the idea is that I do one request, like for example, resource res.txt. I send this to the web server, and if the web server replies with me with 404, I say like it doesn't exist. If it replies with me with a 200, I say yes, it does exist. Now, how do you do it? Do you manually try all the possibilities like that? Obviously not. There are automated tools to do this, and in particular, in this video, I will showcase one such tool, which is called gobuster. So this is a binary written in Go. It is a directory enumerator. It enumerates actually much more than directories. It has various modes of functioning. And for example, we can see that it has the dir mode, the DNS mode, the fuzz mode, the S3 mode, so like, and the VHOST mode. In particular, we will see the dir mode in this video and the VHOST mode in the subsequent video. So in the next video, we will see the VHOST mode, which is for enumerating virtual host. So the dir mode instead is for enumerating directories and files, because in the context of web servers, both directories and files, they act as general resources. So you can either access a file or you can access a directory. Now, to actually get the tool, you can use the README here in GitHub. It says installation. You can firstly install Go, and then you can do go install like it's described in this GitHub page, github.com/oj/gobuster. Now, once you install the command, how do we actually use it? Well, before using such commands, the idea is to have a word list. And word lists are really important when it comes to enumeration. Now, what is a word list? It's exactly what it says. It's a list of words. Of course, the concept of word list is used in many different scenarios, in many different contexts within cybersecurity. For example, when we are trying to crack a password, we also use word list. The difference is what those words represent. What are representing these words? In the context of files and directories enumeration, the word list will be a list of words that represent either files or directory that are commonly found in web servers. So here there is all a statistical discussion that you have to understand, and the idea is that the common word list you will use have been made in such a way as to contain the most popular directories and files that you will find in any sort of web server. And these have come from like the community, so it's a really important resource to have. You can also make your own word list throughout your career and activities as penetration tester or bug bounter, but that's a general idea. Now, how do we get our word list? Well, we can use the seclist repository from GitHub, and specifically here I prepare a command. It's this wget. So this wget downloads directly from the raw GitHub section of the seclist GitHub repository of Daniel Missler, and the word list we're trying to download is the directory list 2.3 medium. So this is like a medium-sized directory, so we wait really fast. It's really fast. The directory is roughly 1.9 megabytes, so we can just open it, and as you can see here, it starts with index, images, download, 2006, news, crack, serial, and stuff like that. and the priority order case sensitive, so we have a bunch of different things, and this is under this copyright license. So we thank, of course, the author for making it available. Now, how do we use such thing? Well, the idea is that, okay, let's say that we have our website right here, and we have gobuster, and we have our word list. So let's put our word list into like word list, and then I put directory word list. Perfect. Now it's in word list, is in this directory. Now, how do we use it? The idea is the command is like this, gobuster, so we call the gobuster command, then we put the mode of operation, which in this case is the directory mode, so remember dir. Then we can set the number of threads. Typically, I think by default is like 10. We can put 15, we can put 20 with a -t. So this -t is number of threads. And the idea is that the more threads you have, the more you can parallelize your work. But of course, also be careful, because the more number of threads you have, the more traffic you will generate, and the more you might be blocked by web application firewalls, by general firewalls, and things of the sort. So be careful with your traffic also for the sake of other people. Then we find the -- word list flag, which essentially says, give me the word list you intend to use. And in this case, we simply give the word list we just downloaded, so the one that we put into the word list directory. Then we put the host name that we want to enumerate. So in this case is HTTP, and then we put localhost, and then we put the port 1337. And this is a first command to use. That's it. It's really simple. Notice we have the gobuster, the directory mode, the number of threads. I mean, we don't even need the number of threads, to be honest. We can also remove this. We just specify the word list and the host we want to use the word list on. And then we press enter and we initialize the command. As soon as we make the command start, among the first entries of the word list, notice how fast it's going. It almost seen half of the word list, and in a little bit it's gonna finish, essentially. Well, the idea is that we found two different directories. We found the pages directory, which actually we already know it existed, so there's nothing new there, but we also found the /API directory. Now, the /API directory is different from the pages directory, because while within the web server, we had a direct mention of the pages directory right here. After all, here it says, look, page / so it's a directory about.html. So we knew about pages, but we did not know about API. There's no mention about API. And if you go into API here, we get a forbidden. We do not get a 404 not found. We get a forbidden. It probably means that the directory actually exists on the server. It's just that we are not authorized to access it. So that's different, that's interesting. And so this is our first command. And of course, all these commands I will put linked down in the description. Now, how can we do a different command? Well, the idea is that in the Docker, I said that we are running a PHP application, so we might be interested in enumerating PHP files. So we can do for example, -x for saying the extension of the files we are interested in is PHP, and then we can run again. And once again, it doesn't find anything much other than the pages and the API. But at this point, we might be able to, we might be wondering okay, but what is within the API folder? It could be like a PHP script, right? So we want to enumerate not the root directory of the web server, but the API specifically, the API directory. So we do not call the command with just the domain name, which would implicitly just enumerate the root folder and that's it, but rather we specify, look, the folder I want to look for is /API/. So I want to look inside the API folder in order to extract PHP file. And so I have to do this and also put the -x-php to add the file extension. And if we run this and we wait a little bit, notice what do we get. We get a command.php which has returned a status of 200. Now, as we said, typically when we have a status of 200, we can sort of assume that it means that this resource exists on the web server. And we can quickly check this, of course. So we stop the scan, we go into the web server, and we go into, okay, let's go API command.php, and it says, look, use the CMD parameter. So we did find this resource. and it's telling us to use this particular parameter, so let's just do it. Let's do cmd uguale who am I, and we get code execution. Now, of course, this was just an example to showcase the enumeration and the finding of hidden files and directories. It was not meant to explain how to exploit this remote code execution, because this is a really simple remote code execution that is running within the Docker. So if we do a uname A, we get all the things that typically happen inside a Docker. So this is the host name, which is this hexadecimal string, because it is within the Docker. And so we have discovered this special resource. How did you do that? Because first we discovered the API directory, and then we enumerated within the API directory with a specific file extension. Another file extension that I typically use is the /x_txt file extension, and specifically, if we enumerate the pages folder this time with the txt text extension, what do we get? We get this secret.txt file. Now, of course, in this example, I knew it was there, so this is why I chose the txt extension. However, you can sort of start to understand what are the interesting extensions that you could enumerate for, and just enumerate a little bit. Enumeration is really an art, because there are no clear indications sometimes that you have to enumerate for a specific file extension. However, for example, .txt, .html, .php, .ini, which is config.ini, so stuff like .ini, .sql or db, something.db, those kind of things, you can just come up with those kind of extension, and after a lot of practice, it comes more intuitively. So if you go into the /pages/secrets, we get hi, this is the password you can use for logging into the database instance used for development. Of course, this password does not work. It was a little Easter egg just to showcase that sometimes you might find resources which are extremely useful by doing this sort of enumeration. And so, before going with the second and last laboratory for this video, let's go a quick review of what we discussed so far. So the idea is that we have this Docker environment which presents a really simple web application, and I created this environment with the idea of showing what it means to enumerate files and directories. The idea behind enumeration is we want to check which resources are actually offered by the web server. We do not know all of them, we just know the ones mentioned in the HTML code, but there could be other. For example, in this case, we actually found many resources. And in particular, if you go into the www.html, where is the root of this web server, we find the API directory, and within the API directory, we do find the command.php file. And if you check this file, it is a simple system shell. So it's a simple web shell that uses the parameter cmd if the parameter has been set, otherwise it prints use the cmd parameter. So this is extremely simple. The idea that I wanted to bring and showcase is that we did not know of the existence of this directory and file. And how did we discover that? Through enumeration. First, we enumerate the directories, and then we enumerate the files. And the commands we use, as a quick recap, were this is so to download the word list, we use wget, which is like curl. It is used to download HTTP file. Then this is the first gobuster command. We can remove the -t. So we specify mod dir word list and the host we're interested in. And this is for directory enum, enumeration. The second command instead was, we went into the API folder and we looked specifically for PHP files. So we add the -x PHP parameter, which says look also for PHP files. And the other one was look for txt files, but starting from the pages folder, the pages directory. So this is essentially the idea of these commands, and when we execute them, we get good results. So for example, in this case, I execute this, I have to say, let's see, it's a word list, not with plural, just with one single letter. So word list. So we can replace those three, and we see the command.php, and we also saw the API directory, and so we can get a lot of information like this. Now, as a final example, I want to show another command of gobuster. Now, the idea is that sometimes it is not true anymore that when we go into a resource that does not exist, we get a 404 not found. Because ultimately, these kind of things can be configured to act differently. So if I configure my server in order to avoid having such enumeration, there are ways in which I can sort of like change the return code. So I can say, look, if you find, for example, a resource that does not exist, so you get a request, but that resource does not exist, do not return a 404 error, because otherwise the enumeration tool will recognize it. Just return a 200 with a custom error page that says not found. This would make it much harder to enumerate, right? And I've prepared a demo for it. Now, in particular, this web server actually exposes two different applications, and these two different applications have two different virtual hosts. So, virtual host. Now, what is a virtual host? We'll talk about this in the next video, which is going to be enumeration at the virtual host layer, at the virtual host level. But the idea is that here, the domain name is different, because instead of being localhost, it's prod.localhost. So it's a different application that has been configured by Nginx to act differently. Now, in this application, for example, let's say that I say ASD or something. It says not found, right? However, if we actually check the HTTP response that we get, so we do a curl prod.localhost1337, and then we do asd. Notice what we get, right? I do the -v to get the HTTP code. Well, notice that we actually get a 200 OK, but then the content says not found. So here I've configured this Nginx instance to not follow strictly the HTTP specification in order to confuse such enumeration tools. Because now, if I launch gobuster, I'm not able to easily recognize when a resource exists or when it does not, based on the return code. So let's try to run gobuster as we learned in the previous example. So how would we do it? Well, it's pretty simple, right? So we have gobuster dir, then we put the word list, and I say word list directory common, and then we put the -u with the host, with the host name, so prod.localhost1337. If we launch this command, notice what we get. We get an error. Gobuster understands that this situation is an error. It says, look, the server returns a status code that matches the provided option for non-existing URLs. So like this one, it says 200. So this one should not really exist, but it still says 200. To continue, please exclude the status code or the length. So the idea is that we cannot just rely on the status code anymore, because there are a lot of false positives. And with false positive, I mean the tool would say this resource exists, but in reality it does not. And it does not exist because in the Nginx configuration, you don't need to understand this, but the idea is that in this simple Nginx configuration, I mapped the 404 error page to return a 200 and to go to the custom 404.html, which simply returns this HTML string. So I have a custom handling of the 404 error page, and I also change the return code, right? Because I say, look, return a 200, not 400. So this is done so as to make life difficult for like tools like gobuster. So how do we deal with this case? And this is exactly why I wanted to bring this case, because it tells you that the tool by default has certain default choices. So for the tool by default, 200 means the resource is there, 404 the resource is not there. If we want to change this, we have to use a different flag. So we have to use like exclude length 37. Now why do we exclude this specific length? Because the idea is that every page will return a content that has 37 characters. So let's try to do some example with curl. So we do curl http prod.localhost 1337 test, and then we say v, look the content length 37. I try a different resource 37. I try a different resource 37, because it's always the same static string which has 37 characters. So here are 36, and then there's a new line, so that's 37 characters in the body of the HTTP response. So that's the idea. So how do we do that? As I said, we do gobuster dir, then we do word list directory, then we do -u, and then we do prod.localhost, we put the port 1337, then we put, let's say, for example, enumerate txt files, but you have to exclude all the results that have 37 in the content length, and we execute the command. Notice what we got immediately. We got a db.txt file, and it says, look, the size is not 37, the size is 41. It means that when we asked for this resource, we did not get the 37 number of characters. Now, does this mean necessarily that this resource exists? No, of course, we cannot have guarantees at this level, but at this point, we can just go into the application, we can just search for it, and boom, we get our flag. 200 not found. So this is a really like a simple challenge that I showed how to solve to showcase that error codes not always tell the truth. It depends on the configuration of your application. Now, most of the time it happens that the configuration used is the default one where 200 are mapped with actually existing resources and 400 are mapped with not existing resources, but that is a configuration that can be changed. In this case, I had this static length for the error page of 37, so we could use that to avoid this configuration, to bypass this mechanism. Maybe in other pages, the error page is custom made and it changes every time. So that's gonna be even harder. I will have to put filter maybe on the output. If the output starts with not found, then I will search for that. So you should get the idea at this point. Enumeration is all about understanding how the web application responds to our queries and understanding what kind of information we can infer from that. The idea is to understand what kind of resources are present within the folder of the web server that are not obvious to know, like for example in the HTML in localhost 1337. And this is the idea of enumeration. It is not a science because there are no certainties for this. You have to develop your own taste, your own intuition with this kind of activity. However, it is extremely important. So to this end, go check out the most important word lists, which are the sec list in GitHub. You can just search GitHub sec list and it should be there. Go download an enumeration tool. In this video I showcase gobuster, but of course there are many other tools, each of which works with a different UI, with a different interface. The idea is that a good enumeration tool should allow you to filter, to make custom filter based on the data present in the HTTP response. So it could be the content length, it could be a specific header, it could be the body itself, maybe matching strings on the body. You have to filter based on the specific logic that is implemented and configured in the web application you're trying to enumerate. So this is it for this video. I hope it was interesting. I hope it showcased what it means to enumerate a web application. And in the next video, we will continue our enumeration with the enumeration of virtual hosts. Hi everyone and welcome to this new video in which I will continue my web exploitation series. In the previous video I discussed how to enumerate files and directories, so it was the first video of the enumeration portion of the course. In this video instead we will learn how to enumerate virtual hosts. So I will explain what are exactly virtual hosts and how we can enumerate them and why enumeration of virtual hosts is an important process of web exploitation. So to play with virtual host enumeration, I developed a Docker environment similar to the one developed for the previous video where I showed how to enumerate files and directories. So for this time we also have a Docker environment, but the Nginx server has been configured differently to allow for virtual host enumeration. So to run the environment, you just have to do a Docker Compose app once you have this file. Of course, before you have to build the image. So this is the image in the Docker file. This is the instruction of the image. And then we're gonna build it with docker build -t. You put the name of the image and then you put a dot. And this is gonna take the Docker file in the current directory, which is the Docker directory in my case. So right now everything is in the Docker directory. You do the build with the dot so that it takes the Docker file from that directory. Of course, in this case, it immediately built the image because I already built it. In your case, it will take some time, but after the image has been built, you can just use the Docker Compose. You can do Docker Compose app, and it will automatically take this Docker Compose YAML, this .yml file, and then you can do Docker Compose app, and it runs the lab. Now, to actually access the machine, you have to do a final thing, and essentially you have to add in the etc host file, you have to add a line that binds the 127.0.0.1 IP address with the local name. So this is important, you have to do this. So the idea is that by modifying this etc/host with this line, so you add this line to this file, you are associating the IP address 127.0.0.1, which is the IP address for localhost, to this specific name, which is not localhost, as we show in the previous episode, but this time is just called local. And you can imagine, for example, if you are doing a box for OSCP or a box for ActedBox, you will be given an IP address and the name of the box. So you can do like machine name, machine.htb, or like for OSCP, like machine.oscp, something like that. So you will be given such domain, and you have to put such domain into the etc host to have the association between IP name and domain name. So you have to do this. Once you do that, so once you are able to ping it, you can just do a ping local to check that it works, and in this case it works. And so essentially you have to go with the browser to this specific host. So this is the host, HTTP with local, and the port is 1337. So you put this in your browser and you're good to go. You see the website and you are able to do this laboratory. So once we go into this local port 1337, we are welcome with this web application. It's a simple HTML page. It's a static page that says welcome. This is a simple landing page. You shall find nothing useful here. And notice that I was able to reach this site because this local is registered in my etc host, in my local etc host, which allows the web browser to resolve this domain name. Local is a domain name, and it resolves to the IP address 127.0.0.1 port, and then I put the port, and the port is 1337. So once I put all this data, I'm able to access the service, which in this case is a very simple web application. Now, what's the idea behind virtual host enumeration? Because in this case, we have this application, and if we check the source code, we find nothing of interest. Now at this point, you could start to enumerate files and directory with gobuster, as I showed in the previous example. However, in this example, you will find nothing useful like that, because I've made sure that you could not find anything useful by just enumerating files and directories. And indeed, if you actually go to the source of this web server, you go to www.html, here there's nothing, there's just a static index.html page, which is the one that we are seeing here rendered by the browser. So nothing useful can come from enumerating files and directories. At this point, the question is, what is there to enumerate other than files and directories? And here we come with the concept of virtual host. Now, virtual host is a mechanism that was introduced in HTTP, if I remember well, in HTTP 1.1. So it is the version HTTP/1.1. And the main idea behind virtual host is the following one. Suppose that you have a web server. So for example, you want to host your application and they give you a machine. They give you a server on the internet, and this server has a certain IP address. So you have an IP. And this IP is accessible from the various clients. So here you have the various clients. All of them are connected to the internet, and your server is also connected to the internet with a specific IP address. And maybe you have a port 80 or like let's say port 1337. So you have port 1337 TCP. So TCP port 1337, you have a web server listening for incoming connection. So each client that wants to access your web application, what does it do? It goes to this IP address at this port with this protocol, with the TCP protocol, and it gets access to your web application. And this is good. However, they realize at some point, the people who engineer this sort of stuff, they realize that this means that just with this, to have a single web application, I need to allocate an IP address and a TCP port. So I need both resources for just one web application. And this can be very limiting. It can be very limiting if you want, for example, to host 2 different web applications, not just one. What would you have to do to host 2 different web applications? Well, maybe you can keep the IP the same, but you have to choose a different port. Maybe you do 1338 as a different port, so not 1337, because that's already allocated for one web application. You have to use a different port, and this means also spawning a different process that takes care of this different web application. At some point, people realize that there should be an easier way to offer multiple web applications with the same IP port. So the idea is that I want to keep the same IP and the same port. However, I want to offer multiple web applications. How can I do that? And this is where the idea of virtual host comes in. Notice the word, it's called host, but it's not just a simple host. It's called a virtual host. So we are trying to virtualize the concept of hosting. To host means to just give some service, just to put a web application that is able to handle some request. So to virtualize this, what does it mean? It means from the same machine with the same IP port connection, I should be able to offer multiple web applications, not just one. I should be able to offer Web 1, Web 2, Web 3, maybe even thousands of web applications, depending of course on the characteristic of the server. And the idea is that a single process, by also using multi-threaded techniques, but the idea is that a single process can receive a request here and then can redirect the request to the appropriate web application. Now, how do you do this redirection? And this is where the concept of the host header comes in. So let's open Burp and let's analyze some requests that are made with Burp. So as usual, I have here on the left Burp and on the right my browser that proxies every request to Burp. Here I'm gonna intercept on, so I'm intercepting all the traffic. Here I get something about Google, we don't care about that. And now I'm gonna make a request to my website. Now notice the various headers of this request. We get the typical get, the verb, then the resource, the slash, which means the root page. Then we have the HTTP version, which is 1.1, and then we find this host header. And notice that the host header says leonardodamiano.xyz. And then we have a bunch of other headers. Now the key idea of for understanding virtual host enumeration is the role played by this host header, and we will discuss why shortly. So let's just forward this to the browser. We forward other request, and then we get this main page. Now let's try to intercept the request that it's made when I go to the blog. So notice here, the host is no longer just leonardodamiano.xyz, but rather it's blog.leonardodamiano.xyz. So the idea here is that I'm using a different virtual host, because the value that we put into this host header is exactly the virtual host that we want to use. Now, when I make requests to this virtual host, I go into entire different applications. So here, for example, is where I have my technical blog. However, I have other virtual hosts. For example, I have the teaching virtual host, where I uploaded some old teaching material, where I did some lecture at university. So notice here, the request that it's made to the web server is no longer blog.leonardodamiano.xyz, but rather it is teaching.leonardodamiano.xyz. So what's the idea here? Well, the idea here is that if we simply do a request like this, so let's try to do follow redirection. Okay, if you just do a request like this, we only see one specific web application. However, there might be other web application that we just do not see. Why? Because we do not have the right virtual host set up. When we set the right virtual host in the host header, we might get access to new virtual host. So for example, here if I put blog.leonardodamiano.xyz, I get a different web application, I get the blog. While if I put teaching, I get the teaching virtual host with a different web application, with the teaching material. So essentially, this is the basic idea behind virtual host. Virtual host is a mechanism that is introduced at the HTTP layer that allows me to have multiple web applications hosted under the same couple IP port. So my web server running on my VPS is listening on the 443 port with the same IP. However, by changing the virtual host parameter, which is found in the host header, I'm able to access different web applications. And all of this is configured, for example, in my case, with Nginx, but you can also have Apache, Tomcat, and all different web servers. Essentially, they support the idea of virtual host, they support the concept of virtual host, and each of them a little bit different, but all of them allow you to specify different virtual hosts and allow you to configure how that particular virtual host behaves. But this is the general idea. Now, if we go back to our application, so this one essentially, the problem is, okay, in this application there seems to be nothing here. And here we have the Docker running. In this application there seems to be nothing. However, there might be information put in other virtual hosts. So to make sure that there really isn't anything useful, we have to do virtual host enumeration. So here, once again, the idea of enumeration comes in. Remember that to enumerate means to list out all the valid possibilities, to list out all the particular hostname that works. In the case of files and directories enumeration, the idea was to discover all the specific files and directories that were exposed by the web server. In this case, it's the same exact idea, but instead of focusing with the files and directories, we are focusing with the virtual host. So the idea behind virtual host enumeration is to discover exactly what are all the virtual hosts that are exposed by the web application. And as always, what is the problem here? The problem here is that unless I know prior to the testing what is the virtual host, I have no clue what could possibly be the virtual host exposed by the application. So to approximate this research, in a way, to approximate this search, the idea is to use word list. So now the problem is, okay, how do I test for virtual host? And as we saw, it was pretty simple actually. I just start from the basic domain that I want to test for the presence of virtual host. So for example, in this case, it could be leonardodamiano.xyz. I start from this, and then here I put the virtual host I want to test. So for example, teaching gives me a new virtual host, but then I could have like something else, and in this case the something else gave me a different virtual host, and so on and so forth. So this essentially is the idea. How do I do that? I just need to put my the virtual host I want to test for within this portion of the host. I need to send a request, and depending on the page that I get, on the specific content, I'm able to understand, okay, I actually found a new application, or sometimes it happens that no new application are found, and so we get the same old application, which means that no new virtual hosts have been found. Now, of course, to help in this search, we can use word list, and they are extremely useful, and I've discussed about word lists also in the previous video, but this time we're gonna use word list specific for virtual host enumeration. And we can go into the GitHub of SecList. These are extremely popular word lists. We can go into discovery, into DNS, and here we have this subdomains top 1 million, subdomain top 1 million, this tree, which contains I think this is like 5,000, 20,000, and 110,000, something like that. So there are a lot of domains. So for example, this is the 5,000 one. So we have www, mail, FTP, localhost, webmail. So these are all the various domains that, for example, have to be added to the domain we're testing. So if our base domain is local, then we're gonna do www.local, and then after that mail.local, and then after that localhost.local, and so on and so forth. So this is the basic idea. Now, of course, there are tools that help us automate this, and the tool we will use in this video is gonna be gobuster. I've already discussed gobuster in the previous video, so I will not talk too much about it, but the idea is that this time we're gonna use gobuster in the virtual host mode, so VHOST mode. Now, how do I get this word list? We can just go into row here. We can go into row, we can get the URL, and then we can either do wget or curl. So in this case I did wget, and I have the subdomains. I can put the subdomains into the word list directory, and then here in the word list I have this word list saved. Now to use gobuster, what do? We do gobuster vhost for the virtual host mode. Then I have to use www word list -- word list, and I put word list and then directory. Then I do -u for the URL, and I put http :/local 1337. And then, most importantly, I have to put an extra here option at the start. I have to say append domain. Now, in old version of gobuster, this was not needed, but what is the idea? This option changes the way that this word list is processed. Why? Because the idea is this. We start from this URL, and then for each domain that we find in this list, without the append domain, we would just put in the host header just the value contained into this word list. So if we have like dom1, dom2, dom3, etc. in this word list, without this flag, each HTTP request that would be made with host dom1, then host dom2, then host dom3. So you have to specify the entire domain within the word list. If instead we use this flag, the idea is that in the host field, it's gonna take the word from the word list, like dom1, but then it's gonna put a dot, and it's gonna append the domain we use in the URL. So dom1.local, then dom2.local. So the idea is that the word list is not the entire full specified domain, but rather is just the final part of the domain, the leftmost part of the domain. So I want to append this because in this word list, it's not specific to this specific machine. It's just the top level. It's just the most specific part of the domain, not the top level, but the most specific part of the domain. So if we just run this, what do we get? Notice what we get. I just said run, and we get found test.localhost, found dev.localhost, found prod.localhost. So it already found 3 different virtual hosts. Now, how do we check if this is correct? Well, we just go here essentially, and what do? We just copy this one, but here at the start, I'm gonna do test.local. Now, as you can see, when we try to go into the test.local 1237, we got this error. So what's the problem here? The gobuster tool says that it found a domain, but the browser is not able to access the page. The issue here has to do with 2 different protocols, which is the HTTP protocol and the DNS protocol. Now, the problem that the browser is encountering has nothing to do with HTTP and virtualhost, but rather it has to do with the domain name system, with the DNS system. Now, why do we use DNS? Well, the idea of DNS is to start from a domain name such as test.local and to resolve this domain name into an IP address. So for example, in this case, the IP address should be 127.0.0.1. Now the problem is that we know this is the case for this example, but the browser does not know. Because when the browser tries to resolve this name is not written anywhere. It is not written on the internet, it is not written in our local machine, so it's simply not able to resolve this particular host. How do we fix this? Well, remember that initially we put into the etc host, we put the line which says, look, local is associated to 127.0.0.1. So we have to edit this file and we have to add that, look, not only local, but also test.local is associated to this IP address. Okay, now I edited the file and essentially in the same line as before, I also added test.local, dev.local and prod.local. Now, if we refresh the page, what is happening is that the browser is checking the etc host for the DNS resolution. The DNS host says, look, this is the IP address, so the browser knows the IP and port to connect to where there is a web server. At that point, the web server receives an HTTP request where the host header has the value test.local. And now Nginx comes in and it says, okay, I have this specific virtual host, I'm gonna give you this specific page, testing environment, which is different from the initial page, from this welcome page. This is a specific page that is only available from this virtual host, from the testing virtual host. And if you go into dev, so if you go into, for example, dev.local, we see development environment. And if you go into the prod.local, we see production environment. So essentially we have three different environments, each of which has a different virtual host, but all of them are within the same web server. So the web server can route the traffic through this different web application using the host header, using this virtual host mechanism. And this is why it's called virtual host, because it is virtualizing the idea of hosting. I don't have a single web application now listening on a given IP and port. I can have many different web applications on the same IP and port, and sort of to multiplex this channel to allow for multiple applications to exist on the same IP and port, I need an extra information so that when an HTTP message is received by the same IP port combination, within this HTTP we have the host header value, so this value which is used to route the message into the proper web application. And this is responsibility of the web server. Now, of course, the idea here are these all the virtual hosts that there are? And the thing is that it's actually not the case. Why? Well, let's open Burp for a moment, right? So we open Burp, and here we can go into the Chromium that we use for, not this one that we use with the proxy. And then, actually, let's go into Chromium. We copy this here, and we just intercept this, right? So we're gonna intercept this, So we have this prod, and then I put to repeater, perfect. So we have this. Now, we just play with Burp. Here I put, for example, test, and I get testing environment. I put dev, and I get development environment. And actually, there is a pre-prod environment, which has this particular virtual host. So it's pre-prod. And it is the pre-production environment. Now, of course, since this value was not present in the word list that we used, we did not find it. gobuster did not give us this virtual host. And here the idea is to learn that depending on the quality of your word list, and of course on the specific application that you're trying to attack, on the specific web server that you're trying to attack, you can have more or less results. So it is never 100% science that you can always guarantee you will find the right virtual host. It is a bit of an art. You have to have a good word list, you have to have a lot of tries, a lot of processing power to discover these kind of things. It's not the most beautiful thing, but it is necessary to know how it works. And so we arrive at the conclusion of this video. In this video, I wanted to talk about virtual host enumeration, and the basic idea is that the value that we put into this host header is extremely important. Notice what happens if we remove it. If we remove it, the Nginx server says bad request. I need to know the virtual host, otherwise I'm not able to route the information to the right application. I can remove almost everything else, I believe. Yes, I can remove everything else, but I need the verb, the resource, the HTTP protocol, and the host header. I do need the host header since the introduction of virtual host, which happened with HTTP 1.1. Now, to finish off the video, one might ask, okay, but what is the difference between virtual host and DNS? Because they both seem to be like domain names, right? So this is a virtual host, but it can also be a domain name, a name in the DNS system. Well, the difference is that even though they might seem the same sort of data because they look the same, so this test.local can play two roles. It can be a virtual host, vhost, or it can be a domain name in the DNS system. So the difference is exactly this. What is this data used for? Because in the domain name system, this is used to associate this name to an IP address. So if you are using this name to have a mapping between a symbolic name and an IP address, then this is a domain name. It's a name in the domain name system. Otherwise, if we are using this value to understand to which application we have to route the HTTP request, then we are not any longer doing the mapping between symbolic name and IP address, but rather we are doing the mapping between HTTP request and web application, and this is done through the virtual host system. So we have a host header and we want to assign to that host header a specific web application. So even though these things might look the same, they are used in different contexts, and you need to understand if you want to enumerate DNS names or virtual host. To enumerate virtual host, you need to send different requests and you need to change the host field in all those requests. By changing the host field, you might get access to new application. So for example, this is production environment. I change this host field and I get access to the development environment. I change it again and I get access to the testing environment. I keep it the same. I put something that does not exist and I'm back to the welcome page. And indeed, as a last thing, what is going on with gobuster after all? If we route the traffic of gobuster through our proxy with a proxy flag, so we have to do HTTP with a proxy flag. If you do this, notice here we're going to get a lot of requests. We're going to get a lot of requests, and here he's going to say, look, I found a lot of virtual hosts. But this is actually not the case. It's just because gobuster is being full by the BurpSuite endpoint. But the idea is that look the request that you are making. So for example, in this case, you are making a request to local, so it's just local. Then here we're making a request to this hexadecimal.local, here to localhost.local, here to ftp.local, here to cpanel.local, here to mail.local. So it just keeps on going. At some point, we make the request to dev.local, and this point we get something back, and so on and so forth. At some point we make the other request. So he did not do it in time here, but essentially at some point we will make the request to prod.local, to dev.local, to test.local, and so on and so forth. And so to finish off the video completely, this is the command you need to remember. It's gobuster in virtual host enumeration mode. You want to append the domain. Then you want to pick a good word list. For example, this is okay. It doesn't have too many entries. You can also use the ones with a lot more entries. And then you put the URL. So remember that the URL, you have to put exactly the entire URL with the top level domain. So in my case, it was simply local. If you're doing a machine out the box, it's going to be machine.htb. If you're doing a machine OSCP, I think it's going to be like machine.oscp maybe. Something like that. I do not remember the top level domain of machines in OSCP, but that's the general idea. You put the entire domain here and it will add the domains present in the word list like this. So in the first section, it's going to add the domain, and then it's going to put exactly what you put in the URL. And with this, you should be able to enumerate the virtual host. I hope the video was interesting. If it was so, please leave some feedback in the comments, and to the next video. Hi everyone, and welcome to this new video in which I continue my web exploitation series. In this video in particular, we will talk about the enumeration of HTTP parameters. So this means a couple of things. The idea is, let's say that you have an HTTP GET. So this is an HTTP GET request. So this get request can be something like index.php maybe. Now the idea is get request can have parameters in the URL here. I can have like, for example, parameter param1 equal value 1. Now the idea is how do we discover if a given HTTP get endpoint has a certain number of parameters? And let's say that we know that there is a specific parameter. How do we know the different values that go into this parameter? How can we understand how the web application behaves if we give certain values or maybe other values and stuff like that? This is for the get. There's also the HTTP post, so we have the post data. Maybe we have a JSON body or we have just the form URL encoded data within the post. So in all those scenarios, we need a way to enumerate the possible parameters, to enumerate the values that go into those parameters, and so on and so forth. And so this is the idea for this video. I hope it is interesting. If it is, leave some feedback in the comments. Leave also some feedback if you didn't like something that I said. This is the 11th video for the series. After this, we will need 2 more, brute forcing and DNS zone transfer, and then we will be completed with the web exploitation series for OSCP. This is really cool. And now we can just start with the content of this video. So we go into the directory, and here there is the content. Here there is the Docker file. So as always, I have a Docker file. This Docker file defines the web application. Here I have essentially just a single PHP script in www.html.orders.php. We will not read the source code for that. We will analyze the application in a black box way, in a dynamic way. This is what happens when you do a black box penetration test. You don't know the source code. You can just interact with the application through HTTP messages. And by doing that, we will discover a bunch of things. So this is the idea. Now, how do we build this? The command is docker build. Then we can give it a name. The name is going to be enum parameters lab. And then we give a dot because the Docker file is in the current directory. So this is how you build it. I already built it, so it's gonna be pretty fast. If you didn't build it, you're just gonna have to download like the images from PHP and so on and so forth. After you build it, we can use the Docker Compose. So the Docker Compose is pretty simple. We just defined this enum parameters lab with the image that we just built. We give it the container name, and we say, look, I want you to bind the 1337 port of my host into the 80 port of the Docker. So internally the Docker is going to run a web server at port 80, but I will be able to access that web server through this endpoint, which is the localhost IP with the 1337 port, the elite port, my favorite port. So we can do Docker Compose up, and it's gonna make our Docker up and running. And so now here the application is up and running with the Docker. And in this other tab, I've prepared the BurpSuite Community Edition and the Chromium instance that proxies to the Burp. So this is a setup that I've already showcased multiple times throughout the series. So now we can go into this. Notice we get a forbidden. Why? Because there's only one resource here, and it is /orders.php. So once we go into the page, what do we see? We can check the HTML code. There's really nothing here. It just prints out need a user ID. I don't even close the body and the HTML tag, so this is not really like proper code, but hey, it says, look, I just need a user ID. Another thing that we can always do and that we should always do is check out the headers. So these are the headers that are sent by my browser, by the Chromium instance, and these are the headers that the web server replied me with. So this is the response headers. And notice it says, look, I'm powered by this version of PHP. Now, typically, this is considered an information disclosure because you don't want to tell your attacker the exact version of your software. But in this case, since it's a home lab, we are not exposing it to the internet, it's fine to leave out the version. Just remember that in case you want to expose a service, you might want to hide such information to external users because the user of your application does not need to know these technical details. These are details that are good for maintaining the site, but they should only be viewed internally in like a different point of view. So this is the idea. Now, here it says need a user ID. So we can assume that the user ID is passed through a parameter. Here we have a get request. So maybe the idea is, oh look, we just need to add something like a parameter here, like I don't know, for example, test equal asked. We can sort of like do this. And we have a query like this. We can send it to the repeater, and we can put different like parameters like test asked 1, 2, and so on and so forth. So this is the idea. Now, when we have like this kind of situation, doing it manually is just impossible, right? Because you don't know what is the exact name for the parameter that is used by the server. Maybe you can make a guess, right? It's sort of like ID. Maybe because it's a user ID, right? Is it written like a D? Is it written like ID caps with caps lock? We don't know. So what's the idea? As usual, when we have an enumeration scenario, we want to go through a bunch of possibility in order to discover if in all those possibilities there are some which are useful to us. So in this case, we should make a list of possible parameter names and then just do a lot of requests where we just change the parameter name to check if the server replies differently. Because the main idea here behind parameter enumeration is that if we find the correct parameter, then we can expect that the web server will behave differently, that the web application and therefore the response sent by the web server will respond to us differently, with maybe a page with a different content length, with different content, with a different tag here. We don't know exactly, but the idea is if we find the correct parameter, we expect a change in behavior, while this behavior is the default behavior that it has when we have an incorrect parameter. Because for example, here we can add another parameter and nothing is gonna change. I'm still gonna get this content length and I'm still gonna get the same exact page. So not much here. So how do we do this? Well, the idea is to use a tool, and the tool I will be using is called Wfuzz, Wfuzz. Now this tool is really useful because essentially it allows you to fuzz for these sorts of parameters. It allows you to discover these sorts of things. And so this is the idea. Now, this is the Docker Compose Lab. We can just leave it up. It's really no big deal. Now down, how do we use Wfuzz? Well, the first thing is that we need a word list, right? So we need a list containing all the different parameters that we want to test. Now, as I said in the previous enumeration videos on files and directory and virtual host, the management of word list is not a trivial task. I mean, you really need to build your word list based on real data, based on what developers typically use, based maybe on leak that have happened in the real world maybe years ago and stuff like that. So in this case, like a default good word list is the ones that are exposed by the seclist GitHub. And in particular, for this case, I'm gonna use this one. I'm gonna use this one, which is it is in the seclist. It is in the seclist repository, and it is in discovery, web content, and it's called burp parameter names. So in this list, we see a bunch of parameters, of like names that can go into parameters. There are a lot of them, of course. For example, CSRF token, cursor, CASD, customer ID, cat, CV module, CV number. So like there are a lot of things like that. So how do we get this? It's really simple. So I go here. I have already downloaded it, but let's say I didn't have it, so I'm gonna remove it. There's not here anymore. We can just use the following wget commands. And all the commands I will use today will be available in my GitHub. There will be a txt file containing all these commands. So if you want to repeat this sort of lab in your own environment, you can do that with no problems. You just need wget, and here is the URL where I download the list. So I just press OK, and here I have my list. So I can open it. I can find a lot of, for example, if we search for ID, we see a lot of different IDs: gift, aid, id, id, item id, network user ID, PHP SSID, parent ID, payer ID. Like we have a lot of occurrences of that. Now, I don't know exactly how many of these things there are. I think we can search. I think we can find the lines. Okay, yeah, we can find the lines like this. And it says there are 60,000 lines. 6,000 lines, not 60. 6,000 lines, 6,453. Let's see. Yes, this is also said by my Emacs here in the down. So there are around 6,000 parameters, almost 6,000 and a half. So there are a lot of parameters, right? So how do we actually use Wfuzz? Well, the idea is that we can either download it with Python with pip install Wfuzz. However, I had some problems with some libraries, with some Python modules, and this sadly happens, especially with Pythons, when maybe one of your dependency uses a package that has been deprecated, so it doesn't really work correctly. Thankfully, however, the author of the Wfuzz package, they also give out a Docker image. So the idea is that we're going to use Docker to run a container. In that container, we will have Wfuzz. So that's the idea. How do we do this? The new command essentially is this one. So let's try to analyze it, but first let's remove a bunch of stuff. So it is another Docker run command, right? Because it's Docker run. Then I do this, I do network equal host. Now, why do I need this flag? I need this flag because my laboratory currently resides on the localhost interface. So the Wfuzz within the container, if this is like the container of Wfuzz, this is the container where I have my vulnerable web application, and this is my host. So the idea is that this thing has to communicate with this thing. So they have to communicate, because otherwise I cannot test that application with a Wfuzz instance running in a container. So the way to do it, the easiest way to do it is, instead of making like a Docker network, that you can also do that, but the easiest way that I found is just to say, look, network host, which means act as if this Wfuzz is running on my localhost network. So it has access to all my localhost, my network interfaces, like the network interfaces of my host. And so that's the idea. So with this, I can just say, look, go to 127.0.0.1, and then you will find this application, because this is the same interface that my host uses to communicate with that. Then we do this, so we mount a directory. So to mount this directory, we get the current path. This pwd says, print me the current working directory, and sort of like expand it. So in the final bash command, this is gonna be the entire directory from the slash, from the root directory to this directory. Then you go into word list, and then you attach this to the internal directory of the container called /word list. And so the idea is that by doing this, I'm able to put the word list that I want within the container so that I can access it, because this is like a resource that I need to access. Then we say essentially where to take the image. So this is IT is where to take it. Then with IT, we make it interactive so that it gives us like a sort of interactive shell. Here we say we specify the image name. So this is like the full image that is present in the Docker repository online, so that we can download it if we don't have it. And then we specify the command we want to execute on this Docker container. For example, we just say Wfuzz. If we do this, what's gonna happen is that it's gonna activate the container, it's gonna execute the Wfuzz command, and then it's gonna stop. So this is the result of the Wfuzz command executed. Now, how do we actually use it, right? We can say, for example, --help to get the common help with all the options and stuff. So a first usage would be like this. So we can sort of like do it like this. So let's say we have Wfuzz. The first thing is we specify the word list. So we do -w, and the -w is to go from the /word list root directory, because remember, this path is gonna be taken from within the container. So we cannot just say .dash, because .dash would start from our current, but it's actually /word list. Then we put the burp. So let's say, how was the burp word list called? Like this. So I'm gonna be /this like this, and then I start with a slash here. Perfect. Then I continue. How do I continue? Well, I put the URL where the application resides. So in this case, it's HTTP 127.0.0.1.1337. It's the port. Then I say orders.php, because this is actually the resource. And then this is the interesting part, right? So I want to fuzz for parameter names. So I do this. I do this question mark, then I do fuzz equal fuzz, and I put everything in quotes here. And this is it for our first wfuzz command. So let's just review it within this buffer, which is better. I'm gonna zoom in. So we say docker run, we set the network to dealing with the network. Then we specify, we mount this word list. Then we say that it is interactive. Then we specify the image, and then this is the actual wfuzz command. So if you were to install wfuzz locally on your machine, you would just have to execute this single command. You wouldn't have to do all this docker run stuff. I do this docker run because it is easier to build with dependencies and stuff. It is just like it's much more easy to manage. So I do this wfuzz, then I put the word list, then I put the URL, and here I say, look, you're gonna read every parameter from this word list, and you're gonna replace it here whenever I write fuzz. So this fuzz keyword in capital letters means change me with all the different parameters that you take from the word list. Which means that for every element in this word list, we're gonna get a different query where these two values are different depending on the value that we picked from the word list. And we're gonna iterate through all the 66,000 possibilities. So if we run this command, what do we get? Let's run this command. We get a bunch of different results. So we get a bunch of different results. Now I stopped it with Ctrl C. And what do we get for each of these results? So the idea is that for each of these results, we have the response code, the number of lines, the number of words, and the number of characters within that response. Notice that for every payload, and here the payload we use to trigger this behavior of the web application. So the idea is that when using wfuzz, we sort of like filter the behavior of the application depending on the status code, the number of lines, words, and charts of the content of the response. And this is the idea. This is already pretty powerful. We don't even need to go into the details on the content itself. This view is already pretty powerful, and we will see why. So here we have the payload. Now notice that for all those payloads, we get the same 526 character response. So we sort of like get the same behavior. Now, why is that? Well, remember that 526 is the default answer we get when we put a wrong parameter here. So the idea is that, look, these parameters are all wrong. Actually, we don't even want them to show in our output because we want to hide them because they are sort of like not working parameters. We did not really discover anything. Well, the idea is that we have control over what we can filter or not filter, because wfuzz, of course, does not know the specific logic of the application we are analyzing, and so it gives us various parameters to hide this sort of stuff. If we go back and we say -help, at the end here, notice this, we have hide the responses with specified code, lines, words, and charts. So we have these 4 different parameters, HC, HL, HW, HH. So these sort of like hide code, hide lines, hide words, hide charts. So that's the idea. Now, what do we want to do? We want, for example, I mean, it doesn't really matter, but we can just use this. So we want to do, after the word list, before the URL, we put hide charts. And so this is like a double, hide charts, and here we put the number that we want to hide, which is, if I remember well, 526, yes. So we go with this again. Notice what we get now. Now, all the previous lines are not shown anymore. They are filtered because they just reply with the default thing. But notice this, however. We have one line now that says, look, this line does not have 526 characters in the response, but rather it has 563. And the payload we use is actually user ID. So it's user written in a lowercase, then ID in capital, and then D in lowercase. This means that with this command, we are able to discover that the correct name for the user ID is actually user lowercase, then ID equals something, for example, test. And notice, now, the behavior of the application changes. Now it says order list of test, but then it says incorrect user ID. So it's sort of like we understood the name of the parameter, but we still don't know the proper value that it has to go there. But that's still a step forward, right? Before we didn't even know it was called user ID. And maybe in a different application it's called ID. In a different it's called user ID all in capital letters. So we don't know exactly, and the order does matter. And notice here that the capital of the fact that I is of a capital letter, it does matter because with this, we get this incorrect user ID. If we just put it into a lowercase, we get the need a user ID. So it's sort of like, I mean, in this case, you can argue like, look, it says literally on the response that it's called like user ID with this specific syntax. So you could have just used that. That's right. But of course, I wanted to show a more general approach, a methodology to discover these things, because you don't want to just find quick solution for your single web application. Rather, you want to build methodologies that work across different web applications. Methodologies and strategies that you can then adapt to your own workflows, to the specific application you're testing, or the bug bounty program you're doing. So now we discover one parameter. We can try to do this. So let's try now to discover if there are more than one single parameter. Because sometimes it happens that the application actually expects more than one parameter, right? So what can we do? We can put, like here we know now that there is a user ID, right? And we can put here test, whatever. Then we say end, and we put another parameter. At this time, we find this like this, same as before. But now we have hard-coded the user ID. So now the user ID is not gonna be replaced, and we will see if there are more parameters. So if we run this, notice that now we still get a lot of answers because we have to adjust our filter code. So it is no longer 526, it has to be 561 now. If we do this, do we get something? Let's just wait. I mean, I know, I wrote the code for this application, so I know. Notice this, we get two results. So we get user ID, and then we get debug. So this is really interesting, actually. So we get a debug parameter that only appears, however, when we have selected the correct user ID. Because if we don't have the correct user ID, then we cannot access this debug. However, if we do have chosen the correct user ID, then we can add a different parameter called debug. So let's do that in our web application, right? So we say end debug equals debug. And the application replies us with nothing. Let's say, for example, debug equals a single hyphens. Once again, the application replies us with nothing. It's just an OK with nothing. If we say, for example, who am I? The application replies us with www data. So what does this mean? It means that we simply have a remote code execution. Why? Because in the code, this debug parameter is used to execute like commands on the operating system. And so we have sort of like a backdoor, a custom backdoor that is hidden by a specific parameter that you can only access if you know the name of both of these parameters. Now, this example might seem like a far-stretched idea, like who would do that? However, some people actually do that. Like sometimes people put this sort of like debug backdoors that can, however, be abused by anyone because they do not handle the authentication process properly. So this is not authenticated. It does not ask me if I was the developer of this application. It does not ask me for any cryptographic proof or stuff like that. Once I discover the parameter, I'm inside. I can just get the host name. I can just get any information. I can leak the source code. So for example, if I can say cat var www html orders.php, what do we get? We get the source code of the application. So it's really, really simple. Before finishing the video, I just want to mention more scenarios. So once again, what did we do so far? We discovered the user ID parameter and we discovered the debug parameter, which led us to a remote code execution. So this sort of like parameter enumeration, parameter fuzzing, you could say, can be useful to discover stuff like that. Now, however, let's go back to just the user ID, right? So it says, look, I can get the order of the order list of someone, right? But in this case, the user ID is not correct. So the idea once again is what kind of value can I put in here, right? Well, in this case, what I do know from coding the application is that here it takes like an integer number, like for example 1 or something like that. Of course, I know this because I coded the application. In the real world, how should you approach this? The idea is that you try to use the application as a normal user and you just observe while using the application the kind of data that the application uses. So for example, if you have your own account with your own order list, you can observe, okay, what goes here? What goes in there? Is it a number? Is it like an identifier written like an hexadecimal string? So by observing the application, you get an idea of the type of data that that specific parameter is able to process, essentially. So in this case, I know it is a number. So the idea is that we have to find a specific number which allows us to get to see the list of orders. Now, how do we do that? Well, we can use Wfuzz or we can use Intruder. So in this case, we can also use Intruder from BurpSuite. We can say send to Intruder. And here we say, look, here I'm gonna put in this value here, I'm gonna put add this kind of thing. It says, look, I want to change the value of this, just of this. The attack type is essentially, the attack uses a single set of payloads. It places each payload into the first and places the same into all the position at once. I think sniper is good because we just have one payload that we want to test, essentially. So we do, for example, we do payloads. In the payload, we're gonna say like numbers. We're gonna go from 1, let's go to 1000, so that's 1000 requests, and we do a step of 1. It means that we start from 1, then we go to 2, then we go to 3, 4, so and so and so forth. So this is the idea. Then the resource pool, we can use the default resource pool, and I mean, this is it essentially. And okay, so we can just do this. We can just start the attack. Contains a demo, Bob Intruder is disabled, and attacks are time throttled. So as you can see here, it is extremely slow, and just to like finish this thing, it's not gonna happen anytime soon. So what we can do is we can actually generate this list of integer and use Wfuzz to perform the same thing, but in a much faster way. So in order to do the same with Wfuzz, of course, we need a word list, and this word list should contain, like I can call it numbers.txt. And this word list should contain all the different numbers that go from 1 to 1000, for example. In this case, it would be like this. So how do we do this? Do we do this manually? Of course not. We have to avoid doing things manually as much as possible. We can use bash. So the syntax for generating a range in bash is pretty simple. We can say for e in, then we can put the braces 0.1000, and then we can say semicolon do echo $I, and then we do done. If we do it like this, it's gonna print in a standard output all those numbers. So notice all those numbers in a standard output, and then by simply doing a redirect of the standard output into the file, numbers.txt, boom, we have our file, and this file now contains all the numbers of our interest. Perfect. Now once again, what do? Well, we can just use Wfuzz essentially. So we can just go here and use we can say Wfuzz, perfect. The word is gonna be like this, but now it's just gonna be numbers. So it's gonna be numbers. Let's not hide anything for now, and we're gonna put user ID equal fuzz. So now the fuzz, we're just gonna put it as a value of the user ID parameter. So if we run this, what do we get? We get a bunch of 260 essentially. So we want to hide also, hide 260. Let's see what we get. A non flag, because of course I did it too before. It should be like here. It should be after the word list. 560. Okay. So do we get? No, it's 559. 500. Let's see. 559. 558. So we get a bunch of different possibilities. Now notice this. While this so what's the idea here? Is that if you notice in the web application actually, so let's go to burp, let's go to the web application. So notice what happens here. We actually print the number itself. Now what does it mean in terms of content length? When we have one number, it's just gonna be 1 byte. When we have two numbers here, like 10, it's gonna be 2 bytes. When we have 3 numbers, it's gonna be 3. When we have 4, it's gonna be 4. So there's like a slight adjustment of numbers. Indeed, notice here it's like 228, 558, 561. While, so this is like small differences between this and this. While notice that for two specific cases, which are 1, 2, 3 and 2, 5, 6, we have a lot of difference. We have like, so for example, in this case, notice this, it's interesting, right? Because I was just looking at the numbers, and in this case, we should not filter with respect to the characters, but rather with respect to the lines. Because the lines, they only change, they don't change most of the time. So we can change hide lines, I can do 38, and now notice what we get. We just get these two, which have different amount of lines. They have 42 lines each. So this is like very, very, very interesting command. Gonna save it because I did not have it, but essentially that's the idea. And now, so what's the idea? What happens when we put 1, 2, 3 here? 1, 2, 3? Well, notice that we have the order list for this particular account. We have a specific item with a specific price, with the payment, maybe this is like a credit card or something like that. This is 1, 2, 3, and then we have 2, 5, 6, which has different items with different payments. So that's the idea. Now, this sort of vulnerability is called an IDOR, and it is an authorization bypass. This is like when the application does not authorize properly the clients. Now, in this case, we don't even have authentication, but the idea is that this data should be private and only the owner of this account should be authorized to view it, because only the owner of these orders should be view. They're like, okay, I paid with this card to get this, I paid with this card to get this is the price, these are the items. So like these are sensitive personal data, and the fact that we are able to access them just by understanding the ID of the user is called an IDOR. And this vulnerability is called an IDOR because it means essentially insecure, of course, direct object reference. So the idea is that since by understanding the ID, we can simply ask the web application to say, look, directly, give me the data for this user ID, and since there is no authorization check, which means that it is insecure, we have an insecure way of directly obtaining information regarding this specific account, which could be like, in general it's called object, but it could be like data, it can be like personal information, you know, like a lot of stuff. Maybe we can change the password given the user ID. Maybe we can do different operation. We can do maybe a bank operation using the user ID. We don't know, but the idea is that anytime by simply using the identifier for the user, we get access to sensitive information, or we can perform a sensitive operation on the behalf of that specific user, then we have an IDOR, which is a problem with authorization. So this is like a really cool example, and to discover it, what did we do? First, we generated a word list made up of numbers. Why numbers? Because I developed this application and I knew it was made of numbers. If you did not develop the application, you have to check how the application behaves, what kind of data does it use as values for these parameters, and then you can create the appropriate payloads to test out. And then we use Wfuzz. In this case, we did not filter for the amount of character, but rather we filter for the amount of lines. And with the query was like user ID equal fuzz. Now to finish off the video, I want to mention two more things. Let's say that something does not work and you want to debug the requests that are made by Wfuzz, and specifically you want to send them to burp. So here I have burp. I can play around with this request, so I can remove all the requests that I made so far. I want to fill this proxy history tab with all the requests that Wfuzz makes. Now, how do I do this? Well, the idea is to use a parameter called p. So I can use p. Actually, I can still hide for the amount of lines. And then I can say p 127.0.0.1.88 and then HTTP like this. Now, if I do this, so before we actually send the command, we have to go to the filter history and we have to remove this show only in scope items. So we have to remove this. We just say apply, so no filters. We press here and notice that our history here is filled with requests, where each request is made by Wfuzz. Notice this user agent, right? It's made by Wfuzz. And as you can see, we also understand much better the way it works. It simply makes many requests by changing this user ID field. It just changes this and it just makes many requests. So that's the general idea. Now, if you go back, for example, to the commands we used to discover, like let's say to the commands we used before to discover the bug parameter, for example. Yeah, this is good. And then here we can put -p 127.0.0.1.88 HTTP, and we remove everything that is going on here, and we just send it again. Once again, we're filled with requests, but notice now The difference is that the request is made with a different HTTP parameter. So what changes is the HTTP parameter after the user ID. So that's the general idea of parameter enumeration. Of course, it's not like super easy. It can be really difficult to do because many web applications have a lot of different parameters and a lot of different things to search for. Now, one last more thing before I actually finish is, okay, in this case, we just put a get. Let's say that we actually want to make a post, and let's say that we want to make a post with a certain body. So what do we do? Well, if we go to the Wfuzz help menu, I always suggest to do it, and we can say like method, specify an HTTP method. So to specify the HTTP method, we can use a -x, that's x post. So let's say if this works. Notice at the end, go at the end. Now we make all post, right? So now we make all post, that's good. So we can just clear this history because it's a lot. And now let's say that we want to put some like data in the body of the post. We can do this with the -d because look at this. I think it's like post data. Let's search for post data, post data, this -d. Use post data id equal catalog 1, for example. So we can say -d, we can put this data, and then we can just put it as before. So this I'm gonna save this command just to showcase in the final commands.txt that I will put for everyone. I can just send this, and now notice what do I get? I get a lot of requests, right? But now in the post data, I have id equal localcode, id equal link. So the values that are read by the word list are put within the value of the id parameter in the data, in the body of the request, not in the get URL parameter, but in the post www form URL encoded data. So that's the idea. Now, of course, this was just the beginning for this topic. I'm just gonna introduce you the basic idea, but there are a lot of things you can do. But I hope it was interesting. So in the next few videos, we are almost done with this series. We just need brute forcing of credentials and DNS zone transfer. And then we are officially done with the web exploitation series. I'm really happy for that. After this, we can talk about Linux. And that's it. To the next video. Hi everyone and welcome to this new video of my web exploitation series. So we are almost at the end. In particular, in this episode, we will talk about the brute forcing of credentials. Now, when we talk about brute forcing, the idea is similar to the ideas that we discussed in the enumeration episodes. So we showed how to enumerate files and directories, we showed how to enumerate virtual host, we showed how to enumerate HTTP parameters. Now, brute forcing is very similar to enumeration, but this time, instead of enumerating a resource like a file or a directory or a virtual host, we want to discover credentials. So credentials to authenticate to various services. So in this video, I will show essentially 3 examples. One, we will brute force SSH credential, then we will brute force FTP credential, and then we will brute force HTTP credentials. In particular, I will showcase 2 different scenarios for HTTP. One using the basic authorization header that HTTP allows, and another using a custom login implementation, and specifically we will brute force the login of the DEM vulnerable web application. Now, to do the first three brute forcing attempts, so the SSH, the FTP, and the HTTP with the basic auth header, basic auth, we will actually use a tool which is called Legba. So this is not your usual Hydra. Typically, even in the OSCP material, it's mentioned Hydra to brute force things. However, recently I've discovered this tool. It's called Legba. It's an open source tool developed by Evil Socket, which is an Italian security researcher. And this tool is really cool. It's fast, it's written in Rust, it's just modern. It's really interesting. So I prepare commands on how to use this tool for the brute forcing of credential. I hope you find the video useful. I hope in this video you can discover how Legba can help you. And that's it. Enjoy the video. So we can go into the folder of the video. So brute forcing, we go into content, we go into Legba. We will start with Legba. So as always, what do I have here? Here I have 3 different scenarios. The first one we will analyze is the SSH login. So here I have a Docker file, this Docker file, and this Docker file creates a really simple Docker container with SSH credential. So the idea is that this container will only expose an SSH service, and we will use this to test our tool. It's sort of like a custom-made lab. Now, how do we set up this login, right? Well, notice that in this Docker file here, when I'm actually setting up the password, when I'm actually configuring the password, I'm running this echo command. The user is the hard-coded string SSH user. However, the password is an argument that the Docker file computes at runtime. So the idea is that during the build of the image, we will actually generate a password. And this password will be taken from a word list, and then we will use the same word list to brute force it. But of course, the cool thing is that so notice here I have this symlink which points to the previous directory, to the word list directory, to password.txt. If I open this file, I have just a bunch of passwords. They are not that many, they are like 62. They were taken from, I believe, the rocku.txt passwords. So one of those files that you can find in your Kali distribution. So it's a very common file, it's a very well-known file. These were the first lines of that file. Now, what is interesting to us for the content of this video is this. The docker build command that I will use is docker build. Then I say build arg, so this is like a new flag we never used before. Then I say password. Here I do this shell escape, this $ with the parentheses. And then I say shaf n1. And then I say passwords. And then I say t legba lab ssh, and then I do dot so that the Docker file will be taken from the current directory. Now, if I run this command, it's gonna build the Docker image. Now, what's the meaning behind this build arg password equals and all this stuff? The idea is that during the build time, a random password will be taken from the passwords.txt file, and this command in bash, it's called like shell expansion. Essentially, this will expand to the internal, to the command within the parentheses. So if I just write shaf n1 passwords, notice what do I get? Mustang. I get one of the line in the passwords.txt file. If I repeat once again the command, I get another password, which in this case is password. I can repeat it many times. This is also fuck you, I mean this interesting password, right? If I just repeat it many times, I get different password. So that's the idea. When we build a Docker, we are picking one line out of the like 70 lines that are in the file, and we are using that as a password. This is to make sure that I do not know before actually executing the container, the specific password that has been chosen. So we can brute force it with legba. Now, we have created the Docker image. Now we have to run it. And to run it, we can do the following command. Docker run, rm to delete it and every time we stop it. Then I say network host to make sure that the 22 port that exposes the SSH service will be available in our localhost interface. So I don't need to connect port between host and the Docker. All ports will be shared. Then I do -t and then I say legba lab SSH, and then I say a dot. Actually, I don't need a dot here. So I can do this, and it runs the Docker in another shell. Now that the Docker is executing, the 22 port of my localhost is now open for receiving SSH connection. So to connect with it, I will do SSH user at 127.0.0.1. I don't need to specify the port because the default port 22 will be good, will suffice us because that's where the service is listening. Now, if I just run this command, notice what we get. Like this, the client, the SSH client is asking us and is saying, look, I cannot verify the authenticity of this host. This is the fingerprint of its public key. Do you trust it? Do you want to trust this or not? Actually, we do not want to trust this because this is just for like a small experiment. And then we will just trash this server and we don't care about that. So to avoid this saving, we can do this. We can do -o user known host file equal devnull. So that even if we save the key, it's actually gonna save it to the driver devnull, which will discard it essentially. So now we can say yes, perfect, and now we can give a password. So for example, I can say password. And of course, this is the wrong password. I can say password test. Of course, this is the wrong password again, because I don't know which among these 70 passwords is the one that was picked during the build time. So the idea of brute forcing is really simple. We will just keep making a lot of requests, each with a different password, until we find the correct one, until we find the one that correctly authenticates us to the service. So the idea of brute forcing is really simple conceptually. The idea is we will try a lot of different passwords, and if the password blocks us, like this, if we get a permission denied, then we discard the password. Otherwise, if we find the correct password, we tell the user. And this is essentially what brute forcing tools do. They just make a lot of requests. Now, of course, you have to be careful to do such attack on a real system, because the fingerprint of this attack, the fact that it can be easily recognized because you are generating a lot of traffic, so you have to be careful. But in this example, since we are executing locally, we don't really care about that. So we're gonna use the tool legba, as I said. Now, how do we use this? Well, the idea is that to actually use it, we can first download the image. We can do docker run it evil socket /legba, and we can say -h to download the container, and it gives us all the various options. So the first time it's gonna download the container. I have already downloaded it, so there's nothing too much to say about it. Now the next thing we'll do is we'll execute a Docker with legba, and we will execute a shell within the Docker. So once again, remember the previous video where I showed how to enumerate HTTP parameters. In that video, I showed how to use Wfuzz, and I was actually using Wfuzz inside a Docker container. I do this because it's easier to run it within a Docker container, so that I don't have to install all dependencies, I don't have to deal with building problems maybe, with the deprecation of old packages that this program uses but that I do not have installed on my system. Everything is handled inside the Docker, which is very, very comfortable, I would say. So how do we run this Docker? Once again, we do Docker run. Then we do entry point, and we say, look, in the entry point, I actually want a shell, so bin bash. Then we connect the folder, we do amount of folder, current directory with the data directory within the Docker. Once again, we do network host. This is important because the legba Docker has to be able to communicate with the SSH Docker. Then we do -et to make it interactive, and then we do evil socket legba latest. We do this, and we have a shell within the Docker, and now if we do which legba, we find our legba. We can do legba help, we get all the help menus and things of the sort. Now, how do we actually execute it, right? So legba is really simple. It has a really intuitive interface. We start with the mode of operation. So which protocol do we want to brute force? Because of course, for each different protocol, we will have a different flow of messages. So if we want to brute force SSH, we will have to generate a bunch of bytes, the ones that match an SSH connection. If we want to brute force FTP, once again, we have a different bunch of bytes. So the idea is that we have to repeatedly send all the bytes that perform an authentication attempt, a login attempt. In this case, it's SSH. Then we can do -- username. We say SSH user because it's hard-coded. Then we say the password. Here we put /data password.txt because this is the file that contains our word list. And then we put the target. So the target is 127.0.0.1, very simple. We don't have to specify the port. Why? Because the port is the default one by SSH. So we execute this. It starts to run. It tells us, okay, apparently it didn't work because it did not find the correct folder. So there is an error here, and the error probably has to do with how I executed this. So I think it's, let's say, current work directory /data. Okay, let's do the same command, but let's do word list, and then say /data. What about this? If I go into /data, okay, now I have the password.txt, so now I actually have the word list. And now if I execute, so legba ssh, username ssh user, password, data, password, and then I say target 127001. Let's say now it's reading all the password and it's trying all the password. Notice now that it's taking a bit of time because it's reading all the different passwords. Here we get a percentage of how much we scan the file and how many passwords we tried of that file. And if we wait a little bit, okay, look at this. It found a valid credential, SSH user Robert. So let's try with the credential found by legba. So we do SSH, then we do this thing about the saving of the host fingerprint. So we don't care about that. We say yes, whatever. We say SSH user. No, it's not the password is not SSH user. That's the user. The password is Robert, right? Because look at this. It says, look, these are the valid credential and this is the password. And now I'm gonna put the password into the prompt. And now I am inside. So I've brute forced this SSH login. And notice how easy that was. We just ran the command of legba. I mean, you should not do this on a server you have not access to, of course, because that would create problem. It's not a good thing to do. You would just spam someone of traffic, but it's really, really simple. And when you're doing maybe a penetration test, when you're doing a CTF, an OSCP exam and stuff like that, this command is extremely intuitive, I would say. I mean, look at this. It explains itself, right? I don't even need to explain it. It's the protocol, the username, the password, and the target. And notice here in the legba wiki, there are some other examples. So let's say that you have a different port, then you can specify it by doing a target, the IP address or the domain name. You do the colon and then you put the number of the port. This is another way using the SSH key-based authentication. So with the public and private key, you just say password and then you put here the path where you can find your keys. And then you say SSH auth mode key. So very, very useful. So this ends the first demo. So the first demo was trying to brute force SSH. Now I can just stop the container. I'm gonna use essentially, so this is legba SSH. I'm gonna say, oh, stop. So this was the Emacs interface for Docker. We don't care about that. Then we can go into the FTP directory. Once again, we're gonna do the same thing, but for FTP. So this is another configuration for FTP. And here is a link to the GitHub where I took inspiration. I simplified a little bit. Once again, notice this. We just say password and the password is taken from an argument. So how do we build this thing? As usual, it's the same thing. We just do docker build arg password. Then we say with the common expansion shaf-n1 passwords.txt. Then we say t legba lab FTP, and then we say a dot so that it takes the Docker file from this particular directory. It executes the Docker image. It says, look, I changed the password for the FTP user this time. So we can actually run the Docker. So we can say docker run rm to remove it. Name, we can give it a name also. Legba lab FTP, network host, DT. We can also do just T for interactive, D will be for daemon mode. But we don't care about that for now. So we can just use the shell. Okay, so let's see. I think here, am I inside? Okay, maybe we don't care about that. So we can say just D once. The container is already in use, so we can just close it, I suppose. We can just close it. Docker legba FTP. So I'm stopping now the container. It's taking a while. So now I stop the container so I can start it again. Okay, now I started it again, it ran, and now we can try to log in. How do we log in with FTP? With the command FTP. So we can say FTP 27001. It says connection refuse. Let's see why. Okay, now it works. I understood the bug. The bug was that I had commented this line. So I had to rebuild the image with the command docker build. So to build the image is this command. So it's docker build with the argument with the password taken from the file, and this is the name of the image. And after I've built the image, I can just run the docker with the docker run, with the network host, with the daemon mode, and that's it. So now the docker is running. I can connect with it via FTP. So I can say FTP user and I can specify a password. Of course, once again, I do not know what is the correct password. So how do I deal with this? Well, once again, we use legba. This time, of course, it's not gonna be legba SSH, it's gonna be legba FTP. So legba FTP, then we can say username, FTP user, password, data passwords, and we can say target 127001. Let's say if this works. Sometimes in my test it crashed the server, so that could be like we would recognize it. So notice this, I think it actually crashed the server or something. Yes, so the server is crashed. Okay, so now it worked before crashing the server actually. So it crashed the server a bunch of time. I had to rebuild it so that the password would be like one of the first lines of the text file. Now I don't know exactly why at some point this just like turns the connection and closes the Docker. This is like out of the time I have spent for studying this thing. But essentially these are the credentials. So FTP user and baseball. Once again, just notice how easy is the legba command and how intuitive it is. We specify the name of the protocol, the username, the password, the target, and it takes care of all the details. Of course, this is not as easy as it seems because there are a lot of details here that I'm skipping because of time. But essentially, for example, in this case, one would have to analyze why is the Docker crashing and how to reduce the number of queries and how to like limit the number of connection that the legba makes to the server in order to not crash it. So that's the idea. This is our second scenario. Now for our third scenario, we will build an HTTP server with the basic authentication method. So here the docker build command is a little bit more complex because we will actually do two things in here. So this is the command. Now in the password we will actually do this. And what does it do? This computes essentially an OpenSSL command, so like it hashes a password. So first we get the password, then we hash it. So if we execute this on our shell, we get here a bunch of hashes. So we can say echo this. We get a bunch of different hashes. So that's the idea, essentially. And then we're gonna build this thing. So we build this. Also, I think I can just stop the... Okay, no, I think I stopped it, right? Because it's just legba, right? Yes, it's just legba. So I've built it. And now I can run it. To run it, I say always run rm name legba lab HTTP network host legba lab HTTP. So this is running now. It's accepting PID, so we can just open a browser and go to localhost. So when we go to a browser and we go to localhost, here we're met with an authentication form. So we say HTTP user and we put a password. Of course, this password is not correct, and with legba we will find the correct password. So how do we do this? Well, as always, here we have our shell with legba, right? So we say legba http.basic username HTTP user password data passwords, and then we say target HTTP 127001. We wait a bit and look at this. It found HTTP user let me in, which seems pretty right? So now with the credential found by legba, we can say HTTP user on the username, let me in on the password, and boom, we are inside. We have found the correct password. So once again, how is the command with legba? It is extremely simple. Now before moving on to the final example in which we will write manual code to brute force a login, I just want to showcase just how simple this is. So notice all the legba commands that we use so far. So this is for the HTTP, for the FTP, I'm gonna put it up here, and finally for the SSH, I'm gonna put it up here. So it's pretty much the same, it's just that changes the initial protocol, but overall the logic is the same. It is very, very intuitive. So this brings us to the last example. So we can close all these containers. So we have essentially these containers. So this one we can just stop it It's stopping. Perfect. And now we can go into DVWA. Perfect. So now we have, what do we have here? As always, we start the WVA, the then vulnerable web application container. So we just do docker run and we have our application. Now, in terms of the login that we want to brute force is the initial login of the application. So specifically, I want to brute force this login. So let's say that we do admin password to just initialize the database. So I'm just going to initialize the database and then I log in, right? So what I want to brute force is this one, is this login, right? So how can we brute force such login? Well, it's actually not that hard. And here I have written the code. So this is the code for brute forcing the login. So let's try to read it. So this is Python code. We are using two libraries, the request library to perform HTTP request and the beautiful soup library to read HTML code. Because the idea is that between our client and the server, we will make multiple requests, one after the other. And from the response of the server, we will extract from the HTML specific piece of data. And so we need to parse the HTML, and to do that, we will use beautiful soup. Here we put like the URL. So we put HTTP, DVWA, login. We actually don't even need this DVWA, it's just login. We don't need the proxy. We put the password word list, username word list. So these are just files which contain a bunch of usernames here. I mean, there are not really that many, but this of course is just for test. And a bunch of passwords as always, taken from Rocku. So this is good. And then we have the main function, the check credential functions. This takes a username and a password and it checks if that username with that password is able to authenticate to the web server. How do we call this? Well, in the main loop here, in the if name equals main, which is executed when we call Python 3 login brute force. So when we do this, this thing is executed. We read all the usernames with this open read split lines. We read all these passwords with the same syntax, and then we iterate for each user and password. We check if the credential is valid. If it is valid, we print them and then we do an exit to exit the loop. So that's the idea. So how does this work? Well, the first thing is we're gonna have to make a request to obtain the CSRF token, so the CSRF code. So this is important because otherwise the next request will not be valid. So the idea is that we have to simulate a real client, and what does a real user do? First, it fetches the page with the GET request, and then it performs the login with the POST request. So this first request will simulate a normal client. Then from this request, we extract the cookie header. So we do from the headers, I want the PHP ID equals, I want to split it, I want to extract the values, and specifically I want to extract everything that comes before the semicolon. So I want the first value of this. So this is the idea. Then we sort of like initialize the parser with the text response. So with the body of the server response, we extract this token using the beautiful soup syntax. So we go into the input field, specifically the one where the name of the HTML has the value user token, and we extract the attribute value from this. So if we just check the essentially the HTML, look at this. So we just refresh the page. We just want this. So this is what we want. We want the input field that has the value user token for the attribute name. And then from the attribute value, this is the CSRF token, which is used to validate the second request, which is the request that actually has the credentials. So let's go back to the code here. So now we prepare the data for the second request. So we do username equal username, password equal password, login equal login, and user token equal the token. How do I know this? Because I've analyzed the request with BurpSuite. You can do it with any sort of login. You can understand the format and then you can just redo it in Python. And then we make the second request, which is a POST request. So we put our custom headers. So our custom headers contain the content type with application xwww form URL encoded to tell the web server, look, I'm sending you data, process it. And then we put the cookie. with the value that we found before, so that the CSRF token is validated, because the CSRF token is associated to the cookie value, to the session token that is used to like keep track of the session of the user. So we have to use the same cookie we got from the first response, and then we send a post with these custom headers, with the custom data. Here the proxies I can remove because we don't need that, and then I say, look, allow redirects false, which means do not follow redirect immediately, follow manually. So then we manually follow the redirects. We can remove this proxy. At this point, if we get login failed, we return false, otherwise we return true. Let's try to execute this. So what do we get here? I get Python login brute false. It says, look, here it says, okay, I need to remove this proxy. Need to remove this because we don't need proxy. And then, so let's say login brute force. Print found credential, login with force. So let's say print hello. Does it even work? Okay, but I'm not sure if it has the proper, let's see, login.php. It's login.php valid? Yes, it seems to be valid. Let's do localhost here. Localhost, login.php. Seems like it's not printing anything. Print user, print password. Okay. Oh, okay, I think it's because I've actually mistaken this syntax, actually. Okay, now it works. So before I had a list which contained another list, so this is why it didn't work. Now I just have a single list which is obtained with a split lines value. So now it found the credential and it says, look, admin and password is actually valid. And if I say admin and password, now it says the CRF token is incorrect because I have to refresh it, admin and password, and I am inside. So this is another example of how you can manually implement custom authentication logic to brute force a specific login. Of course, the same thing could be done with BurpSuite and also with Legba. So we could also use Legba to do this sort of exact same thing. I think it's useful to understand how you would write custom logic like this for maybe a specific login that you cannot automate it with a tool. So this is why I also wanted to show it in the end. But this is it for this video. I hope it was enjoyable. All the code and the commands you will find in my GitHub. So see ya to the next video. In the next video we will finally finish the web exploitation series by talking about DNS zone transfer attacks. So see ya to the next video. Hi everyone and welcome to this new video. In this video I will continue and actually finish finally my web exploitation series. So this is gonna be the last video, the 13th video, and in this video we're gonna talk about DNS zone transfer attacks. Now, DNS, this kind of attacks on DNS is not strictly related to the web because we are talking about a different protocol, about the DNS protocol. However, I wanted to include it on the web exploitation series because sometimes when we have to do a penetration test and we can interact with a DNS server, which could happen, for example, in an active box machine, in the OSCP exam, or in the real world. So anytime we interact with a DNS, this attack is useful to know, and it's also really simple to try it out. It's not hard, it's just a simple command, so it's more about the theory that is behind it. You just need to know about it in order to test it when you get the chance to interact with a DNS server. So I hope the video is enjoyable. We will do some laboratories to showcase the attack in a Docker environment, like I did in the previous example, in the previous videos, and that's it. And since this is the last video of the web exploitation series, in the future we can talk about different arguments, and specifically I want to start the Linux and the Windows series. So more OSCP preparation in different contexts. So I hope the video is enjoyable. If you have any feedback, please let me know. Please share this video, share the playlist, and just share my channel with the people you know who are also interested in learning this. And that's it, we can actually start the video now. So we can go into the directory, we go cd13 zone transfer attack, into the content. As usual we have a Docker compose file. In this case it's a single Docker compose file that calls a standard Docker file. So we don't need a custom Docker file because we will just use the default image of Ubuntu/bind9. Now, bind9 is an open source implementation of a DNS server. So this is really useful to have, and we can just start it. How do we start it? We can say docker compose app, and it's gonna download the image, and it's gonna compile, and it's gonna start the Docker. So now the Docker is running, and we can actually run the command. Now, there's not much to say about the specific command that we will use. It's really not that hard. However, what I want to talk about before showing the command is conceptually, what's the difference between a DNS zone transfer attack and a virtual host enumeration. And I want to discuss this because I think it can be confusing at first. So we have those two scenarios. So I'm gonna put a text mode here. We have like virtual host and DNS zone transfer. So when it comes to a virtual host, we have something like a base domain. So we can say oscp.exam. And then this base domain can be extended with various virtual hosts. For example, we can have a dev.oscp.exam, we can have a prod.oscp.exam, we can have a mail.oscp.exam, a secret. So we can have multiple subdomains from the same domain. Now, why these are related to virtual hosts? Well, these kind of things are related to virtual host when these are handled by the web server, which means by the HTTP protocol. So as I showed in the virtual host enumeration videos, if you can access different web servers through these kind of things which belong, maybe they map to the same IP, for example, they map to the same IP address, but they allow you to access different applications, different web applications. In this context, we are talking about virtual hosts, and they are characterized by the fact that they are present in the host header within the HTTP request. So in the HTTP request, you put here dev.oscp.exam or mail.oscp.exam, and by putting different values within the host header, you get access to different web application. So that's the key. Now, when you talk about the DNS and DNS zone transfers, the idea is that we can have the same exact strings, so the same exact domains and subdomains. However, they have a different meaning. So it's really critical to understand this. Syntactically, they look the same. It's always dev.oscp.exam, prod.oscp.exam. So at first, if you just have the string, right? If you just have the string, you can use this as a virtual host or as a domain name, but they are two different things. However, they are connected, and we will see it how. So the thing is that if you're talking about a DNS and a DNS zone transfer, the idea is that to each of these domain, thanks to the DNS protocol, there will be associated other information. And typically these informations are either other domain names, so other names, IP addresses, or TXT file, TXT like text, just raw data. So while virtual hosts use the HTTP protocol to handle different web applications, the idea is that this maps to a VHOST, so VHOST 1, VHOST 2, VHOST 3, and these are handled by the web server. So for example, they are handled by Nginx, which takes care of mapping. Okay, this virtual host is mapped to this application. This string is mapped to that application. So this is the concept of virtual host, while the idea of DNS zone transfer and DNS is that each of these string is mapped to another domain, an IP address, or a TXT file. So this means is that if you interact with a machine that has a DNS server running, you can do this sort of attack called DNS zone transfer. And the idea is that a DNS zone is a series of mapping which has the same basic domain. So like all the domains of oscp.exam are handled by this DNS server, which handles the DNS zone oscp.exam. When you do a DNS zone transfer, you are asking the DNS server, look, can you give me all your entries associated to this zone? Can you give me all the entries associated to the domain oscp.exam? If the DNS is not properly configured, it will not ask you for authentication. It will just give you the zone. So this is why it's called a DNS zone transfer attack. It is an attack because we are not authenticated. We are not supposed to have the information that tells us like, okay, we have these domains, because maybe we just know the initial domain, right? We just know this. We don't know that there exists a mail.oscp.exam. We don't know that. So like if we just have this, we can ask a DNS server, look, can you give me all the domains associated with oscp.exam? And if the server is not properly configured and it doesn't ask us for authentication, it's insecure, it can just give us this list. And you can say, look, dev.oscp.exam is mapped to this IP address. prod.oscp.exam is mapped to this IP address. And by doing so, we actually enumerate the domains and the subdomains of the application. Once we have those domains, then we can use the VirtualHost mechanism maybe to access different web servers. This means that a DNS zone transfer attack works in a different protocol, the DNS protocol. However, it allows us to enumerate the virtual host in a much smarter way, if this is possible, of course. Because remember, in the virtual host enumeration video, typically to enumerate virtual host, you need to have a word list with all the possible values, and then you check one by one if each of those values is valid or not. With a DNS zone transfer attack, if the DNS is not properly configured, we can just have straight the list, just straight handed to us. It's really, really powerful, but remember, this is a critical point, it uses the DNS protocol. So it's not regarding HTTP. It is a different mechanism altogether. So how do we do this sort of attack? Now, in this case, for example, I have 1337 running, so I have this 1337 running on my machine. So what can I do with that? This is the port of the Docker. Well, the command to perform a DNS zone transfer is dig. Then you write axfr to say give me all the zone. You put the name of the zone, in this case is oscp.exam because this is how I configure the server. You put -p1337 because it is the port that the DNS server listens to. Typically this is the 53 port, 53, but in my case it's a 1337. And then you put @127001 to say the IP address of the DNS server. So since I run the DNS with the Docker and the Docker is running on my host interface, on my localhost interface, I can do this. Once I hit this, notice what do I get. So this is the typical output of a DNS query. And in this case, the zone transfer was successful because we obtained 9 DNS records. What does this tell us? This tells us that this DNS server is not secure because it is supposed to ask for authentication, but we are not authenticated, we do not have any credential to do this, however we still manage to get the zone. This is highly insecure and should not be possible to do it in a real production DNS. So what do we get in particular? Well, we get every sort of record that was configured within the DNS. Now, some of these records are for internal use, like the SOA, which is like that determines the configuration of the DNS. Other are for the IP mapping. So, for example, these 4, 1, 2, 3, and 4. And what do they tell us? They tell us, for example, that dev.oscp.exam is mapped to this IP address, and that mail.oscp.exam is mapped to this IP address, and that, for example, we have uat.oscp.exam, which is mapped to this IP address. Now, this is extremely precious information because now we have information regarding some of the IP in the internal network of the server, and also some of the domain names used, dev.oscp, mail.oscp. Then we have, for example, this ns1, which is also another name server, and we have a lot of information. Notice also the mail server, this mail. So when we mail this domain, we get this mail.oscp.exam, and the ns is the ns1. And also we have a txt. So we have a txt record saying this is a secret. Of course, this is an example. I just put this is a secret. I wrote this line. But the idea is that we could find a lot of stuff, a lot of sensitive and private data that we should not have access to. So this is basically the idea. And essentially this covers this kind of attack. It's really simple, however, it is critical that you know it. Now, what can you do with these domains, right? Well, first of all, now you have information about the internal IP addresses and now they map to the single services. At this point, what you can do is, for example, you can test if there exists this virtual host within this server. So let's say that you have access to this IP address. Then you can try to access the virtual host dev.oscp.exam using this time the HTTP protocol. So even though DNS records and virtual host are different things, most of the time they are configured like to be sort of like to work synchronously. So this means what I'm trying to say here is that people, what do? They put the same value for the virtual host and for the DNS record. This is because when you go to the browser, for example, to dev.oscp.exam, what the browser does essentially is, first, it does a DNS query to get the IP address of the server, and then it uses the same domain value to perform a virtual host query with the HTTP protocol. So first, it uses the domain as a DNS value, and then it uses the domain as a virtual host value to actually connect to the proper virtual host. So now that you have this list, you can start to do the HTTP queries with the host field to, for example, dev.oscp.exam, and if there is a virtual host on that, it will reply to you like a web application, and then you can access maybe new applications that are vulnerable, you can find vulnerabilities there, and you can elevate your privileges. So this is the idea. Once again, I'm gonna repeat it one last time, and then I will finish the video. To perform a DNS zone transfer attack is really easy. You can use dig. Dig is the command to interact with the DNS. AXFR is to say, look, give me a zone transfer, I want a DNS zone, and DNS zone contain all the records for a given zone. Here you put the zone of interest, which in this case is oscp.exam, and then you put the port and the host, so this is the IP of the DNS server. Once you do this, it gives you a list of DNS records. These DNS records contain a list of subdomains. Once you have this list of subdomains, you know, first of all, the relative IP addresses, if there are TXT entries, what do they mean, and stuff like that. And then, after you have this, you can proceed with virtual host enumeration. And if you don't know what is virtual host enumeration, you can just watch my video on virtual host enumeration. So this is it for this video. This concludes the web exploitation series. As I said, it was a pretty fast video because this vulnerability is pretty simple. And in terms of like the configuration here, so just notice here that in my configuration, what do I have here? I have an extremely simple configuration where I say, look, this zone is handled by this file, and in this file I just put all these records. So this is how you use the bind9 open source DNS server to configure a zone. The problem here was that the DNS transfer, the DNS zone transfer was not authenticated. In real world, you should always authenticate stuff like this because otherwise you would leak sensitive data. So we are done. We are officially done with the web exploitation series. We've seen a lot of different stuff because, I mean, look at this. We've seen 13 chapters where the first were introductory, then we went into the attacks. So instead of doing enumeration, we went straight into the main vulnerabilities, which are SQL injections, directory traversal, file inclusion, file upload, common injection, and cross-site scripting. These are the main vulnerabilities, and typically for passing the OSCP exam, knowing these vulnerabilities will be enough most of the time, unless you really hit you hit a really hard exam set, but typically you are covered with this basic. And then we saw all the enumeration aspects with enumeration of files and directories, enumeration of virtual host, and enumeration of parameters. In the last two chapters, we saw brute forcing using the legba tool written in Rust, very efficient and fun. And in this video, we saw how to perform DNS zone transfer attacks using dig with an insecure DNS server. So this is it. Of course, I mean, there are other topics in this, there could be other topics in this series, but I'm ending it here so I can cover other stuff, because this is already a great introductory level. If you know all this stuff, you are almost ready for the web part of OSCP. Later, I'm gonna start to do Linux and Windows series, because those are really important topics in the context of penetration testing and security, offensive security. So I hope the video was interesting. I hope the series was interesting. If you have any feedback, please let me know, and have a good day.